Hello everyone, welcome to this data analytics course by Intellipaat. Did you know that according to a research, the data analytics domain is supposed to grow to a valuation of $279 billion by 2030? And let me tell you why you should be intrigued by these numbers. Because in 2023, the market size for data analytics was just sitting around $51 billion. That means from there onwards, within the time span of 7 years, this field grew almost 6 times and with a mind-blowing growth rate of 30% year on year. Now, if we talk about just within India, you'll find that there are around thousands of jobs available just on LinkedIn job board with an average salary of 7.5 lakh rupees. Plus, the skill can be learned by anybody. It doesn't matter whether you are a fresher or a working professional looking for a career switch. And it doesn't even matter if you are from a non-tech background, you absolutely can learn data analysis regardless. And on top of that, it's skill which almost every job role demands out of you. I mean, just think about the growing importance of data. Every click, every purchase, every behavior of yours is being tracked. Companies literally have virtual persona of you at their disposal to trick you into buying their products and services. They know what you like, what are your preferences, and what makes you tick. By leveraging this data, they are able to convince you into buying their products or services. Even the big monopolies, how they are recommending the things that you like on your search or social media feeds. How are they sending personalized emails about products that you really want to buy? Well, the answer to all these questions revolve around one and only one thing: data, data, and just the data. Now, marketing is just one simple, massive example. Beyond that, every department of business, every business process, or the decision that is being made is backed by the hypothesis supported by data. That's why data analytics has become an integral part of every job, every process. In recent times, if you have observed the job descriptions, you'll see that even for sales, marketing, finance, or development job roles, everyone is expected to have some sort of analytical skills. Skills that will allow you to make sense of the data which you are dealing with at your own level. And to exactly help you do that, we at Intellipaat have designed this free data analytics course. With this course, we are going to build strong analytical intuition within you guys, and to do that, we are going to work on almost 4 data analytics projects that will help you gain practical exposure. Once you are done watching this course, you'll be ready to apply for entry-level data analytics jobs. So let's get started by looking into the topics we are going to cover. We'll get started by exploring what data analytics is, its different types, and how the entire data analytics lifecycle works. Then, we'll understand the key roles and responsibilities of a data analyst and see what data analytics looks like with an example. Next, we'll dive into exploratory data analysis to uncover patterns in data and explore terms like inferential statistics, normal distribution, confidence interval, and hypothesis testing to make data-driven decisions. And we'll also see hands-on implementation of inferential statistics in Python. Then we'll go through hands-on sessions where you'll apply these concepts to real-world scenarios like churn rate detection, sport analysis, and time series analysis. So by the time we are done with these 3 particular topics, you will have 3 solid projects to upload on your resume. And finally, we'll wrap this session with interview questions that are most commonly asked in interviews at startups and MNCs. I hope you all are clear with the agenda. Now, before we get started, I want you to go ahead and enable both the subscribe button and bell icon for Intellipaat's YouTube channel so that you'll always land an update to more technical contents like this one. Alright, that being said, let's get started.
What is data analytics? Data analytics is the buzzword you would have heard a lot about in the recent years. To put it simply, it's the process of analyzing raw data to get insights and find patterns about the information. Using various techniques and processes, the raw data is transformed into a format which could be further visualized and be made human readable. To understand the definition in an even clear way, let's take a look at this example. John, who is a digital marketing professional, is running an online advertising campaign to promote a new smart television. John starts by targeting the group of people who might have bought the previous versions of the smart TV in question. As said campaign runs, data analytics comes into the picture through the data generated whenever people clicked on the published advertisement. Now, by inspecting the data about these users' interest and their buying patterns, you might come across that many of them are interested in streaming 4K UHD video. The reason behind this might be that the new smart TV has a better streaming quality than the previous versions. Using this information, you could tune in your advertisements to focus on users who bought the previous version of the smart TV and are interested in getting 4K streaming quality. This data can also be used to attract new customers who did not go for the previous version of the smart TV but are very interested in a better version of the TV. Why is data analytics significant? Businesses use data analytics to optimize and grow by making better business decisions and finding more efficient ways of doing business. The company can build new and better products with the buying patterns and better understanding what the customers need. So how do data analytics work? The data analytics process has some components that can help a variety of initiatives. By combining these components, a successful data analytics initiative will provide a clear picture of where you are, you have been, and where you should go. Generally, this process begins with the descriptive analysis. This is the process of describing historical trends in data. Descriptive analytics aims to answer the question, what happened? This often involves measuring traditional indicators such as return on investment. The indicators used will be different for each industry. Descriptive analytics does not make predictions or directly inform decisions. It focuses on summarizing data in a meaningful and descriptive way. The next essential part of data analytics is advanced analytics. This part of data science takes advantage of advanced tools to extract data, make predictions, and discover trends. These tools include classical statistics as well as machine learning. Machine learning techs such as neural networks, natural language processing, sentiment analysis, and more enable advanced analytics. This information provides new insight from data. Advanced analytics addresses what if the question. Data analytics affects every aspect of our day-to-day lives. You may not even realize it, but you probably use data analytics almost every day. Here are some of the everyday applications of data analytics. Social media stats instantly register anytime there is a visitor or a post to a page. Cell phone bills can pull up months of calling data to show you patterns of usage. Sensors monitor the changing weather and report that data to you instantly on your smartphone. Sports fans collect statistics on their favorite athletes and often use the data to form the term of fantasy leagues. Schools across the nation are involved in high-stakes testing that generates voluminous data on each student's progress. Educators then utilize data generated from extensive reports to drive their instruction. Data analytics is a growing field and will always be a top domain to get into. The average salary of a data analyst in India is 7 LPA and in the US it's $70,000. There are 27,000 plus data analytics jobs available only on LinkedIn, and there are very few skilled professionals to fill that gap.
Let's quickly see who is a data analyst in detail. A data analyst is a professional responsible for collecting, processing, and interpreting data to help business make informed decisions. Their key roles include identifying the data you want to analyze, clean the data by removing duplicates, handling missing values, and filtering outliers, and interpret the result of analysis to finally draw conclusions out of that. Data analysts play a crucial role in optimizing business operation, improving efficiency, and driving strategic decisions. There are 4 key types of data analytics. Descriptive analytics, which summarizes past data to identify trends. Diagnostic analytics, which explain why certain trends or anomalies occurred. Predictive analytics, which forecast future outcomes based on historical data. And finally, prescriptive analysis, which provides actionable recommendation based on the data insights. Now, talking about the job description, as a data analyst, key responsibilities include collecting and managing data, identifying trends, creating visual reports, maintaining databases, and collaborating with team to enhance decision making. A strong foundation in mathematics, statistics, or computer science is recommended to excel in this field. Essential technical key skills include proficiency in Excel, SQL, Python, R, Tableau, and Power BI, which helps in data processing, visualization, and analysis. Apart from technical expertise and analytical mindset, problem-solving skills and effective communication are crucial for interpreting data and providing actionable insights. The salary trajectory in data analytics is promising, with entry-level data analysts earning 4 to 12 LPA, mid-level and senior data analysts earning 8 to 19 LPA, and advanced roles like data analyst 4 commanding salaries ranging from 15 to 18 LPA or more. With experienced professional can transition into high-paying roles in data science, business intelligence, or machine learning. With experience, professional can transition into high-paying roles in data science, business intelligence, or machine learning, further increasing their earning potential. Data analysts are in demand across industries. In finance and business, they assess financial risk and investment, while marketing and e-commerce rely on them for customer insights and campaign performance. The technology and IT sector need analysts for AI/ML application and business intelligence, whereas healthcare and pharma use data analytics for clinical research and patient data analysis. Similarly, retail and supply chain industry utilize data analysts for tracking sales, inventory, and logistics, while media and government leverage analytics for audience engagement, gaming insight, and policy making. So to build a successful career in data analytics, mastering core skills such as Python, R, SQL, data visualization tools such as Tableau, Power BI, and Seaborn, and Excel is essential. Additionally, strong problem-solving skill and critical thinking abilities help in deriving meaningful insights from data. So if you are aspiring to enter this field, start by learning the right tool, working on real-world data set, and continuously improving your analytical skill. Stay curious, practice regularly, and embrace a data-driven mindset. Before starting with the PowerPoint presentation, let's go through the roadmap we will follow for learning how to become a data analyst. We'll begin with an introduction to data analytics, covering its types, roles, and key responsibilities. Next, we will build a strong foundation by developing essential skills in programming, Python and R, SQL, mathematics, calculus, probability, and statistics, and Excel. Once the basics are in place, we will move to core data analytics concepts, including version control with Git, big data processing with Hadoop and Spark, and advanced topics like machine learning with frameworks such as scikit-learn and TensorFlow. Lastly, we'll focus on data visualization tools like Tableau and Power BI. To solidify learning, we will also emphasize project building, participating in Kaggle competitions, obtaining certification, and networking within the analytics community. Now let's move on to the presentation part. Now let's look at importance of mathematics and statistics, which will take around 1 to 2 months to cover. So mathematics is the backbone of data analysis. It helps in identifying patterns, trends, and relationships within dataset. Key mathematical concepts needed includes calculus, linear algebra, probability, and standard deviation. Alongside mathematics, statistics play a crucial role in hypothesis testing, predictive modeling, and probability estimation. Important statistical concepts include median, standard deviation, hypothesis testing, linear regression, and sampling distribution. To build a strong foundation, it is recommended to spend 1 to 2 months mastering these concepts. Moving ahead with mastering Excel. Excel is a must-have tool for any data analyst. It allows for efficient data cleaning, sorting, and visualization. Pivot tables and formulas simplify complex analysis, while charts like pie, bar, and line graph helps in presenting data visually. Since businesses widely use Excel for tool insight, mastering it within 2-3 weeks is essential for beginners. Moving ahead with SQL, the language of data. Structured query language or SQL is one of the critical skills for data analysts, as it enables efficient data retrieval from databases. SQL helps in querying, filtering, and aggregating large datasets. Key topics to cover include database concepts, data retrieval, filtering, data manipulation, and aggregate function like sum, min, max, count, and average. So spending 1 month learning SQL will provide a strong foundation for working with structured data. Moving ahead with programming languages like Python and R. So programming language like Python and R are widely used in data analytics. Python with libraries like pandas and numpy is great for data manipulation and machine learning. On the other hand, R is preferred for statistical analysis for data visualization. So learning the basics along with the essential libraries should take around 1.5 months. Moving ahead with version control like Git and GitHub. Version control is crucial for tracking changes in code and collaborating on data projects. Git and GitHub help in maintaining a systematic approach to project development. And learning version control in 1 to 2 weeks will make teamwork and project handling much more efficient. Moving ahead with data visualization. Data visualization is a key for presenting insights effectively. Tools like Tableau and Power BI allow users to create interactive dashboard, while Seaborn and Matplotlib are commonly used for visualizing data in Python. A good data analyst should be able to tell a story with data, making it easier for non-technical stakeholders to understand trends. Mastering data visualization in 1 to 2 months is crucial for success in this field. Then we have some advanced topics such as machine learning and big data. For those who want to take their data analytics skills further, exploring machine learning and big data can be a game changer. Machine learning enables pattern recognition and predictive analysis, while big data tools like Hadoop and Spark help in handling large and complex datasets. Understanding the basics of supervised and unsupervised learning. Using framework like scikit-learn and TensorFlow is valuable addition to data analyst skill set. So the last step is to implement hands-on project. Learning data analytics is incomplete without hands-on practice. Working on real-world project helps in applying theoretical knowledge to practical scenarios. And 2 recommended beginner-friendly projects are sales data analysis and customer segmentation, both of which demonstrate problem-solving abilities to potential employees. A strong portfolio showcasing such projects increases job opportunities significantly. In conclusion, becoming a data analyst requires dedication, but by following this roadmap, you can build a strong foundation and develop the necessary skills step by step. Whether you're just starting out or looking to upskill, mastering these essential tools and techniques will set you for success in data-driven world.
On that note, we can come check out the type of data analytics that can be done in today's business, guys. There are a couple of types of data analytics, and I'll be walking you through the same. So the first type of data analytics you can go about doing is the descriptive analytics. With respect to descriptive analytics, again, the quick one phrase answer to what descriptive analytics is basically picking out data from a source, summarizing your data, making sure your data can be understood by everyone, that is picking out very good insights from your data, from all the past events, doing some predictive analytics on that as well, and then keeping it ready so your data is descriptive at the end of the day. And a question which goes by to understand the descriptive analytics is what happened in my business. So the answer to this question, what happened in my business, is given to by the descriptive analytics, guys. So most of the time the data which is generated by descriptive analytics is very comprehensive, it is extremely accurate, and the visualizations are very effective as well. So here's a very simple scenario that you guys can consider. So consider a scenario where an e-learning website decides to focus on a trending course according to the analytics of the search volume of the course content, which pretty much the users go on searching, and all of the revenue generated by the course in the past few months as well. So there are certain technologies, again, we live in a world full of trends, right? So let's say data science is in the boom right now. So pretty much any e-learning company, or any company for that matter, they're going to find these trends. They're going to know that, hey, data science is sitting in the top tier and we need to do something about it. If they have students in data science, then most of these companies are aimed at making the students' life better, right? So even as a firm here in Intellipaat, that's exactly what we do as well. We get this amazing insight from all of our learners for any particular course, and we use all of those insights, all of the feedback that we get, and what's trending in the market, what's latest in the market, and we use all of these to perform analytics. And then pretty much all of these helps us to put out a better course as well, guys. So at the end of it, you can already see how the descriptive analysis is already helping our business, right? And then the next type of data analytics we can check out is the diagnostic analytics, guys. So we already checked out what is happening to my business with respect to descriptive analytics. With respect to diagnostic analytics, you will check out of why this particular thing is happening to my business, guys. To simplify it again, it basically gives you the ability to drill down to the root cause of why something is behaving just like how it should, guys. So drilling down the data to identify certain set of problems which are present in your data or in the trends that the data shows is a very vital part of diagnostic analytics, guys. And then it basically helps in answering the question for us about why the issue has occurred, So it just takes one look towards the data, towards the analytic result of the data to understand what the cause behind a problem, if one should exist, as guys. So again, to give you a very simple scenario of how diagnostic analytics would work, let's say consider a company where the sales went down for a month. So let's say they weren't doing as good as the previous months. So to diagnose this particular problem, you will let's say consider the situation where the number of employees were quitting their job and they weren't bringing in a lot of sales. So this could pretty much, this number of people quitting the company could directly impact the sales that they brought into the company. So the sales went down this month because they did not have the company right. They did not have the sales right. So finding out why this is happening and hunting for that root cause, which is basically a treasure hunt with your data where you go on finding something and taking insights from your data. Finding out that why part of it is extremely important, where you'll be finding out what's happening to the data and why it's behaving this way, guys. So this again is a very vital part of diagnostic analytics. And coming to the third type of data analytics, it is predictive data analytics, guys. And as the name suggests, the quick question you'll be asking is what will happen in the future based on the past trends, guys. So hunting out historical patterns that are being used to basically predict all these specific outcomes using let's say machine learning algorithms, using deep learning, and using so many more concepts to predict something in the future based on the data we have now is again a very important niche of data analytics, guys. So predicting the future trends and the possibilities in the market based on the current trends is self-explanatory. And then it helps in optimizing all of the business plans for the future, because now your business has a direction to head to, right? So you're predicting certain aspects in the future and you know which path leads to better business strategies, right? And this will give you an edge over all of the other businesses as well. To give you a very nice example, think of the Netflix recommendation systems, guys. So this will basically use statistical modeling to analyze all the content that it's being watched by the audience across the world. So let's say there are a couple of TV shows which are very famous in India, but then there might be a couple of TV shows which is trending in the United States and let's say Australia, United Kingdom, so much more. Making sure that the right users in the right geographical area get to know the right recommendations are extremely important for Netflix as a business, right? So this again, predictive analytics will just do them good there, guys. Again, it will provide us with the prediction of all of the upcoming content and the shows that must be watched by all the different class of audience as well. So let's say someone sitting in the United States is very interested in watching an Indian trending television series as well. So knowing Netflix, finding out that this person exists and to recommend an Indian TV show for this person sitting in the United States to watch. Again, this is another very good business opportunity for Netflix. And then if they go about nailing their recommendation system for everyone, it just makes them a better business model, and then it just makes a better user environment for the users to go about watching videos there, guys. So the next type of data analytics is prescriptive data analytics. So as soon as we think of a prescription, again, we think of a doctor, we think of something, a medical appointment or something, right? Here it's again something similar. The question which will be asked here is what should be done? So applying advanced analytical algorithms to ensure that you make very good recommendations, you make sure you're punching out very good strategies that help the business and so much more is a very vital part of prescriptive analytics, guys. So it basically involves breaking down all of this complex information into a very simple set of steps. And these steps are like the prescription we handed out when we visit the doctor, right? And these are the prescriptions which are precautious as well, let's say. That the precautions basically used to remove any of the future problems that might occur, and it will also help in performing predictive analysis. This will basically help to predict outcome, and eventually that will help us optimizing business as well, guys. So this again demands the use of artificial intelligence and big data, and then the data analyst person will always be in touch with the data engineer as well and the data scientist as well, because he's going to need all the help he can get with respect to artificial intelligence from the data scientist, and help with respect to big data from the data engineer as well, right? So all these three guys working in correlation make up a business, and I've already told you that. So again, to give you a common scenario of how this would happen, consider the prescriptive data analytics that Google Map goes about doing, right? So every day we are commuting from our office to our homes, or let's say we're going on a vacation and then we need to get out of the city as quick as possible. So Google Maps has a wonderful API where they map out the best possible route considering live traffic conditions, weather conditions, road closures, and so much more. It considers your distance, traffic constraints, and again, as I already told you, it even considers if it's raining, if you're walking, what's the best route that you can take to walk, what's the best route to take if you're on a car. And now they've come up with the bike route as well. So if you're in a moped or a bike, you can take a different route compared to the person who'd commute with the car, and so much more. So knowing this kind of a prediction into the future, and giving you this sort of a prescription to ensure you don't run into any problems along the way is a very important part of prescriptive data analytics, guys. So on that note, let's quickly check out what the life cycle of data analytics is like. So the data analytics lifestyle, it basically defines the analytics process and all of the best practices, which goes on from the discovery of the data or the project till the completion of this project, guys. So there are a couple of steps involved in this life cycle process, and the first one is business understanding. At the end of it, again, understanding the purpose and all of the requirements that come from your business, and understanding it from the business viewpoint is very important and vital for the functioning of a business, right? This also consists of a very good introductory plan. It consists of a decision plan. It consists of a formal to-do list, let's say, for the business to go on to achieving the target. So the first important thing about the life cycle is the understanding of what's going on around you, and the second one is the data understanding, guys. With respect to data understanding, again, this mainly involves the process where we're collecting the data and we're processing the data in a way which leads to analytics. And then after the analysis of the data is done, we need to pick up some insights that we can go about using from the data. So extracting all of these meaningful insights from the data, again, is a very vital step in the life cycle of data analytics through data understanding, guys. The third part of it is data preparation. So data preparation is the let's say converting the data from an unstructured form to a structured form, and this involves constructing, let's say, a data set as well. And then this data set will be provided and fed into a model, and then this model will be used by a machine learning algorithm to train, to understand, to see what's going on, to perform predictions, and then it will be given to the data analyst to be visualized using Tableau or any other business intelligence tools, and so much more. So data preparation, again, is a very important phase where the data is actually being transformed, and even at the stage, the cleansing of the data is pretty much performed as well, guys. And then comes modeling. This step is very important because it involves the selection of various modeling techniques, applying all of these modeling techniques, making sure the parameters are right and all of the readings here are right to ensure that your data being converted into the information, raw data being converted into the information is of the optimal, let's say, it's of the optimal tolerance that can be used for your business usage. And then as soon as your modeling part of it is done, as soon as the techniques are applied and all the parameters are marked, then comes evaluation, guys. So evaluation is a very important phase where, again, the model which is being built, it will be built very rigorously, tested very rigorously based on what you've built in the initial stages, and then so many tests will be performed on this data as well. So evaluating something that you have generated, performing various tests on it is extremely important. Most of the time this is overlooked, but then these days everyone knows the value of evaluating your data, guys. So this again involves reviewing all of the steps that are again needed to carry out carry out to construct this particular model and to perform tests on it is very important. And with evaluation, that's exactly what we do, guys. So the next life cycle concept I want to tell you guys is deployment. Deployment is the last step in the in the data analytics life cycle, because deploying is when you're sending out your model into the world, for, let's say, by the world I mean, let's say, for your team, for your peers, or let's say even for your client and customers as well. So making your data go from just you seeing it all the way till spreading the data and performing spreading the data to your clients, to your peers, or anyone else. If you can perform more tests on these as well. So after deployment, you can have after deployment tests. If something is wrong, again, you can go back to modeling, perform more evaluation, perform more deployment as well. So the thing you need to know here is that deployment pretty much goes about to be the final phase of the data analytics lifestyle, guys. And on that note, we can check out very quickly what are the roles of analytics in various industries around us, guys. Again, data analytics has an amazing insight and impact when it comes to the telecom industry, because, again, if you've been observing, all the prices of, let's say, the calls, the messages, or the internet packs these days have been coming down and down. And there was a time when they were being exorbitantly high as well. So again, the telecom industry realized that if you keep the prices very high to make more profits, then eventually your customers will not come. They will not buy the internet packs. So to keep this in mind, probably they decided, let's say we're having a bad impact right now, so let's drop down our prices to see if it works. And it is, I guess. And this has helped the telecom industry in bringing better business. And for us as users, this has helped us just make it a bit economical and efficient on our side with respect to money as well. And then the retail banking industry, data analytics has a huge impact in the retail banking industry as well, to know what their customer wants. Because again, with telecom industry as well, they have a huge amount of customers to play with, right? So they need to understand the view of each customer, the requirement of each customers, and then to find out if all of the customers are actually in the common chain of what's being supplied by the bank, or if the customers are against something that's being sent by the bank. So that again is a very important thing that you need to check here as well. And then with respect to the e-commerce industry as well, to perform again some analytics in the e-commerce industry, it might be ad recommendations, or there are very big sales which are run by some of the big names in the industry such as Amazon, Flipkart, Myntra, and so much more. So these guys will have to perform extremely heavy analytics on the data that they see, based on the products that they sell, and based on the places, based on the city in which the product sells, or if the people are unhappy with the price. Again, performing analytics has just changed the e-commerce industry, if you may, guys. And the last most important industry where data analytics has touched is the healthcare industry. This has had the most impact with respect to analytics in the healthcare industry, with respect to so many things. Mainly it is with respect to finding out what medication is required by what countries, what amount of medication is working for what population, and so much more, guys. I can probably talk about just the roles of analytics in these industries for days together, and we can still be going on and have a very good discussion of how important analytics has become these days. Again, with respect to insurance as well, what geographical location requires insurance, what the audience are, and so much more. So again, as I've said, we can go on talking about this, but then to keep it to the scope of this tutorial, we can just quickly brief through each of these guys. So with respect to the healthcare industry, this is the formal way of going about analytics. The first one is to, again, analyze all of these disease patterns, analyze all of the disease outbreak that pretty much goes out. We had a disease outbreak a couple of years back, which is Ebola, and so much more. We had H1N1 and so much more, right? To keep a track of all of these outbreaks, this basically again improves the surveillance with respect to health, and then this gives out good responses to the emergency sectors as well, guys. And then development of better targeted preventive techniques, obviously, and then with the development of vaccines, making sure your vaccines again reach your customers, and all of these where you need to reach your customers, or let's say in this case the patients, are very important, guys. So identifying the consumers, again, in this is the greatest risk of business. So identifying certain customers or patients who are at the greatest risk is again, because they might be developing some adverse health outcomes and then developing welfare programs to keep a track of their health, to track their health on a daily basis, even a weekly basis, monthly basis, to perform analytics on all of the aspects and the parameters that you're tracking with respect to the patients. Again, that is a very important thing. And lastly, to ensure that they can reduce readmissions, because they might know what the cause of an adverse effect is. And if there are 10 patients with very similar symptoms, then you can perform analysis and you can at least filter out and find out that all of these 10 patients might have this one common symptom associated with them, and this might be the cause of that. So mapping that for every patient is again very important, guys. So coming to the telecom industry, again, telecom industry pretty much goes about using predictive analysis to gain all of the insights that they need to make better decisions, to make faster decisions, and to make more effective decisions. Again, as I was talking about the internet pack example, again, this was very key in that. And then by learning more and more about their customers daily and the preferences and the needs, these telecom companies can be more successful in this extremely highly competitive industry as well. It's good for them with respect to business, and it is good for us as customers by bringing down the prices again. So it is used for analytical customer relationship management. It is used for fraud reduction. It is used for bad debt reduction. It's used for price optimization, call center optimization, and so much more. So now that you're looking at data analytics in this way, you realize that data analytics eventually has a big play or has a big say when it comes to any of these business models, right? So again, coming to banking, as I've already mentioned, analytics is making banks become very smart day by day, guys. So it is managing all of the plethora of challenges that the bank faces, and then again, while pretty much going about doing some basic reporting all the way till descriptive analytics, and this is all a must for every single bank, right? Even performing, let's say, advanced prescriptive analytics or so much more, and all these are starting at this age. Banks have started to realize that this will again help you generate very good insights, and this will result in extremely good business impact, and it will help the banks as well. On that note, we need to check out how data analytics is helping in the banking industry as well, right? So it is used to acquire and retain customers. It is used to detect fraud, which is again extremely important with respect to banking. It is used to improve risk control, find new sources of growth for the bank, and to optimize all of the product and generate their portfolio models as well. So as soon as we check out the banking sector again with the e-commerce industry, right? So this is a market which is exploding for the last couple of years. I can say even the decade, right? eBay came up, Flipkart came up, Amazon is again taking over everything, Myntra, Nykaa. Guys, there are so many e-commerce portals today, and to make sure we perform very good analytics on these e-commerce industries is very vital. So how is data analytics used? Again, it is used to improve user experiences. It is used to enhance customer engagement, customize offers and promotions, maintain effective supply chain management, optimize pricing models, minimize the risk of frauds, provide them very good advertisements that pretty much help them pick up products, good recommendation systems where they'll pick up another product after the first product, guys, and so much more. If you've just bought an iPhone, again, you will pretty much be recommended with a couple of cases that the people have bought as soon as they bought another iPhone. So you might be that person, you might like the case and you might pick it up. At the end of it, you have the case to protect your phone. The business just created more money out of it, right? So again, the analytics, the role of analytics in e-commerce industry is extremely vital. Let's say the people in the e-commerce industry have known this for a while, guys. So coming to the analytics in the insurance industry, again, here as well, guys, this is basically used to enhance your customer engagement, acquire new customers, retain the existing customers, make sure the customers don't leave, prevent the frauds, at the end of it, reduce the frauds, prioritize all the claims that need, because you'll have medical insurance, you'll have again health insurances, you'll have life insurance, you'll have so much more that you need to take, and all of these directly impact the user, right? So making sure you take the feedback from the user, work on it, and then create some analytics out of it is again very vital, guys. So on that note, we can quickly come to our case study which I was talking about, and this case study is a very famous one. It's basically the house price case study, and here all we'll be doing is predicting house prices, guys. So we'll have a certain set of data which we will use to predict the prices of the houses. So basically, how can we predict the price of a house? There are so many things that you'll need to know, right? You'll be looking at the locality in which the house is present. You'll be looking at the amenities. You'll be looking at the number of bedrooms, the living space, the number of floors in your house, or the number of cars that can fit in your garage, the size of the garage, the quality of the construction of the house, if it has a swimming pool or not, if it has a spa or not. I mean, so many things. if we have to list down this particular use case, then it will be extremely tough, because each one of us has our own judgment of how we can validate a house, right? Because house is something that's very personal to us. Again, the materials of what was used to go to build the house, the style of the house which is built in, the number of if the house has an elevator, how convenient is the house for disabled people, guys, so much more. So basically we'll be performing exploratory analysis on this, guys. So exploratory data analysis again is used to find a hidden trend in your data by performing analysis on it, and then at the end of it the trends will be shown as numbers. But since we already know visualization, we're going to be pretty much using these numbers to visualize all of the data for us, and we'll be doing it step by step. So we'll be finding correlation between the data as well. So again, correlation is basically to check how one variable is linked and how the changing of one variable directly changes the other variable as well. So how these two variables are pretty much hung up together, how changing one variable changes the other can be known using correlation as well, guys. So a couple of steps that pretty much is generally followed in the case of performing exploratory analysis. First, we'll be visualizing all of our data, finding the missing values, and we'll be looking for correlations, guys. And then after this is done, we'll be cleaning the data to check if any issues are fixed, or if we'll be checking out if the data that we have is pretty much being used fully or not. And then we'll go about building a model which is used to visualize our result. It will give us the diagnostic, it will give us the residual diagnostic, ROC curves, charts, graphs, tabs, tables, and so much more, guys. I do not want to basically overwhelm you with the use case. So to keep this use case very simple, we'll just perform exploratory data analysis at this stage to find out correlations between the data. And as soon as we go about progressing with respect to our data set and to work with, you will understand how beautiful data analytics is, guys. So let me quickly jump into Google Colab, which is basically a Jupyter notebook hosted on the Google Cloud. And here we can go about performing our data analytics on the use case that I just walked you through. So we're going to need a couple of files to run our use case. We'll actually need one file, which is our training dataset file. Let me just quickly add the file to our Google Colab, and then we can go about proceeding performing our analytics, guys. Those will just take a second to upload the file. Give me a second. We just actually need one file from out here, but then it doesn't harm to upload it and keep it in your runtime. But then you just check the message, right? So pretty much all of your files are recycled as soon as the runtime is pretty much changed. So the first step for our use case is to load all of the necessary files and the libraries that we require, guys. So the first, again, we'll be using pandas to handle all of our data. We'll be using seaborn and matplotlib to perform plotting operations on all of this data, to perform visualizations on all of these data. And the style that we'll be using is pretty much called as the BMH method. And with respect to the BMH, again, BMH is nothing but the Bayesian method for hackers. And this is just a type of a graph visualization method, which gives us graphs which look nicer, and then it helps us to perform analysis better on linear data sets, guys. So the second thing we'll be doing is, again, loading all of the necessary files. One of the important files we need is the training data set, which is this. And here you have the ID of the houses, you have the subclass of where the houses is present, you have the zone in which the house is present, what is the area of the frontage that you have, what is the area lot of your house, what is the street, what is the alley, again, lot shape, lot contour, what is the year the house was built in, what it was remodeled in, what is the size of the roof, again, so many conditions out here. What is the foundation made of? How is the quality of the basement, condition of the basement, the exposure to the basement, again, finishing type of the basement. Guys, just look at how expansive this data set is. This is, again, a data set which is extremely popular among us analysts, where we pretty much like to work on this, because it consists of everything and you can perform so much on the single data set and so much more, guys. So on that note, let's quickly find out the information of all the variables that are present. Again, since I was just working, if the housing has heating, how is the quality control of the heating, does it have centralized air conditioning, how is the condition of the electricals, what is the square footing of the first floor, square footing of the second floor, what is the low quality finish, that's and how many square feet of that do we have, what's the living space area, how many full bathrooms do we have, how many half bathrooms do we have, kitchen quality. Guys, this will go on, right? So all these data is what we need to check out. Again, if you see here, all of these are the values that are present which will help us map something. But then alley, again, doesn't have many values. You can check out here itself, right? So alley, it's NaN is basically not a number. So there are not many, alley or details which we can make analysis out of. So we will not require alley. Again, coming down, not much of fireplace quality as well. We do not have pool quality control at all. Miscellaneous features are very less. Again, even fencing is very less. So the average is somewhere around 1400, right? So to make sure that are cleaning up our data, very important part of it is to basically how we go about doing it again. We'll just remove all of these data which are less than 30%. So less than 30% of, again, 1460, and then we can have at least 70% of the data to give us some accurate results, right? So as I already checked, alley ID, not every house has an ID, so that's removed. Not every house is mapped to an alley. Pool quality control is not there. Fence is not there. Miscellaneous features are very less. So we have dropped all of these columns, and we'll not be using these to perform our analytics, guys. And so again, to describe what goes on to do a distribution, I hope you guys know this concept about normal distribution, and with respect to all of the details that we can get out of it when we perform the math operation, guys. So basically we can count the total number of data that's present with respect to all the individual data. What is the mean sale price of the data? What is the standard deviation? Let's say the mean of the normal distribution is right at the center somewhere here, guys. So the mean is somewhere around 18,000, right? I'm sorry, this is 180,000. If you just keep tracing from the center point down, this is somewhere where 180,000 exists, guys. So again, what is standard deviation is basically the deviation from the mean. So what is there are house values which deviate from this mean as well. Again, 25% deviations, 50% deviations, 75% deviations, and then what is the maximum sale price of the house as well. So all of these can be found out from this particular graph, guys. And if you can already observe, and even if you're not exposed to a normal distribution, this starts out as a very steep curve, but then it ends out with respect to a lot of data here as well, right? It goes on until 800,000. So basically probably from 5,000, or let's say even 400,000 all the way till 800,000, we call these as outliers. These are called outliers because these are very far away from our normal distribution, and then these actually might not be useful for us with respect to our mean or whatever, and these will impact a lot when we are performing analytics with respect to the mean or the standard deviation or anything for that matter. So we will have to actually remove them and not consider them to basically perform very accurate analysis, guys. So on that note, we can pretty much go on to finding the type of the data set and the type of the data that we'll only consider, because in this particular case, since we're playing with numbers, it has to be the numeric data type, right? Again, as you can check out, we have integer numbers, we have floating numbers, and so much more. So let's pretty much go on to print what it looks like after we have dropped the values where we're not using ID, we're not using alley, we're not using so much more, right? So these are all the numerical values that we'll be using to pretty much consider. Again, year built is a numerical value, 2003 is a date, a year, overall condition, overall quality, all these can be rated from a particular scale, right? So again, a square footing is a particular number as well. So the second floor of this particular house has 854 square feet, so much more. So on that particular note, as soon as we check out all of these numbers are present, we can start performing an analysis, guys. So before that, again, we need to just plot all of these to just check what it look like on graphs, because seeing numbers are one thing, seeing graphs on the other hand are something else, right? So pretty much we'll be developing histograms and we can be checking out, guys. So let me just scroll down a little. Yeah, perfect. So with respect to first floor square footing, the mean is somewhere around here, right? So it's around, let's say 500 square foot, 1000 square foot. And again, look at second floor square footing, look at the bedroom average, basement finishing qualities, garages, so number of cars that you can park in the garage, and look at the value here too. So the majority of the houses here have 2 spaces to park your cars. The year that the garage was built in. Again, the ground floor living area, how many half bathrooms? So you can see 1 half bathrooms. Again, at this point of time, you have certain values at 0 as well. Well, sure, we can consider values of 0 if it's very important, but then since we're talking about sale price, what is present is more important than what is absent, right? We need to have something descriptive for our analytics methods to work. So in that case, we'll have something called as the golden features list, and this variable will basically contains all of the features that we'll be associating with respect to why our sales price is as high as it is, guys. So this variable called as the golden features list will have all of the features, guys. So basically we're creating a variable where we're finding out the correlation, and then we can already check out the top 10 correlated values which are strongly correlated. By correlated, again, let's say let me give you a quick impact. Basically, we have described this in the descending order, as you can already check out. So the first thing here is overall quality. Again, to transcribe this into literal terms, overall quality of the house, whatever the rating that was given in our data set, is mattering the most of how the houses is being priced. Again, the living area of it, the number of garages you can park is having almost 64% impact of with respect to why the price is like that. Garage area is having a 62% impact. The basement square footing has a 61% impact. And then the year it was remodeled and changes made is having a 50% impact of why the house price, the sales price is like that, guys. So looking at a couple of linear relationships, you can pretty much find out that a lot of values are zeros that I just walked you through a couple of seconds. And look at that. With respect to our, again, the ground floor living area, we have a very little number of zeros. With respect to the sales price, again, check out the basement surface area again. With respect to the total basement surface area, again, even here as well. So look at all these tiny dots which are sticking up to zero with respect to the sales price. So these have no impact for our sales price because they're not giving us any valid linear data. Look at this again with zero. Oh, it is raised up to a lot, about $600,000, right? So all these are not adding any meaning to our data. So if x is equal to 0, again, this might indicate that that house does not have that feature at all. So if this is 0, this house does, a lot of houses do not have pools here. So pool area is 0. So in that particular case, we need to remove all of these zeros so that we can go on to finding more correlated values that we can actually use to go about working with it. Guys, again, here's all of the correlated values that we found as soon as we ran this command. Basically, we are sorting it again in the descending order to find out what helps most. And you can see that it's almost 80% of the total quality of the house, which matters when you're buying because of the price of the house, and people are actually preferring this. Living area, second floor surface area has a 67% chances of affecting the price and so much more. And check out what the golden features list looks like with respect to all of the strongly correlated values we just found. Again, you're remodeled, you're built, so much more. So total surface area, again, number of full bathrooms, the first floor surface area, the garage area, total basement square footing, the number of cars you can park, the square footing of the second floor, the living area, and the overall quality. Again, in this particular order from the least to the highest is exactly what we're trying to find out with respect to exploratory data analysis, guys. So just looking at the data set, you could never figure out why the list price of a house was so much. And once we break it down into simple terms like this, we can find out that there is an 80% impact from the overall quality of the house, which the user is checking out to just consider the house or not. If the quality is very less, he will not pick up the house. If the quality is higher, then sure, he will pick up the house. So 80% of the reason why the price is set like that is a very important aspect of why the house price casing study is important, guys. Again, this has been a very important, very nice data set to work with, and you will get a lot of analytics that can be done using this particular data set as well, guys.
Just a quick info, guys. Intellipaat offers data analytics course training. Through this course, you will master Power BI, data wrangling, data mining, and much more from the IIT Roorkee faculty and industry experts. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take the first step towards career growth in the field of data analytics.
Interesting, right? The first few steps that were performed in the hands-on file are known as EDA or Exploratory Data Analysis. This technique helps us find patterns, spot anomalies, and understand relationships between variables. In the upcoming section, we'll understand EDA in detail, first by understanding the theory behind it, and then a hands-on implementation on the Metro Cities data.
So what exactly is EDA? EDA or Exploratory Data Analysis is an approach of exploring the data in a way where you are able to gather few insights from the data. These insights may include the pointers that best explain the distribution of the data points, peakness, and other necessary information like relationship between each of the variables in the data. You are able to identify the underlying patterns which you may not be able to identify just by looking at it. You are able to remove the redundancies like null values and outliers. The idea is to use the processes and tools available to us to make sure that no stone is unturned when it comes to exploring the data. The main objective of the EDA is to understand which kind of solution, or if we are using the machine learning approach, we are going to use to solve the problem. This practice gives us enough room to decide the outcomes based on findings while doing the EDA. Now that we have a vague idea about what exactly is exploratory data analysis, let's go ahead and look at why it is so important for any aspiring data scientist to be thorough with the concept of EDA. So when we discuss the importance of exploratory data analysis, we have to cover some points. First of all, EDA helps us uncover underlying patterns and trends in the data that are not visible by just looking at the data. So let's say if you're looking at any data which is related to insurance companies, you might not be able to find the patterns in how the people are paying their premium just by looking at it. And when it comes to EDA, it will help you identify those patterns and actually work on those insights. Next up, EDA can highlight useful relationships between the data points to gather insights. Now, taking the example of insurance data again, we can actually find out how and why people are paying their premiums on time, or what are the different parameters which are holding them from paying their premiums on time, etc. EDA also helps in restructuring the data according to the problem statement. Let's say we have to create a prediction model against some data that we have to know how we are going to structure that data. Do we need the outliers? Do we need the null values? Or do we actually need to standardize the data for further computations? So that is where EDA comes into the picture. And last but not the least, EDA helps in removing the redundancies from the data, which I have already mentioned, the outliers and the data imputation techniques that we are going to use to replace or either remove the null values. Now that we have a clear idea of what exactly EDA is and how it is very important for us to learn about the exploratory data analysis, let's go ahead and check out the steps involved in the exploratory data analysis. So the steps involved in the EDA starts from how you load the data into your program. That is where your actual EDA begins, and that is the first step of the entire cycle also. Once you're done with loading the data comes the data visualization, where you use the data visualization tools. For example, if you're using Python, we have matplotlib, we have Seaborn, we can use Plotly to derive different plots from the data, which is going to explain the distribution, the peakness, and other important points like outliers, etc. Then we can also find out the relationship between different variables using data visualization. Next up, the third step is data imputation, where we are going to figure out how we are going to replace the null values or how we are going to deal with them basically. So let's say if we have a distribution which is a normal distribution, we can just simply replace the values with mean. If we don't have a normal distribution, let's say if it is positively skewed, the distribution, then we can replace the values with the median, or otherwise if the presence of null values is very minimum, or let's say less than 5% of the entire data, we can just remove those values or drop those columns. Now moving on to the next step, that is the outlier analysis. With EDA, we are able to do the outlier analysis also. We can identify which features has the outliers, and we can also analyze and basically remove those outliers. And if we want to keep them, we can take a decision on that as well. So that is also covered in the EDA on repeat. So that is also covered in the EDA. And last but not the least, the fifth step is gathering the insights. So from all these steps that we have performed, we have to come to a conclusion that our data has several insights. For example, let's say if I am analyzing the IPL data like we have done in one of the previous sessions, what we have done is basically carrying out an entire EDA on that particular data, and we have found out the 10 best players of that. Repeat. We have found out the 10 best players from that entire data. So similarly, we have to gather insights from the data, and now that we have actually understood the steps involved, we have understood the importance and the basic definition of EDA, let's move on to the hands-on part where we are going to perform the EDA on metro data using Python. Before that, let's just quickly take a look at the problem statement. So we have the metro cities data, and we already know that subway system or the metro trains that we have in the various countries has been there for civilizations and has been helping the modern civilization to commute in everyday life, and it is a very big network all around the world. So we have gathered that data, and our job is to identify the underlying patterns by performing EDA, where we are going to use Python on the metro data. And in the end, we are going to gather a few insights from the data. So let's also take a look at the data set, how we have all these features: city, country, name, year last expansion, stations, length, kilometer, annual ridership, mil, and region. So we have also described the columns here. So city is basically the name of the city, then we have the name of the country, the name of the metro, the year it was built, and the year when the last expansion happened for that particular metro, and then we have the number of stations, the length of the entire network in kilometers, and then we have the annual riders, which is in millions, and last but not least, we have the column with region, which is basically nothing but the region where it is located in. It could be North America, it can be Europe, it can be Asia, or it could be Australia, and then we have Latin America as well. So we'll quickly go to the notebook and perform EDA. So let's get started, guys. All right. So this is our notebook that we have created. Increase the visibility here. So as you can see, we have already imported the dataset and we are using the Google Colab for this. You can perform the same on Jupyter Notebook if you like. It's up to you guys, whatever suits you better. So we are going to be performing EDA using Google Colab. So first of all, we have to load the dataset, and we have imported all these libraries. Pandas, because we are going to be using data frames here. NumPy for basic few computations. Matplotlib and Seaborn for visualization. So loading the data is very simple, guys. We can use the read.csv function over here from Pandas module and with the file name. If you're using Jupyter Notebook, you might have to give the directory over here, and you may find out that you're facing a few errors importing the data. But don't worry, guys, you can reach out to Intellipaat and we'll be happy to help you with this problem. And then with this, we are basically done loading the data. So the very first step that I'm doing over here is getting the name of the columns. So data.columns give me the column names. So we have city, country, name, year last expansion that we have discussed while discussing the description of all these columns in our data. Next up, we have data.info. So info is going to give me the information about, as you can see, we have 3 columns here. One is having the column name, basically all these names. Then we have the number of values and how many of them are non-null. So as you can see, we have 198, repeat. As you can see, we have 198 values over here, which are all non-null. The data type here is object for 3 columns. Then we have integer. The annual ridership is in float, and then we have object again. So we might have to change these data types if we are going to perform some linear regression, let's say. So that comes after we have gathered the insight or before we are preparing our data for the modeling. So that is also one of the things that we can cover in the EDA, where we look at all these data types and figure out which one needs to be converted to, let's say, integer. Now let's go ahead and check the shape of the data with data.shape. So we can see we have 198 by 9 is the shape of our data over here. We can check the dimensions also. So checking the dimensions helps you when you are performing, let's say you have a data which has 64 dimensions, then you may have to perform dimensionality reduction over there, which will help you in preparing your data for the modeling. And that is why checking the dimensions is also one of the good practices when you are doing EDA. Alright, so this is the part where we describe our data. So first of all, what we are doing is we are getting the first 5 rows in our data set using the data.head method over here. As you can see, the first 5 rows in our data, we have the cities, we have the country, the name of the metro, the year it was built, the last time it was expanded, and then we have the stations, the length in kilometers, annual ridership in million, and then Africa. So we have a lot of variables here which are not integer or float type. So what we are doing is we'll describe the data, but we are not going to get the values for those particular columns. Like if you can see over here, the describe method does not fetch us the count, mean, standard, minimum, 25 percentile, 50 percentile, 75 percentile, and maximum. For the columns, city, country, we don't have name over there. We won't be having region as well. So we have only got the year last expansion, the stations, length kilometer, and annual ridership. So this is one pointer that you can make a note of. Whenever you're using the describe method, it is not going to get you the values which is not in the type numbers, basically, which is integer, float, it could be a complex also. But if it is an object or a string data type, it is not going to get you these values. So describe is actually one of the methods which is quite useful while doing the EDA. So I can, for example, let's take this column, stations. So we can know what the count is, we know what the mean is, we know the standard deviation, we know the minimum, and there's a 25th percentile, that is a 50th percentile, then we get the 75th percentile as well, and the maximum also. So we know for sure the highest number of stations in the entire data is 424, the lowest is 6, and the mean value for all these metro stations is 68. Similarly, we can have the numbers on length kilometer. So the highest is 49,039 kilometers, and the lowest is basically 12 kilometers. So the metro station with the lowest network, or the lowest range of network, is 12 kilometers only. And then again, we have the minimum of annual ridership. So there is a station which does not even cross 1 million commuters every year, and the highest is 2834 million. So that is quite a number. So this simple 5-point summary you can get from describe method. So this is very crucial when you are doing the EDA for any data. You get the basic idea of how your data is. And then again, what we are doing is getting the unique values for region. So let's say we have this column region over here. So we can get all the unique values using the unique function over here, and we are printing those. So the number of unique values is 6, and the values are Africa, Latin America, Asia, Australia, Europe, and North America. Let's say if we wanted to narrow down our analysis only to one region, we can segregate the data based on this value and then perform our EDA on that particular set of data. So that is why we have done that, and we have done that same thing for countries. So we have 59 countries that has the metro network in our data, and these are the country names. And then again, if you do that for the cities, so 187 countries from the world in our data has the metro networks or metro trains. So this is a very simple finding from our data, which you can say in these 6 regions, 59 countries have metro stations, and out of these 59 countries, 187 cities are there. So that is our initial finding from the data. Now when we move on, let's check the distribution plots for each parameters. Now we are using Seaborn over here to create a distribution plot. Now distribution plot will tell you a lot about your data. Basically, it will give you if it's a normal distribution or if it is positively skewed or negatively skewed. So if you take a look at this data, this is negatively skewed because we have a lot of values towards the end of the distribution, and that is how we can estimate or basically interpret this data. So most of the metros were built after 1975, we can assume that, and the first ones were built somewhere around 1900s or before that in very less numbers. When we take a look at the next plot, which is about the stations, this is also a skewed data, not a normal distribution. So most of the metro stations are in numbers 0 to 100, and only a very few metros have stations more than 200. So these are the findings we get from visualization. That is why data visualization is a very important aspect of performing EDA on any data. Now visualization can be it can be of any sort. You can find out the distribution, you can find out the relationship between the variables, you can find the outliers. So these are 3 basic things that we'll be covering in this session. But visualization is not just limited to finding out the distribution or the relationship. You can actually get beautiful insights or create dashboards using Plotly, or you can create a beautiful dashboards using Power BI and other tools available to you in the market. But we are only going to be using Matplotlib and Seaborn for this session. There's a surprise in the end where we'll be covering something interesting using Plotly. So hang on there if you are waiting to learn something new today. And moving on, there's another distribution plot where we are checking the distribution for the annual ridership. So there again we have a skewed data, and most of the ridership or the annual ridership falls between 0 to 500 million, and only a few goes until let's say crosses 2500 million annual riders. And then we go on to check the distribution of last year expansion. This is also skewed, and we can clearly see that most of the expansions happened after 2000. So that is how you easily find out the distributions here and make quick assumptions about the data using these values. So from these few plots, I know that most of the stations or the most of the metros that are located in these cities, countries, have has less than 200 stations, were built after 1975, and the annual ridership is less than 500 million, and were probably expanded after 2000. So these are the insights I have gathered so far. Moving further, I checked the distribution for the length of kilometers, and this is where it gets interesting. So mostly all of the data falls under 10,000 kilometers. So that is where our distribution is not very helpful. So we'll be taking a look at this particular parameter while checking the box plot so that we can get a clear idea about how the data is distributed. Now we do the outlier analysis with box plots. Now box plots is not just about finding out the outliers, which is basically whatever values we're getting outside this particular line over here. These are the outliers, but we can get the median values, we can get the percentiles over here, which is the IQR range, minimum and max, and these are the whiskers. So these are the values, and we can clearly see that year is negatively skewed. So we hardly get any, what do you call it? So we can hardly get any normal distributions in this particular data that we are handling right now. So there's no normal distribution. So let's say if we are going to use this for linear regression, we might have to scale the data so that the standard deviation and mean is actually normalized, and that you can check out in other sessions where we have covered linear regression, guys. Now coming back to our session, we have gathered some insight on the outliers for the year column. Now what we'll do is we are basically going to get all the values before 1925, because that's where our outliers lie, before 1925. So we are taking a rough number here, and then this is the data for all those metro stations which falls under this range, the outliers basically. And we have created a few plots over here, the visualization plots, to understand this data, the outliers. So we have a bar plot over here where X is the number of stations and Y is the city. The hue we have taken as region. So if you take a look at this, blue is represented by Latin America, orange is in Europe, and North America is denoted by green. So by looking at this plot, I can clearly say that most of the metro stations that were built before 1925 were built in Europe. So that is how I can make an assumption or an interpretation from this plot. And only a few were built in Latin America, and the other ones, the other majority falls into North America. And this also shows that New York has, let's say, New York has been mentioned twice over here. So that is why we get the line over here in this bar plot, multiple values. Now let's move on to the next one. Next bar plot is the length of kilometer and the city. Now I can make assumption about these because most of the metros that were built in Europe has a length of kilometer which is higher than everybody else, which falls under London. So my assumption from this plot is the metro station built in London or the subway built in London has the length in highest numbers that were built before 1925. So like this, you can make assumptions about the data. So these are the findings that we are gathering through this EDA. Similarly, we have another plot where we are checking the annual ridership. Then again, I can make an assumption over here that Paris, or the subway or metro station that was built in Paris, has the annual ridership in millions in highest numbers, which was built before 1925. So that is how you gather all the insights on the data. And this is basically what we are doing with the outliers. We're just checking the values of the outliers over here. And then again, we can also create the histograms over here where we have added the hue as region again. And there we have done the same thing. You can figure out the number of stations fall under the Europe region that are in the highest numbers. And surprisingly, North America has more than 400 stations. That is basically the highest over here. Annual ridership, if we check for this, that is 639 million. Alright, so I actually want to correct myself. It is not Paris which has the most number of stations. It is New York City, guys. One second, let me just correct myself. Yes, it is New York City that has the most number of stations. Alright, so let's move on. And similarly, we have done that for length of kilometers and annual ridership again. And same thing we have done for every column. We have checked the outliers for year last expansion, and most of them fall before 2005. So we have taken the number as 2000 over here. Anything built before 2000 we have over here. And we do the same thing. We check the annual ridership. We check the number of stations. We check the length of kilometer, and then we provide some histograms to get the better idea of how the number of stations looks like. There we have Asia again in this, and so we can also make a conclusion that most of the metro stations that were built in Asia started after 1925. So that is one assumption. We can get a clear number on that when we check the very first metro that was built in Asia. And this is how we can gather a few insights on the outliers. Now moving on, we have done the same for length in kilometers also. So anything after 2000, let's say, or 2300 we have taken over here, is falling outside the range, which is the outliers, and we have all these metro stations. Most of these falls under China, guys, and we have done the same thing. We have created the histograms for annual ridership. So annual ridership falls majorly in 0 to 500 million, and then we have the number of stations, which also falls majorly in 0 to 50, let's say 0 to 70 stations. And the histogram shows for length in kilometers according to region. So we have most for Asia because most of the stations are in China. That is why it all looks blue, guys. And if you take a look at Europe over here, we only have two cities, Madrid and London, which shows the length in kilometer. And this basically is where we can conclude that so the largest network of trains exist in Asia. So this is the conclusion from our analysis over here. And then again, we can check the annual ridership and all these things. So we have done the same thing for stations also. We have taken all the stations more than 200 are going to be in the outlier section. So we have all these cities over here. We have done the same thing again, plotted a few bar plots to get the clear idea on length on kilometers. So I think Delhi tops the chart over here, and then we have the number of stations. I'm sorry guys, this is the length in kilometers that we're talking about for Delhi. So that is the highest for any city that has more than 200 stations. And if we check that for number of stations, the most comes with Beijing and Shanghai. There is Paris from Europe, Madrid, London, and New York City. So I think New York City is the highest. Then on the second place we might be having Shanghai, and then we have Beijing also. Then we check for annual ridership. The hue is region over here again. So we have Asia, Europe, and North America. Surprisingly, we do not have Latin America in this. So probably Latin America does not have the metro network which has more than 200 stations. So that we can conclude. And similarly, we have created a few histograms over here, and it is dominated by the Asian region for annual ridership, for stations, for length in kilometers. Number of stations actually is shared by North America, where New York City tops the chart. And then again, we have a box plot for annual ridership, where everything after 500 million is an outlier. So we have segregated the data based on this, which is greater than 600 million. That's going to be in our outliers list. So that is how we can analyze this data, check the annual ridership, which is highest in Shanghai. Similarly, Tokyo also has a few concerns over here. And then we have Beijing. Then we have Delhi also, Moscow. Mexico City from Latin America is also there, and then North America we have New York City. So majorly all the regions are here. Only the Australian region is not present over here, but let's carry on. And then when we check for stations, then again Beijing, Shanghai, Seoul, and then we have Mexico City from the Latin American region, and New York City, of course. It's topping the chart again here, which we already have concluded. When we check for length in kilometers, first of all we have Delhi, then there is Xi'an, Moscow, Mexico City again, and Sao Paulo is also there from Brazil. And alright, so when we check the histograms, there we can see the Asian region dominating the charts over here. So this is why we have used the visualizations to get beautiful insights from the data, which we might not be able to get just by looking at the data or just by inspecting it. Like if I just take a look at the 5 rows or the entire rows of the data over here, I might not be able to fix or gather a few insights related to this data. But through visualization, I was able to do that. Now moving further, let's talk about how we fix the outliers. So I'll quickly give you a preview of what we have to do for that. So handling outliers is not a very big task. Like most of the times we can leave the outliers in the data because they might help in reaching a conclusion, because they are very useful information, the outliers also. Like for our metro data again, we might not want to do this because the information that we get from outliers is extreme but is important because those are facts. So this is just an example of how you can get your data fixed or remove the outliers. You get the IQR range, which is the 75th percentile minus the 25th percentile, and these are all the IQR range for every column. For year it is 36.75, for year last expansion is 7, stations is 69.75, length kilometers, and annual ridership. So what you can do is basically replace the values with this particular thing where anything above or beyond the range, the IQR range, we are going to replace it with that. So we are going to skip this part because we want to keep the outliers so that we understand the data better. And let's also check the number of null values. Since we do not have any null values in this particular data, what I'm going to tell you is how you can replace them. The first option is always to drop the null values. Then again, you can fill the null values with 0 or with mean or with median if you don't want bias in your columns, because if the distribution is not normal, you can replace the column values or the null values with the median. And then again, if it's object data type, you can replace the values with the mode, and that is how you can treat your data for data imputation, basically replacing the null values. Moving further, to understand the relationship between the columns, what you can do is basically plot a few scatter plots, and you will get the idea of how your relationship in between the columns is. So let's say if I wanted to quickly summarize or use this entire data to decide the annual ridership, what I'll do is check the relationship with all these values or all these columns with annual ridership, so that I get a clear idea if length in kilometer is going to affect the annual ridership, if number of stations is going to affect this, if the region is affecting this particular value, or if the last expansion that happened has affected the annual ridership. That I can find out by using the scatter plots. So scatter plot between the stations and length kilometers is showing a considerable amount of increase, but not that great. So we can't really say it has a linear relationship. But for stations and annual ridership, it clearly shows a linear relationship, not exactly that strong, but it just shows that there is a relationship between these two variables. Then again, if we check for length in kilometers and annual ridership, it's not exactly that strong, but we can say it's gradually increasing. So there is a clear sign of increase, but not that strong. When we check for year and year last expansion, it's not really great. We have taken the limit from 2000 to 2022 because most of the expansions happened in that time. Similarly, for X limit also we have taken that for length in kilometers. And when we check for year and stations, this also does not show a considerable amount of relationship. So this does not actually show a very good relationship between the two. For year and length kilometers also, there we can't find any considerable amount of relationship. And then again, if we plot all these subplots, these are the subplots that you can get: annual ridership with respect to built year, annual ridership with respect to stations, annual ridership with respect to expansion, and length. So length shows somewhat linear relationship, and the number of stations also show. So these two variables or these two features in the data are going to be very useful for us if we go for a linear regression model, let's say. So these two will be able to decide how our data looks like and how we can actually predict some of these values. Since we have not used any of the object columns, if we do a little bit of hot encoding or label encoding on that, we might be able to find out relationship over there as well. So you can take that up as an exercise. So I'll tell you 2 questions you can solve. Convert the object data type in this particular data into an integer data type, or perform label encoding in that, and find out the relationship between those variables and the annual ridership column. So that is one exercise you can take from this session. And then again, if you just want to get the relationship easily, you can just use the pair plot, which gives you all these plots with respect to each of the columns. And with the annual ridership in millions, we can see 2 columns that are showing considerable amount of linear relationship. And we are going to conclude with that. We can add the hue as a region also, where blue is Africa, then we have orange, which is Australia, Europe is in green, Latin America in red, North America and Asia. So if we check over there, the extremes are on the Europe over here, number of stations, and length in kilometer is in North America, the extreme. That is how we can visualize the data, guys, to gather insights. We can also create a regression plot. So annual ridership and the 2 columns that we have gathered, which is station. So the best fit line is over there, and here the error we can reduce. And same again, if we plot this for annual ridership in million with length in kilometers. So that is how we plot the regression line also. Now to sum up this session, let's also do a little bit of region wise analysis, and also a little surprise for you, where we have used a few pie plots using Plotly. So that is something that looks interesting and gives you a better picture of the entire data. Alright, so we get the unique values, which is all these 6 regions. We segregate the data based on all these regions. We're using the data.loc or loc, where the region is equal to Africa, Latin America, Asia, Australia, Europe and North America. Now what we're doing is we're using Plotly for sunburst, which looks like a pie plot, but it actually opens up when you click on these. Alright, so just to quickly give you a review on this, we'll go to the Asian and let's check for Latin America first. So this is sunburst, which is going to give us the clear picture of the entire data or the entire metro network in the Latin America. What we have is all these countries. So these are countries, let's say. Alright, I'm sorry guys, these are not the countries. So we have only used the region, the city name and stations. We have not used the countries. I'm sorry guys, these are not the countries. So if I click on Caracas, we have the Caracas Metro, and which has 52 stations, and the annual ridership in million is 358. Let's go back. Let's check for Medellin, and we have the Medellin Metro, which has 27 stations, and the ridership in million is 115. So I can check that for every city that we have in Latin America or in Africa. For in Africa, we have only one city, which is Algiers Metro, which has 19 stations and 45.3 million annual ridership. So this quickly summarized all the data based on regions. So that is how I have segregated the data. If we take a look at Rio de Janeiro, we have the Rio de Janeiro Metro, which has 41 stations, and the annual ridership is 118.7. Now when we have a lot of cities, we have a lot of these columns. So what we can do is we just check for the number of stations over here. Let's say we go to Seoul. Seoul has 2 metros. We have the Korail metro lines, which has 86 stations and 426.4 ridership in millions. And then we have the Shimbodang line Neotrans, which has 12 stations and 122.5 ridership in millions. Then in Asia, we can check for other cities. Okay, let's go to Istanbul. So we have the Istanbul Metro, 107 stations. There might be there's Manila over there, which has the Manila Light Train System. Repeat, the Manila Light Rail Transit System, and number of stations is 33 and 218.2 million ridership. Alright guys, so that is all about how we can create a sunburst. So in Bangkok we have BTS SkyTrain, the Metropolitan Rapid Transit, 53 and 60 stations, annual ridership 236.9 and 95.3. So we have Bengaluru also, which is Nama Metro with 51 stations and 174.22 million riders or commuters every year. We have Hyderabad Metro also, which has 56 stations. And these are all the summary of all the cities that has metro in the Asian region. St. Petersburg is also there, the St. Petersburg's metro, 64 stations and 495 million. So that basically gives me a summary. Then we have for Australia with Sydney Metro has 13 stations and 12.9 million users. And then we have for Europe, Milan, Munich, Vienna, all these values, the Lisbon, Warsaw, Minsk, and we have Prague, Kiev, Rome. So for Kiev we have the Kiev Metro, which has 52 stations and 279.5 million riders every year. We have for Lisbon, the Lisbon Metro, 56 stations and 184.6 million riders every year. And Barcelona we have for Vienna actually has Vienna U-Bahn, 98 stations with 459.8 million annual ridership. So if we take a look at this Warsaw Metro we have, and similarly we've done that for the North America also. So we have Montreal, Toronto, Vancouver, Washington DC, and there's Miami also. So a sunburst is something that you can use to get a clear picture of all the data points in your data set. Now last but not least, I want to talk about the data correlation, which gives you a better picture of all the variables that are going to be correlated to each other. And if we check for annual ridership in million, we can see stations and length in kilometers is showing a positive correlation, where stations is actually showing a strong positive correlation, whereas length in kilometers is not that strong but is considerably showing somewhat correlated values over here for annual ridership.
Just a quick info, guys. Intellipaat offers data analytics course training. Through this course, you will master Power BI, data wrangling, data mining, and much more from the IIT Roorkee faculty and industry experts. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take the first step towards career growth in the field of data analytics. Now that the first process of data analysis is clear, let's dive deeper into the mathematical part like normal distribution, confidence intervals, and hypothesis testing, all of which will be used in the algorithms that will be covered in the later stages. In the end of this section, there will also be a practical implementation on the topics that we just discussed. So let's get started.
Think first, what is the difference between statistic and statistics? So descriptive is done, so I think I can ask this, right? What is the difference between statistic and statistics? Anil is like telling, come again. Let me write it also. I'm just finding, oh, I got my pen. Okay, let me write. Statistic versus statistics. Any idea, anybody? Don't Google it. This is the first question I asked when I talk about statistics. If you observe, there's just one extra letter S in there, right? That's the difference in the spelling, not in the concept. So anyone, statistic can be a single piece of data. So guys, I think, see, so this is a question out of syllabus, right? You might say, you have done this statistics and not sure what is this, what is that, right? So I think this is a more like a teacher's way of testing where the unexpected question might come. So see, statistic, I think Soumya, what you have mentioned in the chat, you are close. Statistical technique. So in case someone is wondering, he suddenly jumped into the concept. The reason is that I have taught this batch. Okay. Statistical technique like Z-test, T-test, chi-square test, right? All these are your statistic. More like it's an approach, it's a method within the universe of what? Statistics. Statistics is a subject, right? Isn't it, guys? So statistic is more like a method or approach, a technique which you apply on a set of data which you have collected over a period of time. You have done some transformation. You are going to analyze with the help of these tests. Okay. Let me give you a couple of things and let's see, understand you few things that what is your understanding of descriptive statistics a little bit more so that I can use some of those things in inferential. So I'm just making sure. So tell me one thing, if I talk about salary, right? And I have a very good diagram for that. So you must have, this is the time, by the way, guys. So those who have been to engineering colleges or typically I would say IITs, December is day one. December 1 is day 0 for them. So this is the moment I am sure my juniors will be getting placed, right? So this is a bell curve which I put together, and you might be seeing something coming in the news, right? 1 crore package. Let me tell you, I have been asked this question a lot of time. 1 crore package is a myth, or more like it's a misinformation given to news media print to get some footage or mileage. Uh, Definitely, some of the guys, maybe 1 or 2 or 3 people in a batch, they get 1 crore, but that's all in dollar. Means it's not in India, it's in US or likes of US. So converting dollar into rupees and then telling you are getting a package of 1 crore, the people forget that they have to spend in dollar. They'll not take a flight, come back to India and spend in rupees. Understand my point? So 1 crore package is okay, right? It's not like that. It is beyond imagination. Okay, so don't worry about it. In India, hardly anybody gets as a fresher 1 crore package. If some company is giving, they're idiots. The company owners or the board is idiot. Okay, doesn't make sense. Now come back to this amazing curve. Okay, let's understand quickly, guys. So definitely you can see this is a skewed distribution. And as you can also see, I've already written it's a right skewed. Anybody? Why it is called right skewed? Why is it called so? Very good, Anthony. That's correct. Because it has a long tail, on the right side. Some of the guys will be wondering what is that long tail. Let me highlight, you will see it. Can you see the distribution is going like this, has a long tail. This is what we say long tail. And the peak is on the left hand side. So it's a right skewed. Okay. Now you must have been taught when the data is symmetric, when the data is having a shape like this, the distribution. So then mean, median, mode, all are going to be at the same place. Remember? Now, when the data is skewed, then there is an issue doing mean here. Okay. So far with me, guys, doing mean here. And what is the reason for that? Because mean is sensitive to outliers. I hope must have been taught this, right? Mean is sensitive to outlier. And this is a very, very common concept. Are you guys aware? Mean is sensitive to outliers. Let me show you if you're not. Tell me one thing. I've also written some packages. Okay. Let's say this is not 51, by the way. This is 5 LPA. Let me write clearly. As you start laughing at me. 5 LPA. Let's say most of the guys are getting 5 LPA. That becomes, if you think this is your, this is the peak of the salary, you can say like mock or mode. So this is the highest value which you see in the normal distribution. So that's your highest frequency value, which means it's the mode, right? Or you can say close to median, but it cannot be the average. You know why? Because of these guys who are sitting somewhere here, can you see this? Who are sitting here, they are going to impact the average. Are you able to follow, guys? Let me give a simple example. So let's say these are your salaries, 3, 5. I'm taking some numbers in LPA, lakhs per annum. 50 and 80, let's say. So let's say these guys' salary, if you want to find, and this is all in LPA. So if you do the math, what is the mean salary? If someone can do this for me, you will get to how much? Do the maths, guys. Anybody who can help me out here? And I think I have 3, 6, 9, 10. So what is it coming, guys? Did someone do? 81.5. No. Soumya seems to be close. How can be 81.5 average? Only two values are 50, 80. Please check your calculation. 18.2, so many people are telling. So let's say that's the average. Okay. I have not done myself. Right? But if you observe closely, most of your data distribution is not even higher than 10. Right, guys? Can you see this? Just because of these two guys who are like the IITs, that media guy who are getting this high package, has impacted your overall salary. Guys, so far with me? Why don't you do that? If you exclude these outliers and do this maths again, add these 8 salary only and divide by 10. Oh, sorry, divide by 8. How much you are getting, guys? I think it will be close to 6 or 7, 6.5. Okay, thank you. Those who are helping me. Do you think which one looks more closer to reality? This one or this one as an average salary? Definitely 6.5, right? Definitely 6.5. So you understand when I say mean is sensitive to outliers. And that's the reason people say whenever you are looking at a data with outliers, you should not go with mean, you should go with median. Now, why don't we find median for this one? So just arrange 3, 4, 3, 4, 5, 6, 8, 10, 11, 50, 80. 4, 6, 8. I missed one number. I think 5 is 2 times, right, guys? Okay. Aryan, what are you asking? Such a silly question asking why 50 and 80 is outlier. Now tell me, guys, what is the median? So I'll come to you, Aryan. 2, 4, 5, right? So what you will do, my dear, you will take first 4 and second 4, last 4. So you will be left out with what? These two guys. Hello? What is the average? I'm damn sure you must have been taught how to calculate median. So what is the average of these two? I'm not going to teach that. I'm just making a... Now tell me, looking at this number and this number, which one is more realistic? Mean is more realistic or median is more realistic to the average which you might have thought. So now you understand. So that's why if you see, if some apps like Glassdoor or some similar like PayScale, if they report average salary, you should not never go with that. Because let me also tell you, there are students who are coming from ISB and all, and they're getting 30 lakhs as a fresher salary. And then there will be students who are coming from normal college, and they will be getting 3 lakhs or 5 lakhs. So 30 lakhs guys, if you keep taking right blindly, you will be in a wrong, means you will in a bubble that thinking, oh, I am also going to get 30 lakhs. So just to just to bust this thought that it doesn't work like this. Okay. So does it make sense, guys? Now coming back to Aryan, outlier, identifying outlier, treating outlier. Okay. So remember I had taught you guys box plot. Okay. So box plot says that if something is in, I'm just more like, revisiting few things. So Aryan, If you do a little math and try to identify an outlier, you will be able to do that. So now my question is, did you guys go through some of those examples where you identify the outlier and got treated and treat the outlier already, right? So generally, this is in response to the question Aryan asked. I don't know, Aryan, if you're there in that session. That's why you might be asking outlier. Can you see these? There are two on the upper side and two on the lower side. We have outliers. Okay. So there is a statistical way to calculate these whiskers known as whisker. I have also talked about it in my visualization. Let's say this is your upper threshold. So guys, I'll not repeat it. I'll quickly write the equation. So you take the Q3 and then you add the 1.5 times. Statistically, this number has been given to you, this whole formula. You do the interquartile range, which is Q3 minus Q1 and multiply with 1.5. Anything which is greater than this, like these two guys, are going to be outlier. Similarly, you can also do lower threshold. Just refresh your memory. So that will be Q1 minus 1.5 IQR. IQR is interquartile range. Anything lower than this lower threshold, like these guys, are outliers. And you can also make a little sense out of it. If someone is getting, outlier means little something unexpected or weird, right? Everybody is getting 5 lakhs, 6 lakhs, 10 lakhs, and somebody is getting 80 lakhs. Definitely that is an outlier. That's a normal way of saying it. So outlier means which is not normal, which doesn't fit in normal scenario, is an outlier. Literally, I'm trying to explain. Mathematically, this is how do you do that. Now, guys, I'll jump to one question. And if you have been taught normal distribution, you should be able to take it, because then you must have been taught jet score as well, or no? So then what did you guys do in normal distribution? There's no normal distribution without jet score. And without the normal distribution jet score, I cannot go into inferential. So it's a prerequisite. Okay, so remember, there's a bell curve, okay? Standard normal distribution. Let me do the thing. Okay. So one of the key distribution is normal distribution, also known as bell curve. Bell's curve. I hope my spelling is correct. It has gotten a name, bell curve. Anybody knows why it is? Because if you go to a temple, right, and have you seen a bell, right? The normal distribution can be, shown as a bell curve. Okay. And here you go. Now, if you look at the normal distribution, okay, most of the thing in the world can be modeled as a bell curve. Trust me on that. So that's what I was telling, right? If the normal distribution is symmetric, your mean, median, mode all will be on the same point. Okay. So ideally, when we talk about standard normal distribution, you make sure that it is symmetric, it's not skewed. Okay. And if you look at the top one, not the bottom one, the top one, you must be seeing that I have given 3 colors. One is, between mu plus minus sigma. So I hope you know what is mu, what is sigma. So this is going to cover how much of your data? 68.27%, right? And then if you look at the from mu plus minus 2 sigma, 95% of the data will lie in there. And if you go and stretch it further, mu plus minus 3 sigma, 99% of the data will be there. So you might be wondering, why do we need normal distribution, right? And why mu plus minus sigma is so important. See, this is what has been found or observed on a normal distribution, because it's all about probabilities of what data will lie in where. So if you take any normal distribution curve, you can always find mu, which is your more like expectation of X. Don't go into this. It's a random variable. I'm damn sure you don't know. So expectation of X is generally written as mu, which is your, you can say mean, but it's not real mean, because mean of deterministic data is your average. But this is more like expected value of X. So I'm going to write expected value, and the moment expectation comes, it's probability. Okay, then you also have sigma, which is your, you know that, right? Standard deviation, which is square root of variance. Now, what we are saying that if you take a range of mu plus minus sigma, 68, I'll say roughly, 68% of the data it will have, plus minus 2 sigma, it will be 95% of the data, and mu plus minus 3 sigma, 99% of the data will lie there. This is the reason the professors or the college universities professors, they use this like a lot. So suppose they fit on a normal distribution on your to calculate grades, right? So what happens, guys? Let's say, and definitely it will not be like symmetric. This normal distribution can be skewed. So they know that. So we have a mean somewhere here. So this is going to be mu. They know that in this there will be some sigma. So this is mu plus sigma. This will be mu plus 2 sigma, and this will be mu plus 3 sigma. And let's say this is mu minus sigma. Are you following, guys? And then they create bands. So this is going to be their favorite student, which is maybe 1 or 2, who is maybe 1 or 2, right? And they will be getting, let's say, A plus grade. Then they'll go to the next band, which is mu plus 2 sigma to mu plus 3 sigma. Focus, guys. So all those guys who are here, they are going to get, let's say, grade A, grade B, grade C, grade D. Hello? And everybody who is behind this are going to get what grade? F grade, which is a fail grade. First of all, this is just a high-level overview of how grading system works. It's not that straightforward, by the way. This is just to give an example. And this is the, most of the guys, generally F grade means you have to repeat the course and exam as well. Are you guys able to follow how normal distribution can help you? As a matter of fact, even the COVID quizzes were more modeled as a normal distribution. Income can be modeled as a normal distribution. IIT's performance or result can be modeled as a normal distribution. So normal distribution is like bread and butter. Okay. The beauty about normal distribution is that it starts from negative. So it can fit all the real data from minus infinity to plus infinity. No other distribution can do justice for a continuous one. Okay. Now coming back to how we are going to use it. Okay. By the way, you understand what is the meaning of standard deviation? What is the interpretation of high standard deviation versus low standard deviation? Anybody? So for example, I give you two curves. Tell me which one is having the higher standard deviation. Higher standard deviation curve is which color, black or red? Where do you observe higher standard deviation? Right? Very good, guys. At least first one, right? Black. Those who are saying red, so please pay attention. Standard deviation is spreadness of the data, right? So how spreadness means amount of variation. So standard deviation, and you know why do we need standard deviation? Because can you see that the mean of the data, the peak of the data is same, right? So just saying mean, median, mode is not enough a lot of time, right? It's all same, but these two distribution are quite different. So the reason is that why standard deviation is required, because standard deviation talks about the amount of variation or dispersion, also known as dispersion, or also known as spread of data. Amount of variation or dispersion of the data or spread of data. So you guys can clearly see that this guy, the black one, is like quite varying, and the red one is like less varying. If you look at the similar range, that's why it is. Okay. Now, guys, there is a probability density function for the standard normal distribution. So what happens from the mean? It's definitely from the mean. So probability density function. Now you might be wondering what is it? Don't wonder much. I'll just use this jargon for you, although it should have been with you, but I can't do much about it. Probability density function is actually a mathematical function to represent the any distribution. So for normal distribution, you also have a probability distribution function, density function. Those who have done a little bit of random variable, they know that. So it is actually a mathematical equation, and it's a very ugly equation, guys. I love it, but you can hate it. 1 upon root under 2 pi, sigma is outside, e to the power minus half x minus mu by sigma whole square, where x can be between this. Doesn't look close. Yeah, this looks better. Okay, guys. Now this is your normal distribution. This is not standard. Now the problem this guy has, if this is normal distribution. Sorry, guys. Normal distribution. Now, giving a little idea. Suppose you talk about a normal distribution curve, and this is how it is. P. I hope everybody knows this. The area under this curve is the total probability. Come on, right? If it represents all the different probabilities, the total data will have probability equal to 1. I think this is common sense. So then if it is symmetric about, let's say, about the center, then can I say that this area minus infinity to 0, let me take some time to shade it. How much this will be probability value? What is the area under this curve? What is this area? If total is 1, what is this area? Similarly, on the other side, you can say, what is it? You tell me. Another 0.5. So total is 1, right? So far with me, guys. Hello? Total is 1. 0.5 is 1. Since it is symmetric, it is easy to do some of these juggling. So you can say minus infinity to 0, Akash, it is one part, and 0 to infinity, it is another part, right? When it is symmetric. But look at this. Suppose this is a distribution, right? This is also normal distribution. It is like skewed distribution. Ideally, people don't say this is a normal distribution. Let me also tell you this. But let's say the distribution is not symmetric. Let's say this is the 0 here. See, about the peak, it is symmetric only, but it has shifted. Can you see that, guys? Hello? Are you with me? Now this is not at 0. It has shifted towards right. Now you tell me, if I ask what is this area? Minus infinity to 0. Minus infinity to 0. What is this area? Will it be easy for you to calculate? I think no. Because to find this area, and if you have done a little bit of maths, it means that you are going to integrate this guy from minus infinity to 0 dx, and you will die doing the integration. Very good, Aryan. You got it. You got my point. So statisticians, mathematicians, they agreed that, boss, we can't do it all the time. So they said, why don't we normalize this, make it a standard normal distribution? Doesn't matter what data we are getting. End of the day, we are going to make it look like what you see on the first one. And that's where we got the normal distribution to the standard normal distribution. Are you guys able to follow me? Because who will be doing this integration, right? It is doable, but it's not easily doable. So they thought, why don't we introduce standard normal distribution, which is in Python, you must have heard this, like, oh, I'll standardize the data. Have you heard this word? Normalize the data. The data scientists, they keep telling this all the time, which is overused or abused. But what is the interpretation of it? It means that you will take all the x value. Then what you will do, you will subtract the mean and divide by sigma. and you will call a new variable called Z. And this is where I introduce the Z score. Are you guys able to do? Have you ever observed this at some point, x minus mu minus x minus mu by sigma? So basically what you're doing, you're taking the whole data, subtract the mean and divide by sigma, means normalizing by sigma. This is known as, Z value or Z score, right? And what you're going to do with this, the idea is that if you take this and find expectation of Z, which is like expectation of x minus mu by sigma, this is a little bit coming from random variable. So please excuse me for that, but I want to show you. So if you do the maths, it comes to be expectation of x minus expectation of mu 1 by sigma. Expectation of x is also average. If you remember what I've given on the top, see here. So using that, you write this as mu. Why I'm using curly braces, sorry. And then expectation of anything constant is also mu. Cancel madi. So this is coming to 0. So the beauty of Z score is that expectation of Z is what? 0. Which means that mean for standard normal distribution is always 0. Mean for standard normal distribution is 0. It is a calculated mean. Always know it's not the natural mean coming from the data. You have standardized it. So don't miss this step in the whole scheme of things. I'll take a pause here, guys. You have done this extra step on your data to normalize it. And that's the reason that your expectation of Z is coming to be 0. And likewise, sigma will come out to be 1, which I'm not deriving because it will take me to the intensive calculation on random variable, which is not there for you. Okay. Let's not go too mathematical actually. So far with me, guys. Now you might be wondering what is the benefit of this. So benefit is there, no? The moment you do this, you started with fxx mu sigma equal to 1 upon root under 2 pi sigma e to the power minus half x minus mu by sigma whole square. Now what you have done, my dear, you have taken this guy and you have calling this as Z. Focus. So now suddenly what's happening? The transition is happening, and I'll write it will become fz. Z mu becomes 0, sigma becomes 1. And then you will write 1 upon root under 2 pi. Sigma is 1, so this will be a shorter one. E to the power minus z square by 2. Guys, does it look simpler than the one which I just showed you? So right, your equation gets simpler and you can generate a table out of it, and that's where you're going to use it. So when I say table, then you will be looking at something. This is known as Z score table. So now if you see, guys, if you look at, Z equal to 0, which is here, this is 0, okay? So all the values of, Z is coming here, okay? On the left, why it's not picking it up. All the values are coming on the left. Then see Z value 0.1, 0.2, 0.3. And you have another set of values which are decimal values on the horizontal line. So you have two lines, vertical line and horizontal line. Let's say I'm trying to find a Z score for, let's say, some value. Like, let's say, what is the Z score for 1? So when the moment I say 1, it means that from 0 to 1, what is the value? So 0 to 1, how will you find? You can clearly see that this is your value. What is that? 0.3413. It's your probability, okay? Don't get me wrong. It's your probability. Okay. So let's say if I fit a normal distribution curve, I take an example to make you understand this table and you will definitely appreciate it. Let's say this is 0 and this is 1 and this is minus 1. I'm interested in finding the mu plus minus sigma. Guys, this is mu plus minus sigma. Na? Mu is 0 and sigma is 1. Everybody, keep talking to me. This is challenging, I know, but don't give up. mu plus minus sigma. Basically, you are trying to find 0 plus minus 1. Now, to get it, you can also understand that this is symmetric. If you find 0 to 1, you can also get the whole thing. And as this example say, this always talks about 0 to z, right? So 0 to 1, if I say, already I identified it. See, z 0 to 1 means in the chart, you have to find 1. What is the value for 1? Z equal to 1. What is this value, my dear? 0.3143. And since it is symmetric, it doesn't matter. The Z value for -1 to 0 will be same. Why area-wise if you look at that? It's not in this table. Do you see any negative value -1 or not? No, right? If you do the total, are you seeing a number which is very much familiar to you? Let me show you in case you are not able to recall. What is this number, guys? Mu plus minus sigma, 68.27. Are you able to almost getting the same? In percentage, what is it? 68.26% of the data. Interesting, no? So this table works, right? This table works. So what you can actually calculate and find and then answer, you are getting right for. Make sense, guys? Why it is 50%? Then this reminds me one of my cousin. So he was solving a trigonometric question and he was supposed to find this angle. So you're supposed to find this angle. And then what he did, he drew this extension. And then he was thinking that this will be 60. So this angle will be 180 minus 60, so 120. So that's exactly what Aryan is doing. What is the basis for this? Are you observing it with the line? You're not looking at any condition, what angle, what is the triangle shape, right? So exactly you're doing the same. You have to go with the concept. The concept says that if it is 0 to 1, how will you find 0 to 1 in a Z-score table? You will go and find what is the value for 1. Because this table gives you from 0 to Z. So suppose you want to find 0 to 1, I can see that 0 to 1 is this. Then you might be wondering, what is this? You should ask that, what is this? What is this? So suppose you want to find till 1.5, right? Or let's say you want to find 1.05. How will you find 1.05? So you'll take 1 here, my dear, and 0.05 will look at here, and then you will draw 2 lines, and then where it is intersecting, that's the value. So what is the value, guys? 0.3531. Are you getting how to use this? This is for decimal places. Okay, got it? So let me take this. Top 5% of applicants as measured by GRE scores, top 5% of applicants as measured by GRE scores will receive scholarships. If GRE is normally distributed with the mean 500 and the variance, 100 square is variance, my dear, right? Sigma square is variance. So sigma is 100. This is like being smart. How high does your GRE score have to be to qualify for a scholarship? A real question, guys. We're trying to estimate it. Have to be to qualify for a scholarship. So this is for all those guys having American dream, going to US, going to US university, get a job, learn there, study there, and settle there, right? So they write GRE exam. So did you understand the question, guys? You have a normal distribution. Mu is 500, sigma is 100. And they're asking that what should be the value, what should be the GRE score to qualify for a scholarship? You will not be able to do this right now. Let me do it for you. So guys, definitely when you look at this, it's a normal distribution. It's a not a standard normal distribution. It's a normal distribution. Because why it is not a standard normal distribution? Anybody can answer that. Let's see who is still, awake and not sleepy. How do you realize that it is normal distribution, not a standard normal distribution? Come on, Janta, let me know. What is in standard normal distribution? What is the value of mu? Is it 500? It's very good, Soumya. Expected from you. It's normal distribution, right? Because mu is something non-zero and sigma is also not 1, it is 100. So it's normal distribution. Now, I needed to convert into standard normal, right? So standard normal I have to get into. How will I get it? I'll calculate Z, which is x minus mu by sigma, which is basically x minus 500 by 100. Right, guys? So far with me? Now here we'll need a little bit of help on from the question itself. They'll give you in the question itself that if you talk about that I need some data about the threshold, this threshold will be given from the data itself. And it's given, right, that 5% of the applicants are going to, receive the scholarship. Like, if you are having 96 percentile, 97 percentile, you're going to get the scholarship, right? Remember, those who have written CAT exam or any exam which are having percentile. Percentile means, suppose you are at 99, what does it mean? It means that 99% of the students are behind you, right? So similarly for 95%, this is your 95%, the whole of it 95, and this small part is your 5%. Let's say this is your 5%, and this all is your 95%. So those who are going to be in the pink area, they are going to get the scholarship. Hello guys, so far with me? So the major chunk is 95. Obviously, majority doesn't get scholarship, right? So far with me, 5%. Now this 5% cutoff will be given by the question itself. Generally, when I'll teach you confidence interval, hypothesis testing, right? So I will give you this. Don't worry about it. That 95% means you have a probability there. And that probability is going to get converted into a Z score, and that Z score will be 1.65. For the time being, just remember it. So alpha 0.05 gives you the alpha cutoff, right? And for this corresponding Z score is, for now, you just take it as a value. Later, I'll explain everything. Okay, it is 1.65, right? What is this coming? Because this is your confidence interval cutoff, and this is where the magic happens, okay? So for the time being, I'm just saying again and again, forget how I have reached to this, how they have given you this number. Later you will see. So now you have the Z score cutoff. Anybody who is having higher than this value will get the scholarship. So 1.65 x minus 500 by 100. If you calculate, it will come to 665 guys. Hello. So anyone who is scoring more than 665, they'll get a scholarship. Guys, are you able to follow this question? So you might be wondering that how do you know that? Because see, if this is your cutoff, which is 1.65, then as you go towards the right, this value will increase now, right? So Aryan, buddy, the question is how high does your GS score? When I say how high, means how minimum you have to maintain to get the scholarship. Higher cutoff they're not asking, they're asking the cutoff, right? Suppose the qualifying marks is 665, you'll get the scholarship. Ideally, I use this table for getting this more better. So this is like, the problem is that this chart can only be used, and that's why we'll not use, when something we are measuring from 0, right? Guys, remember they're saying 0 to Z. But if you are trying to do from minus infinity till here, right, this value. So then you should use this minus infinity to Z, right? This is the most appropriate chart. Now you tell me, where is 1.65? So this is 1.6. and 1.65. Now let's see. So this is a value, and the closer values are this. Now you are making sense, guys. So it is coming to what? Either you take this higher cutoff, 95.05, right? Now, guys, let me talk about important things, which is I feel the first question I generally ask, moving away from descriptive to inferential, is that what is the difference between descriptive and inferential statistics? Anyone? Anyone want to take a shot at this, answering it? Inferential is conclusive, descriptive is unbiased measurement. Okay, very good, Pulkit. In descriptive, we'll be doing things on population. What even with things like you're finding mean and all. And then what we will do in inferential, sample. Very good. I think you've gotten it. But someone has answered in terms of what you will do with what, right? But what is the key difference? Descriptive. If you go with the literal meaning of it, describing your data. Now that data will be population or sample, that is another discussion, right? But if you are summarizing and presenting the data in a meaningful way to describe it without taking or making or generalizing any inferences based on the presented data, which Aryan has also mentioned. So inferential is conclusive. So if I can give you some pointers, guys, okay? So descriptive, if I may write, descriptive statistics, I'll just write stats, involves the summarization and presentation of data in a meaningful way. It's not like it's good for nothing, just it describes the data, So what is the primary goal here, guys? Primary goal or objective is to describe the data. Obviously, with the help of mean, dispersion, measures of central tendency, leveraging, measures of central tendency. What is that, guys? What are the measures of central tendency? Mean, median, mode, right? Must have been taught. Measures of dispersion, right? Spreadness, variance, standard deviation, right? Measure of shape. What is measures of shape? I hope you must have been taught. Skewness, kurtosis, right? Etc. Prabha is saying inferential is used when you want to make prediction or generalization about a population based on a sample. Yes, that's the application of inferential statistics, right? Why do we need inferential? That's the answer to that question. We are still understanding what's the difference between what is what. So guys, definitely all of the answers which you have given is correct. That descriptive is all about population, inferential is all about sample. But one thing which is very much, you have to be very much clear about that descriptive stats do not make any inferences. Okay. That's why I have a separate branch altogether. Do not, draw conclusions or inferences, but it doesn't mean that you will not find any logical conclusion, right, to RN point. It does not draw any conclusion or inferences beyond what is presented in data. So basically means what? Generalizing it. What you see in the data, you tell it, right? It's an unbiased approach. So I'm very happy to see some amazing answers from few of the folks. Are we good, guys? Everybody's clear, descriptive. They are going to inferential. So this is what descriptive is. Now, I'll get into inferential. If you remember in school days in the English MCB main course book, those who have done CBSE, they would know. I don't know if it's still there or not, but I'm talking about more than a decade ago. So when I was in class 9, 10, right? So there we had a book called MCB, main course book. There they used to give some 5 or 6 lines, right, in the paper, in the exam, and then they used to ask what is the inference of this, these 4 or 5 lines, right? Remember, somebody remembers that, and then they used to give 5 option, 4 option, one would be correct, right? So obviously read those 4 or 5 lines, right, and trying to make some conclusion on inferences about it. That's what you must have done in English, but it's a similar kind of situation for statistics as well. So inferential statistics, as the name suggests, you draw some inferences, right? The literal meaning of inferences is conclusion, some generalization. So I'll also keep talking and write so that I can save some time. Involve making inferences. And once you have done the inferences with you draw some conclusion. About a population based on sample data. And that will be random sample. There are numerous ways of doing the random sampling. So what is the goal? The primary goal is to, sorry guys, I'm writing after like 3 weeks or so. Can you see that the handwriting has gone for a toss? So that's how practice is important in life. The goal is to generalize findings or insights from a sample to a larger population, right? And then you also have some techniques there. Leveraging, what are the techniques generally we use, guys? Like as simple as doing hypothesis testing, right? So you actually form a hypothesis and you test it to come to a conclusion, using confidence interval concept, right? CI concept. And you will love it the way I'll teach you, I can promise. As simple as running some tests like t-test, right? ANOVA, analysis of variance, etc. Okay. So this is my introduction to the difference between these two guys. Now, at least we have come to a point where we know that descriptive is all about generalizing the data. Sorry, describing the data. Inferential is all about making inferences or generalization about a larger data set from a sample of those, right? That is clear. If that is clear, guys, so then I'll give you a movie recommendation. And this is just one summary, which I have already written. I don't want to write. See, so if I have to summarize it in a nutshell, descriptive talks about describing the visible characteristics of a data, which can be a population or sample. So not always be like stubborn, I'll only do population with. You can also find descriptive statistics for sample. Who is stopping you? Meanwhile, inferential talks about inferences or generalization. Look at the green highlighter. About a larger data set based on sample of those, and that sample will be random. There are a lot of samples, stratified, strategic, random, simple random. There are a lot of things are there. So whenever we talk about sampling, so sampling is very, very important for any inferential statistics, right? Any sort of test. You cannot test everybody. So let's say you are looking at a population, which is, the country population. India has how many people? How many we are? 1.4 or we are now 1.5? How is it? Prabha, you must know, right? 1.4, 1.5. What is it? 1.6. Okay. So 160 crores. Okay. So let's say if I try to measure something, 160 crore people, this will be quite a lot of data, isn't it? If you are referring to what is India's population in 2023, I think it is saying 1.43 or 1.44, not 1.6. So yeah, it is, you're right, Arun. We are close to 1.4243. Anyway, so doesn't matter for my example. Suppose I ask you to go and talk to everybody and ask their mathematics marks, right? and give me the mean of maths for Indians who have studied maths. Means except those guys who are in, let's say, and grade wise. So grade 1, average marks, grade 2, grade 4. Do you think it is even possible to do that? I think no. I'm asking you to go and talk to everybody, right? Oh, okay, let me take a recent example. Election just concluded, right? You must have heard about exit poll. One of the famous things happens on media. Exit poll. Anybody has any idea? Exit poll. Exit poll is like they do give you, agencies. They do the polling and they do the random polling, random sampling of the voters. They ask in a constituency that, okay, tell us. So let's say there are three parties, party ABC. Whom did you vote for? They don't ask. They have a very amazing set of questions, they call questionnaire, and they go and they do this survey. But do you think is it possible to, let's say, just so I was in Indore, so MP Indore, let's say we go to Vijayanagar. Anybody from Indore, say hi. So let's say an MP election just concluded. Suppose this is a nice place in MP Indore. So even for a Vijayanagar population, let's say the population is maybe let's say 20 lakhs. Okay. Hypothetically, I'm just making some numbers. Is it easy to go and talk to everybody who are 18 plus who can vote? We can vote 18 plus or 21 plus. My GK has gone. I think 18 plus is the voter. This is really sometimes mathematics. We keep talking about normal distribution, but I don't know. Kids will laugh at me. Anyway, so 18 plus guys can vote. You're not going to ask all the voters that whom did you vote for, right? It's not possible. So what this agency do, guys, agency do the random sampling of voters. So what they do, they are going to do random sampling of voters. And if I'm correct, they also pay the one who participate in it, but they never accept it, by the way. So agencies do random sampling of voters. They'll do in Vijayanagar and ask a set of questions to gauge the sentiment, right? Ask a set of questions to gauge the sentiment and tie back to which party these guys voted for, right? And then what happens, they prepare a nice summary. And if you have seen, and I think I can get a screenshot also, exit poll MP 2023. You must have seen something like this. I cannot show you who is getting what, but I can definitely show you how does it look like, right? Have you seen this? So can you see, if I take the first number, 120 to 140, let's say this is party A, party B, party C, party D, whatever. It seems that party A has a clear majority in most of the agencies. So what is this 122 to 140? What do you mean by that? So these agencies, they do, right? Let's understand the process. 120 to 140, right, is the range they are given. Isn't a range? That minimum party A will get 122 seats and maximum they are going to get 140. This is what we call it as confidence interval. Interesting. So we have been seeing these exit polls for long. This is known as confidence interval, and they give a confidence score also that we feel 95% chances that party A will get these many seats. This is known as confidence interval estimate. It's an estimate, right? Because you are not talking to everybody. You are talking to a sample of people. You are asking those questions, right? You are asking those questions and you are coming to a conclusion that, okay, party A will get these many seats. Because don't forget that you did some sampling here, right? This is how sampling looks like. You go to a constituency, you will pick and ask questions. This is your sample, right? And then you come back to generalize something about that population. Makes sense, guys? Everybody? Now, what is the difference between point estimate versus confidence interval estimate? So just to, give you a little idea, and then we will pick it from here as well. Pick it from here tomorrow. Point estimate would be like, okay, I will say party A will get 130 seats, period. Hey, you are not Rajnikant, right? You cannot exactly predict it. 130 seats. Astrologer do that. I think party A will get 130 seats. It is a point estimate, one value, single value. That is like, getting the mean. Generally, people say this will be the mean of the sample. And then I am saying that this will become population. So mean of the population I am predicting. So on an average, I feel party will get 130. But tell me, getting 130 correct is tough or not? Tell me. If the party gets 132, you're wrong. If the party get 128, you're wrong. Are you feeling it, guys? So point estimate, you cannot, put a confidence to it. So that's why statistically, we generally go with confidence interval concept. Now, if I'm getting 132 or 128, still both the options are going to fall in here. Hello. And your analysis is still correct. That happens with clinical trials in vaccines as well. When the COVID hit us, so a lot of vaccine trials would have happened. And I'll take that example. I talked about that case study that vaccine trials, right? Vaccine trials are not going to be 100% accurate. And when the pandemic happens, right? It's a mahamari. It's very tough because you're running against the clock, right? You need to get a vaccine in the market. So you cannot be like waiting for 99.99% accuracy, right? You will go with some confidence interval. Generally, they use 95 because it's related to health. You cannot administer something to someone who are having some comorbidities. They might die, right? Rather than they die with the virus, they die because of your medicine. So you have to be very careful. But they do all those clinical trials to come to the range of efficacy. So that's what is the efficacy of the medicine, how effective it is, it's a score. So that score, if it comes in a threshold, you go and release the vaccine in the market. Hello? And then you put in the batch production. Are you feeling it, guys? So that's the difference between the point estimate and the confidence interval range. I'll deliberate more on it. But point estimate does not provide a room of error. There's no margin of error. 130 means 130. But confidence interval does provide margin of error. You can make mistake. And that you can also set it up. Suppose you say 80% confidence interval, then your range will be like 100 to 140 or 100 to 160. Are you feeling it, guys? Then you will say that, what is this? You cannot have this much of range, right? 100 to 160, and then some party will, the majority is like only 60, let's say. Majority to form a government is 70, and you are putting a range of 100 to 200. Error cannot be the majority, right? Are you getting my point, what I'm saying? Let's say to form the government, the majority is like 70. You are putting the range of 100, that the gap is 100. So that's not an appropriate study. So that's where range, how much we should keep a percentage, 95, 99, 90. Generally, these are the confidence interval levels, 95, 90, 99. In any exit poll, they follow a very good set of approaches to come a number, which is your confidence interval. That's what they show in the TV, which you are seeing, right? And they also claim that my analysis depends on blah, blah, blah thing, right? That's why if you see, some of the guys are like Rockstar. Can you see these guys? I am telling you, you'll get exactly. This is like idiot. They must be new. So definitely these are the top players, right? Sea Voter, I have been seeing since my childhood days. But this is like New Nation, whatever. Can you see that? They are giving the point estimate. I just realized that. So I don't know. Definitely they're wrong because there's no range. So even 90 is not, they will say, okay, it's close to 86, but that's not how it is.
Just a quick info, guys. Intellipaat offers data analytics course training. Through this course, you will master Power BI, data wrangling, data mining, and much more from the IIT Roorkee faculty and industry experts. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take the first step towards career growth in the field of data analytics.
So for the exit poll, a point estimate looks like, let's say there are 300 seats. So now I'll take my own example. You have three party A, B, party C. Let's say you are saying party A will get 180 seats, party B will get 80 seats, and party C will get 40. Total to 300 if you do the maths. This is what we call it as what? Point estimate. What point estimate? You are giving a single value that this will happen exactly the same. So there we don't have any, margin of error, right? But on contrary, if you go to the other side of the story where we are saying we'll talk about, so this is point estimate. Let's say we talk about confidence interval. So what we do, we add a margin of error to the point estimate and we develop confidence interval. And then we have different levels of confidence that, okay, you will say 90%, 95%, 99%, which one you are going to say. So for example, if I look at party A, so I'll say, okay, party A will get 170 to 190 seats. So let me rewrite this, party A, party B, and party C. Let's say we say party A would get 170 to 190 seats. So what you've done, my dear, is that you've added a margin of error. You have added a margin of error. Obviously, it's still the mean, the average is what? 180. But you are not saying 180, you are saying 170 to 190, which means that you are going with certain alpha. Let's say alpha is 95% confidence. Don't worry, I'll explain that. Alpha is, 95 means 0.05. You have to do opposite. And alpha is known as level of significance. This is a jargon for you as of now, but I'll explain. Similarly, for party B, you will say, 70 to 90. Party C will say 35 to 45. Something like this, right? This is known as interval estimate, confidence interval estimate. You have a range there. So I have a very good example to give you the definition of confidence interval. I always show that. So, and you will love it. Can you see that? So there are two people, right? There are two images. Can you see that? So I have already kept the concept and notes here. But if you see here, look at the first point estimate. Let's say you go for fishing, right? You go for fishing and you're using a more like a spear to fish, right? So you think that, oh, I'll just, hit the fish with this, right? What is the margin of error in this? Quite a lot of, there's no margin of error, right? Means you have to make a mistake. Chances are very high, guys. You agree with me? Then there are another image on the right hand side that talks about confidence interval, that you have a fishing net. Tell me which option will give you more number of fishes. Chances of you get a fish, obviously the net one, the confidence interval, because it will place you in the range. Chances are very high to compare against with that you will get exactly that fish. So this is a very cool image to understand that confidence interval, refers to the probability that a population parameter will fall between a set of values, right? And that set of values is like your range, your interval, and that will fall for a fixed or certain proportion of times. So when you say 95% confidence interval, what do you mean by that? It means that if you do this activity of exit polling, 95% times I will fall in this range. Hello. I will not be in this range for how much time? 5%. Means still there will be some error, there will be mistakes, but it will be 95% within the range. Hello, guys. And you will be 5% outside the range. Means mistakes has been done, means your exit polling gone wrong. Are you getting it? So that's how you define confidence interval. So it's okay. I'll explain again, Anthony. But why don't we look at this image? So see, this is a normal distribution curve, and this is 95% confidence interval, which I mean to say alpha is 0.05. Again, look at this. And you can clearly see that if alpha is 0.05, so it is two tail. So you have divided this into alpha by 2. So one is for the left tail, right? If you do alpha by 2, how much is that, guys? 0.025. In percentage, it will be 2.5%. Similarly, for the right tail, you have alpha by 2, so 0.025 equal to 2.5%. Total is 5%. So if you look at the limit, right, this is your upper limit. This is your lower limit. What we are saying that, let's say we gotten a population mean, right? And we say that the population mean, we are trying to estimate, there is 95% chance, listen to me, 95% chance that the population mean will fall between what? These lower and upper limit. 90%, 95% chance is your population mean will fall between this. This is your confidence interval, right? Just like in this example, I had mentioned that let's say your mean is 180, and when I give a range of like 170 to 190, I am sure that 95% times you will get a value 180 lying in between this range. Clear? This is for Anthony. Don't worry, I have given you the formula, derivation, everything, but did you understand the concept? Now moving on to Prava's question. Prava is asking, point estimate is used in which cases then? Because CI has a broader approach. So whenever you are interested in getting a single value, Prava, right? You are not interested in giving a confidence interval. You can go and use it. For example, let's say you want to estimate the average height of a population, right? You don't need to really go and give them, let's say estimating average height of a population. So in this case, point estimate can be might be the sample mean height, right? So you take a sample, you find the average, that will be your point estimate for the population. Okay. Now, whenever you want to add, and that's exactly being done now. You have taken a sample in the exit polling also, right? Remember? And you have done the average number of seats I feel from the sample it should come. This is a point estimate. So it's not like that point estimate is not being used. You are using point estimate in the more like a first step. And that becomes the base for your confidence interval, which you will realize that let's say if I have a average sample height, let's say some value X, right? Sample mean height or sample average height. And now you want to, rather than you want to represent this into a confidence interval manner or confidence interval representation, you want to say, oh no, I don't want to say average height. I would like to say 95% confidence that the true population height is between the lower limit and the upper limit. So it's more likely to, go from point estimate to confidence interval when you want to give a more like a certainty of getting a value, right? If you are not going to give that certainty of a value, you just want to estimate it and just say it out, you can use sample mean, and that's where point estimate can be used everywhere. You're getting my point? It's not about that it's like A versus B. It's like A, and then how we can add a layer of certainty to A, and that becomes your confidence interval. Point estimate, single value you are estimating. Confidence interval, when you want to give a range of values, and showing that, okay, you are 95% sure that, it will fall in that range. That's how you should take both these guys. Cool. So now, why don't we get into some questions then? How to calculate confidence interval? See, I'm telling you mathematics behind the scene as well. Generally, trainers will just show you this in hands-on by using Python codes. I'm teaching you how to calculate manually, right? Just taking a pen and paper. That's the difference. Now, guys, you always remember that you have a Z score for different confidence level. Okay. Confidence level is different from confidence interval. Always remember that. So this is your confidence level. This is as good as saying your 1 minus alpha, right? So 95% chance is 0.95. Z score is 1.96. And you can see this in your, right, 1.96 now. So 1.9, where is 0.6? Here. So you can come here, see. So what is the value you're getting, guys? 0.9750, right? You are here. And this is your 2.5%. Do the maths. If you subtract 1.9750, you'll get 2.5 in percentage. And similarly, we'll have other 2.5. So are you getting 1.96 means 95%. 95% chance, right? So these are the values you should always remember. It should be on your fingertips. So once you have the confidence level and the Z score, so the formula becomes, to be honest, very easy. So the formula says, let me give you, confidence interval CI is equal to X bar plus minus Z S by root under N, where X bar is the mean, sample mean, Z is the chosen Z value, right? I'll also give an arrow to take you the right place. Yeah. S is what, my dear? S is your standard error. Standard error. It's not standard deviation, standard error. I'll come to that. And N is the sample size. So what is going to be upper limit? It is going to be upper limit for confidence interval X bar plus Z score S by root under N to multiply. What is going to be a lower limit? Confidence interval X bar minus S by root under N. So now, guys, this is known as standard error of mean. Okay. Let's talk about a little bit more. Standard error of mean. So what is the meaning of it? So let me write one liner, you'll understand. This is a measure. Again, this is equal to a standard deviation only, but not like typical standard deviation. You have to always say standard deviation of what? So this is measure of variability associated with sample mean when it is used to estimate the population mean. You will not get anything. I know that with these word. Okay, I'll explain. So suppose you have a population, right? This is your population, and you have a sample. This is your sample. And you can have multiple samples, right? Every time you will get a sample mean, guys. Sample 1, sample 2. So far with me, guys, right? If you do that random sampling, population mean is not going to change, right? Let's say this is your mu p, mu population, mu pop. So every time the delta between mu pop and what you have estimated, there will be some number, let's say A, mu pop minus x2 bar B, mu pop minus x3 bar C. Hello? If this delta, if you find standard deviation for ABC, that becomes your standard error. And dot, 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 dot. Are you getting that measure of variability associated with the when you're trying to estimate? Okay, the difference always. Okay, that becomes your standard error. Are we clear, guys? And I'm going to give the formula. See, right? Correct, guys? So obviously, you can see what I was saying, right? Xi is your different sample mean, and you're finding that. So what we are trying to do, we are finding x1 minus mu, x2 minus mu, x3 minus mu. No, this is a different formula. So we are not actually subtracting from standard error. We are not subtracting from sample mean. As for this formula, what we are doing, I'm just also contemplating that only somewhere, that sigma divided by root under n. Yeah, so that's correct only now. You are right, you are right. So n is the sample size. This, what I've written, this whole thing is your standard error. You're right, you're right. So this S, okay, let me update this because then you will get confused. You're right. This whole thing is your standard error. This is your standard error. But guys, I think this is something I need to just validate, but this is the formula of standard error of the mean. There is no doubt about it. Okay. Standard error of the mean, but I'll validate it. Okay. For the now, for the time being, just hold on to that. Okay. This formula can be a little tricky time to time. And what is n, by the way, guys? N is the size of the population. Rest terms, you know, right? Rest of the terms, you know. But I'll get back to that again. I need to validate from a. So every time all the resources will have, you know, S by root under n is the standard error of the mean. Okay. Every time, some of the times, you know, the portals are not that great. They also make slight mistake in the formula, not concept. But this is how we go about it. For the time being, guys, let's go into the question so that you have a certain idea that how do we calculate confidence interval. Okay. So let's say if I give you, and I can give you like an example rather than calculating it. So for example, not a question, but for example, if you look at confidence interval, suppose I say sample mean is 86, Z is 1.96, and standard error is, a standard error of the mean is 6.2 by 46 total, right? 46 your sample sets. How will you do it? This is your sample mean. X bar and mu are not same in Rani. Mu is for population mean, right? This is for population, and X bar is for sample mean. They are not same. Okay, so don't get confused. Come on, guys. How will you calculate it quickly? Yeah, you have to calculate the margin. So give me the upper limit, give me the lower limit, and tell me the answer. Do the maths. By the way, guys, tell me one thing, and maybe Soumya, you only tell me what this is standard error of the mean, but what is this S? This is your sample standard deviation, right? I hope you guys know, right? And the moment you divide by root under n, it becomes the standard error of the mean. Okay? Standard error of the mean. So that's the difference. Okay, by the way, come here. So what is it? 86 plus 1.96. Why you guys are thinking so much, right? 46. Come on. Someone can give me this, or I can write myself. 86 plus, and guys, this will be root under now 46. I need help now. I cannot calculate this. Root, I don't know. I can take it in one note. But guys, anybody has solved it? I have the answer, so you can help me. This is root under. So I have the answer for the upper limit as 87.79. Anybody who got in this? Yeah, Siddharth. Very good. So this is what you will get. For the lower limit, you have to do the same thing. And it should be 84.21, right? So if you look at this formula, guys, x bar plus minus, z into s by root under n. This is your confidence interval. If you deliberate little more, you'll realize that as the sample size increases, right, confidence interval become narrow. It's obvious, right? It's a general thumb rule, right? Should become more narrow and vice versa. Right? Because you have more data points to get more exact answers. So your confidence level can be narrow and you can still achieve better accuracy. But don't worry, guys, I'll do some questions. Let me give a question here. In a sample of 40 light bulbs, the mean lifetime is 5,000 hours. Okay. 40 light bulbs, mean is 5,000 hours and the standard deviation is 400 hours. Compute a 90% confidence interval for the average lifetime of the bulbs. Guys, come on, get to it. And I'm giving you another question, and that will be your homework. Come on, guys. I can also help you. See here, whenever you're looking on any confidence interval, generally there is a concept of central limit theorem, which says that to apply any concept of normal distribution, you have to have your distribution normal. And that can only be possible that if n is greater than 30, which is your sample size, we can use, we can use z-score equal to how much? 90%, right? So it is what? How much is the value? 1.676. Look at that table. 90%, 1.645, sorry. Z-score is what? 1.645. So if n is not more than 30, then you will not be able to use this. There are some rules. Now, if you use this, so you have the z-score, you have a sample size n40, you have mean lifetime, how much? 5,000. You have standard deviation S, sample standard deviation is how much? 400. So what is going to be your confidence interval? It will be x bar plus minus z score. Listen to me, guys. S by root under n, right? Someone should have done by now. So someone should have done it. How much is that? 1.645 into 400 by 40, root under 40. What is it, guys? What is the range coming out to be? Upper limit will be how much and lower limit will be how much? Please help me out. Then I can confirm the answer. So upper limit is 4895 or lower limit. Which one is it, Siddharth? Lower. Lower I am getting. No, I think I made some calculation mistake. What is square root of 40? I don't know if it will work. Ah, it works. Wow, this is good, yeah. Okay. So 400 divided by square root of 40. I can use it. This is cool. Wow, this is good, yeah. Then what I can do, I can multiply 1.645 into this with this, right? So, and I also want to add 5,000 plus, right, guys? This is my one note equation. I am getting 5104. Okay? I'll copy and paste. I'll just add a minus. And here is your 4895. I think you guys are right only, no? Sorry. So the answer is, So apparently my answer key is wrong, which I was looking at. 5104 and 4896, right guys? Come on. So upper limit is, so that's why I don't trust these question and the answer keys. You have to be careful. But you guys are doing amazing. Hello. And this is a homework, guys. You can try it at your end. Answer again I can give you, but I'm not sure this is correct answer because I don't trust these sources. I'm only interested in the question, but this is the range, guys. If you're not getting it, whatever you have done is correct. Okay. So yeah, this is how generally any statisticians, right? They come up with this kind of approach to estimate the population characteristics with the help of sample, right? So you can clearly observe in question like this, you are not looking at all the bulbs. Let's interpret it now. You're not looking at all the bulbs. You're only looking at 40 bulbs, right? And taking the sample mean of those bulbs, standard deviation of those bulbs, hours, right? And then you are coming with the confidence of saying that I feel all the bulbs in the population will either last 4896 to 5104 hours. Interesting, right? So looking at batches, you are coming and generalizing the whole, you are looking at this batch sample and then generalizing it to the whole population in that batch. So in manufacturing, you use confidence interval like anything, the quality assurance, the quality engineers, they use a lot. So if you are not finding a lot of issues, right, you feel that average lifetime is X, right? You can generalize and you can generalize it to the population. So using this sample mean and putting a buffer, which is your margin of error, this is your margin of error, no guys? You forgot? This is your margin of error, right? And this is for you, Prabha. You were asking, right? What is point estimate? You started with what, Prabha? This is your point estimate, correct? Should be clear for everybody. Combining these two guys, you get confident interval. Okay. Indrani is asking, percentage of CI table from where we can get that, are those constant? You're talking about this 90, 95, 99. This is your confidence you want to keep, right? So you start with this Indrani, right? That I want to be 95% sure or 90. This is your confidence on your manufacturing process or any activity. So this is not coming from any table. You come up with this score. Oh, I want to go with 90 or 95. And then you have a table, which I have already given, right? This one. And this is coming from the same jet score table. And then 90% confidence interval, sorry, confidence level gives you this jet score. So this you will decide or the business will decide, right? It's not coming from anywhere else. I'll talk about the next very important topic. Later on, guys, you remember I said n should be greater than 30, sample size should be greater than 30, then only we can use that score. But nobody asked me that what if sample size is less than 30? So if the sample size is less than 30, you will be using the t distribution and you will be using a t-score. So I'm giving a note because I have not talked about t distribution or t-test, but I'll give as a note. Please keep it with you. You don't need to write, it's going to be in the notes. So I'll write a note. Let's say we have one small set of data or one small set of sample, which is, let's say n is less than 30, then t distribution in place of z distribution or normal distribution instead of normal distribution is used. Used to construct the confidence interval. Okay, guys, clear? So if the sample size is less than 30, then t distribution And instead of normal distributions, I'm going to highlight it as like pink, purple, to construct the confidence interval. That's how you construct the confidence interval when the n is less than 30. You have another t distribution. Your formula will change. Your formula will look like this, my dear. X bar plus minus. Here you will bring t distribution or t score, t distribution score into same thing, S by root under F. Nothing changes. Only thing is changing is what, my dear? This Z score will be replaced with t score. Clear? Now I'm interested in more on hypothesis testing. Very interesting topic. Hypothesis, right? In India, people are always ready with their own hypothesis, right? Indians are opinionated. You guys agree with me? We Indians are very much opinionated. हमारे पास है, right? We always have opinions for everything, everybody. So we have a lot of opinions. So we make a lot of hypotheses, and then without testing a hypothesis, we assume it is true. That's our characteristics, right? But you ask anybody anywhere in India, they'll answer something. That's the problem. So let's say you want to ask about where to do statistics course from, let's say which college, and you ask this question to a commerce guy, right? Or maybe let's say a arts guy, BA, who's doing a BA, right? Arts. That person, the student will also have a lot of knowledge about that where you can do statistics in which college. I don't know how much you can trust that, but we'll get some colleges named from that person. So that's the problem. Okay. But hypothesis testing is not like, just form opinions. It's beyond that. It's a science. Okay. Even in our projects, right, we always come up with some hypothesis and we test with our data to ascertain that that hypothesis is correct or wrong. So a simple hypothesis can be that, which I always take this as an example, that there is a man who goes for a trial. A man goes to a trial where he is being tried. This is a very classical example I take. Where he is being tried for the murder of his wife. I know it's, discussing this example in the morning is not a good idea, but I'm bound to take this example, right? What do you guys think? What is your opinion, thoughts? Girls, ladies, let me know. Ideally, when I say this, without getting into anything, 95% will say, okay, definitely he would have done it. Guys, a man goes to a trial where he's being tried for the murder. The moment you see murder of his wife, living in today's society, we believe that this is 99% correct. But do you think, judiciary works on this principle? Do you think the judge in the court will behave like you? Never ever. There's a rule, right, in the law, and obviously I'm again, just like we Indians are opinionated, right? I don't have any idea about law and order, but I'm just reading some lines and telling you this is how they proceed any cases in the world, not in India, across the globe. And if you see the last few words, innocent until they have been proven guilty. That's how you have to treat it. But trust me, it doesn't work like this. And people have their opinions and they try to. That's why you must have heard about these words these days is media trial, right? And they influence everything. And the judge has truly honest, truly honest here, right? Judge does not have any power. Trust me. Judge will only work on the documents, and documents is always under the administration. How they present it, what they presented, that is going to decide the fate of the case. That's how reality is. Okay, there's no emotion attached to it. But when I say this statement, a lot of people, if you go and say this in society, right, the moment something happens, right, 100% people will start believing that this man was that, blah, 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 100% he has murdered his wife. But this is a hypothesis. You need to test it. So if you want to test it, then you have to form two set of hypotheses. And that's where you must have heard in hypothesis, there is one known as null hypothesis. So you have to first frame null hypothesis. Now you tell me, guys, what should be the null hypothesis in this case? H naught. In this case, the null hypothesis is what? Not guilty. The code will proceed or initiate this discussion, right, with the guy saying not guilty. Right? At the moment, have you seen in the movie, right? I think we learn a lot from movies, but few things are correct. The judge will, just to save the court time of the court, they'll ask the person that, do you accept that you are guilty or not? Like there's a very typical language, right? The lawyer will tell you how to respond. If the person himself accepts guilty, then nothing to be done, right? So obviously he will be just punished for it. Agree? So that the first thing they ask to the person itself, that are you guilty or not? Do you accept that you have done it? If you have not done it, then the court will accept it as the null hypothesis. Null hypothesis means natural. Null means no change. Always remember that. Someone can ask this in interview. Null means no change. Tell me, do you really think that everybody, right, waking up and killing their wives? I don't think so. Right? Every man in the world, every day they wake up and they plan to kill their wife. I don't think so. Right? What is rare is you're going to be alternate hypothesis. What is very common to happen in this society is going to be null hypothesis. So what is common in this world? Like you sleep in the night, sleep during night. That's common. I know some no, we are owls. We don't sleep in during night. We wake up. We wake up in the 2 a.m. in the night, and then they'll sleep around 6 a.m. in the morning. So I'm not talking about exception. I'm talking about natural. What is natural in this world? You sleep during night and you wake up in the morning. Guys, hello. You agree? That's your normal. Similarly, this is also normal that man is not going to kill his wife, right? This is normal. Still, it is normal. I know it's hard to believe it, but then the woman would not have got married, right? There's no point if you know you are going to die. So definitely this is all normal. That's why the hypothesis should be very carefully framed, right? Null hypothesis is not guilty because of this normal natural phenomena that nobody wants to kill nobody, right? Trust me, still this is the philosophy. And trust me, building hypothesis is a lot of philosophy. Then alternate hypothesis. Alternate will be what? There is some change. Change in what? Change in the normal behavior, right? And that will be HA. Sometimes people also write H1. So both these notations are there. And it looks weird. HA or H1, and it is going to be killed. And now you will start with the data to test this assumption that, okay, guilty or not guilty, and you're going to start with the whole data-driven approach to come to a conclusion. Are you clear with the example which I took to explain hypothesis? This is maybe not a good test, but this is a very cool example. Trust me. This opens a lot of eyes. That what you feel is not important. What is correct? What is the approach? You have to pick it up. You might feel something about it, right? But doesn't matter what you feel, right? This is how it is. Okay. Yes, we always want to prove the null hypothesis is true. If we are failing to do it, then alternate wins. Clear? So you lose the case while trying winning it, right? And generally, when we say, have you seen this also a defendant? If you are getting convicted in something, so not convicted, sorry. If you're getting tried for something which you have done or not, still you will get a defendant, right? You are going to be defendant, right? Victim, I don't know what are the words, but defendant means that the person who is getting blamed, right? That person needs to be defended. So naturally you feel that this person, even you can feel that, okay, he might have killed his wife, but you need to still defend that person because that's not natural for killing, right, a person. So null hypothesis is going to be the idea to win that so that you prove that person is not guilty. In case we fail to prove it, then he will be getting convicted and he will be getting the punishment. Simple. Anthony, are we good? Okay. So see, we were discussing hypothesis, right? So null hypothesis means no change, no impact on treatment, no change, nothing. Nothing has been done. Okay. You're doing a test like in a pharmaceutical company, you are doing a control test group. What is the effect of treatment on your patient? If it is null, means no effect, right? So that's where comes your normal distribution. Sorry, comes your null hypothesis. Now, let me get into the little more of the details. You should know that hypothesis testing is basically is an assumption, right? Always remember that. Let me give you as a note, else you will forget. Hypothesis testing, my screen is up, right? Is basically an assumption that we make about the population parameter. It's an assumption that this will happen, that will happen. Till the time you are done the test, complete testing, it's still an assumption. If I continue right, hypothesis testing evaluates two mutually exclusive statements. Correct, guys? H0 and H1. What is the meaning of mutually exclusive? Means if H0 is correct, H1 will be false, right, guys? Correct? Two mutually exclusive statements you are going to evaluate about population to determine which statement is best supported by the sample data. Now, how does hypothesis testing work, right? I want to show you. And to show that, I have to use an image. Let me show you this. This is very, very important, guys. Again, you are going to fit a normal distribution, right? You can see that this is for two sides, by the way. Can you see two tails are red? This is for two sides. Suppose you say alpha equal to 0.05, right? That's your level of significance. But tell me for alpha 0.05, alpha by 2 is what? I have just calculated. So in terms of percentage, it is 2.5, 2.5, guys, correct? For 95% confidence interval, you have alpha by 2 is equal to 2.5. So guys, if you look at this, I'll start shading. This is your happy region. That's your confidence interval, now, guys. This green shade, the bigger area. Come on. Keep talking to me, guys. You agree or not? See, this can be a little tricky. So you can always ask me question. Don't hesitate. Don't think that what I'm thinking about your question, I'm not thinking anything. Okay, I just want to answer those. This is a tricky topic. I'm trying my best to explain. See, this is your confidence interval region. You can say this is your happy region or CI region, where you will say that if anything which you're trying to test is going to fall in this place or not, right? Now, what happens now, whenever you're trying to form the hypothesis, I'm giving one example of hypothesis, that average height of the sample is equal to the national average height, which is your population height, right, guys? Come on. If you're comparing sample height with national average height, is your population height. So ideally, you will believe that average height of us, like let's say, and this is a sample, and the data you're looking like all the adults, male, between age 18 to 25, right? Something like that. Or 20 to 25. You can decide the test. So you are saying that if you try to take a sample out of this population for the average height of the adult male, we believe ideally it will be same. That's why it is part of what hypothesis? H0. If your hypothesis is true, listen to me. So you have a alpha. Always remember that. You have a alpha, which is your level of significance. Remember that. In this study, I have fixed it to 0.05. Now there are certain rules. If your p-value, which is denoted as p, is less than alpha, listen to me, less than alpha, sometimes people also write less than equal to alpha, you are gonna reject the null hypothesis. Listen to me. Don't worry how, why, I'll explain, you will understand. If your p-value is greater than alpha, you accept the null hypothesis. Is it clear, guys? At least can you remember this as a rule in your head? P less than alpha, less than equal to alpha, you reject. P greater than alpha, you accept. Simple. Abhi ke liye, just remember it. Sorry, I'm speaking Hindi. I know some of the learners will not understand a word, so should not do that. But yeah, sorry. P greater than alpha, you have to accept. Now the question comes, bro, I'm going there only. What is P value? So what is P value? Let's answer that. So P value is the probability. P stands for probability of rejecting a null hypothesis when it is proven to be true, right? So it is the probability of rejecting a null hypothesis when the hypothesis is proven true. If P value is less than or equal to, as it's written here, guys, let me highlight, P value is equal to or less than the significance level alpha, then the null hypothesis is inconsistent and needs to be rejected. I think that's the same thing I've written, guys. Here, if P is less than equal to alpha, you are going to reject the null hypothesis. But this is a little tricky. And Anthony, everyone, please hold on to your question. Let me explain. I'm not done. To explain this, I need to show you one cool example with the help of this chart. I think you are going to understand like this. Tell me one thing. I'm talking about two scenarios. Scenario number one, a dog bites a man. You must have seen some news in the videos, right? Where the pet dogs in the lift, they are doing all the kind of nonsense things. Have you seen it, guys? Especially the residents or the delivery guys have been victim of the dogs, the pet dogs. So it is in our society also, but no such incident happened. But that is a very common phenomenon. A dog bites a man. Do you think it's going to be here or in the tail? What do you say? There are two options on the plate. Most likely observation, most unlikely observation. Very unlikely. It is going to be in the tail or it is going to be in the peak. Why it will be in the tail, Prabha? A dog bites a man is a natural phenomena. It will always be somewhere coming as a most likely observation. In India, every day a dog is biting somebody, right? It's a common phenomenon. The second phenomena I'll give you is a man bites a dog. The moment a man bites a dog, it becomes the breaking news. Very good, Pulkit. You read my mind, huh? A man bites a dog is like likely. Now, probably will understand why I was asking this. What do you think? A man bites a dog is very unlikely. It's like some psychotic behavior, right? That's how we put it. But I don't see this is going to be a common phenomenon, right? You guys agree or not? Hello? So it will be coming somewhere in the tail. Now it's clear, everybody. I'll take a pause. Right? Now you tell me, a dog biting a man is like a non-hypothesis. It's a normal behavior. To reject it, you have to come to the tail. Listen to me. A man biting a dog, you have to come here, and that is in the tail, very unlikely. So you will come here. Now let's say this is your p-value. I think this is your observed data point. This is your p-value. So I think this part of the chart, which these idiots have put, that's why sometimes I'm not happy. But see, this is a chart which I have gotten, but they're not doing a justice there. Okay, forget about what they have written. So these images I take it from the web, different places, but not everything is as per I would have done it. So forget about all this observed data point and all this, right? Now you know that you have a cutoff, remember? And you have another cutoff here. Guys, don't forget that. At least you know this, right? You know that this part of the graph is your green region. Let me do my way. If there is an easy way to create these diagram and all, I would have done all myself. So now if you see here, this is the most likely to happen. That's why it's green zone. This is this purple zone where the unlikely things happen. Agree? Everybody so far with me? Don't lose it. Keep holding on the thoughts, right? Now tell me, this is your reason of what? 0.025. Remember? Alpha by 2. And this is also 0.025. This guy is 95%. And this guy is how much? 2.5, 2.5. Don't forget that. Okay. Now you have a alpha. Alpha is how much? 0.05. You are saying that if your p value, probability value, is less than equal to alpha, you reject. Remember that. Tell me, p value is probability value. This is going to be the highest probability. Look on the y-axis, right? So if this is less than alpha, your alpha is what? Fixed. You fixed it. Somebody asking me alpha is going to be fixed. Yeah, you fix it now. Your alpha is 0.05 or for two tail you will fix it to 0.025. Depends on you. But let's keep it for 0.05. If you get any value which is less than that, you will automatically land in this region. Are you feeling it, guys? Where you have the less probability? This is your cutoff. Less than means what? You are going in this red zone, na? This purple zone. Everybody, I need your yes, no, good to go, right? The moment you say less than 0.05, so see, if I can give you some numbers, then you will understand the beauty. Let's say this is like, 0.3, this is like 0.2, this is like 0.1, this guy will be like 0.05, right? If you go lesser than this, you will come more toward the tail now. Are you feeling it, guys? People don't feel because they don't look at this. This is y-axis is probability only, no? Let me also tell you with so much confidence, you can go after this lecture, watch any video. It will be tough to understand because these examples combining everything into one story or narrative will not find anywhere. Maybe one guy after doing 1 hour of search, you'll find. Obviously, I'm not there. So you'll find someone X, Y, Z, but it's very tough. Trust me on that. Understanding the p-value, understanding the alpha, and understanding where to reject visually. As Soumya mentioned, explaining this in visually is very tough. And if you're able to explain, it's very easy then. Because everybody gives some statement, some gyan, that doesn't help. Are we guys cool on this? Why, when I say this line, it means it go to this region. Everybody has gotten this. You can say no if you have not. Alpha is 0.05, which is your cutoff, or alpha by 2. What do you set? If you want to go lower than this, you will don't go there. Because what in our head happens now, you always think like a kid, x-axis, y-axis. Suppose this is your cutoff, let's say alpha. When I write less than equal to alpha, your brain automatically will push you back. Isn't it, guys? That's what always happens. The moment you say less than alpha, so sir, it will go towards the left now. But what is the issue here? The left is more probability because this is different from your normal XY axis, right? So here alpha is less on the right hand side. Again, always remember, this is the distribution. You are not looking the x-axis now, buddy. You are looking on the y-axis, deciding on the x-axis. That's why it is confusing. You look at the probability on the y-axis, where the probability will be less as you come down now. Come towards the right or come towards the left. This is the highest probability, guys. This is the highest probability, this point. Clear? So that's why when you say p less than alpha, you reject. Less than equal to alpha, you reject. Because why do you reject also? Because it's a very unlikely observation. It's not normal, right? Again, I'll tie back to this diagram, right? A man kills his wife, right? Are we going to put here a man kills his wife? No, it's unlikely or likely. It's likely to kill a person? No. So I'll say a man doesn't kill his wife is likely to happen, right? And here it will be a man kills his wife. Unlikely. So now you understand why I say that not guilty is null hypothesis, because it is likely to happen. And being guilty is your alternate hypothesis, which will come here. Are we clear, guys? So if you observe, I have connected the dots. So now I will move on to the steps, typical steps in doing the hypothesis testing. Steps involved in hypothesis testing. So number one, null hypothesis means no change. It doesn't mean no assumption in running. You are assuming that he has not killed his wife, right? It means natural, anything which has no change in the behavior, right? So if you take my example, killing a person is not a normal behavior, right? It's not natural, right? Got it? So number one point, how to get into hypothesis testing. So first of all, you have to formulate it, you have to assign which one is going to be null, which one is going to be alternate. So formulate two hypotheses for analysis. Once you have done it, we'll move on to draw sample. So once you have done the hypothesis statement, draw samples from population for analysis. Obviously, it is for analysis, why I need to write. Third step will be perform appropriate test. And there I will be teaching you mostly tomorrow. I think we have a couple of more sessions. Perform appropriate statistical tests or techniques. Right? There I'll teach you multiple techniques. Last step will be either accept or reject. Accept or reject. We don't even talk about alternate. We always talk about accept or reject null hypothesis based on evidence. So when you try to do hypothesis, you are bound to make mistake, and there can be type 1 versus type 2 error. You might have heard about this in statistics, hypothesis testing. You must have heard about type 1 versus type 2 error, very famous. So let me show you a nice diagram. Doesn't matter what you do, right? You are always going to make mistake. Trust me. Chances will be less, but you are bound to make mistake. And the moment you make mistakes, right, you are going to get certain error. Okay. So first thing first, let me explain you what are these errors. So number one, if you see, you are going to see two normal distribution curve, right? And if you see here, if you take this curve as the base, which is your null hypothesis samples, right? And you are thinking it is null hypothesis part, but if you look at, this is your any mean value you have estimated, like, this will be equal to mu naught or mu one, whatever. Against this cutoff, can you see that? Against this line, something like this. Right, I'll share it so that it stands out. I don't know which color I should use. Yeah, this will look more, no, I need a light color. I'm stuck. Yeah, I think this will do a good job, right guys? Yeah, perfect. See, so now if you look at this, this is known as type 1 error. Why it is type 1 error? Type 1 error is a type of error which happens when there is a rejection of null hypothesis, which is when it is actually true. So let me take in my example. Suppose a man is being tried for the murder of his wife and he was innocent. A man who is innocent got convicted in the trial for murder of his wife. What kind of error is this? Come on. Guys, are you able to relate? This is your type 1 error. Generally, again, in the law and order, there's a philosophy that doesn't matter that if you set free some criminals, but make sure that you don't convict an innocent man, right? Have you heard of it? It's okay that you make mistake in punishing a criminal, but you cannot punish an innocent. But irony is that that it happens a lot of time, right? Across the globe, but the idea is to avoid it. This is known as blunder. This is not an error, it's a blunder. You cannot go with this. Even in any machine learning model, type 1 error is not accepted at all. Okay? Means how can you do that? It's like you're telling a man you're pregnant. I'll show you that image also. You're telling a man that you're pregnant is a type 1 error. Let me show you that image. It's a very cool image. Generally, it comes as memes, right? Let me just pull that for you. Yeah. So this is the image which I was talking about. You must have seen it in a lot of data science memes. Oh, this is a very bad quality image. Hold on. Yeah, this is much better. So guys, can you see this on your screen? Although they are calling, true positive, true negative, I cannot go in that yet because that's more of a classification, ML based kind of understanding. But can you see that type 1 error? It's there in the box. What is type 1 error? You are looking at an old man. He's the doctor, and you are telling him that you are pregnant. Obviously, it's a blunder, right? You can look at a pregnant lady and you can say you are not pregnant. That's your type 2 error. That is still acceptable, right? It doesn't harm anybody, right? But how can you say this to a man? So then, this is a typical example of making an error, right? In null hypothesis. And can you see that this particular part of the tail is a null hypothesis? But since you are overlapping these two guys, null and alternate, and you have a cutoff of mean, anything more than this, you say it is null, it is rejected. So you have rejected the null hypothesis, right? Anything before this, now can you see that, guys? This one, you have accepted the null hypothesis. And there can be a chance that if you look at this part, can there be a chance that this part is part of what another one, alternate also, right? Guys, please pay attention. So what's happening, guys? This is known as type 2 error. So far with me? So what is type 2 error? Type 2 error is the kind of error that occurs when we do not reject the null hypothesis equivalent to false negative, and when the null hypothesis was false, right? So this is as good as saying, I'll write, I need some space below it. I'll write here, this is like saying a man is proven not guilty. This also happens, by the way, even when he killed his wife, right? Are you getting, guys? This is equivalent to what error? Type 2 error. Type 2 error. Type 1 error, type 2 error. Right, guys, clear? As per the law and order, this is okay. Means I know you guys might be feeling, oh, how can you leave this person? But this is how it is. In case you make a mistake and a criminal gets free, it's okay. But an innocent cannot be convicted. Guys, there. Now I'll give you the definitions. So this is type 1 error. This is type 2 error. So type 1 error, when there is a rejection of null hypothesis, when it is actually true, and type 2 error, when we do not reject a null hypothesis, that is false. So this marks the closure of hypothesis testing, not from the example or use cases. This is more from the concept side. When I take this example in the hands-on, you will understand nicely.
Just a quick info, guys. Intellipaat offers data analytics course training. Through this course, you will master Power BI, data wrangling, data mining, and much more from the IIT Roorkee faculty and industry experts. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take the first step towards career growth in the field of data analytics.
Let me give you this and we can discuss on this. So whenever you're comparing two samples means, right? So you are looking at a population. So this is your population. Just imagine. I hope you can see my screen, right? And let's say you have two samples, sample 1, and you have another sample, sample 2. Now there can be two different population as well. So that's one of the way of looking at. You can have one population and you can have another population, pop1, pop2. You have two samples coming out of these two different populations. Now the question is that which t-test is being used where? This is known as paired t-test. I don't know if you guys are able to recall, those who have studied or not. Those who have studied. If you have not studied, definitely will not know. This is known as paired t-test. Okay. And what you are looking at, the other one, this is known as, if samples are taken from two independent population, two different population, this is known as two sample t-test. So far with me, guys. And this is something you have to keep in your head. Means you can't do much about it. These are the concept. Okay. So when you're trying to compare the means, two means like this, you have a two sample t-test, you have a paired t-test. There's one more thing when you compare the mean against the standard value. So let me take a population. You are getting a sample out of it. Sample. And you are comparing this sample against a standard value. Then this becomes your one sample t-test. So now you don't have two samples, you have only one sample. You have only one sample, right? And you are comparing against some standard value. Let's say I have a sample and I want to compare the sample mean against, let's say, 20, right? So that it will say that you are comparing with respect to 20, and that becomes your one sample t-test. Okay. So these are the different flavors of t-test. T-test works on the, as I was telling, that when you have the sample less than 30, then only you should use t-test. And there are a few assumptions, guys, like samples are independent. I just talked about homogeneity in sample variance, also known as homoscedasticity. It's a very difficult word to pronounce. And heteroscedasticity. Anybody recalls that? So homoscedasticity, let me use this word, means homogeneity of the variance. Can you see that? So whenever you're all the samples, right, sample 1, sample 2 are having the same variance, different samples exhibiting same variance, they are called homoscedasticity. Okay. So that's like more like, one assumption that we have to just check to apply t-test. And data is assumed to be normally distributed. So normal distribution, homogeneity in sample variance, and samples have to be independent. So these are some assumptions that you have to, follow, you have to comply, right? Now I'll get into more like a tree diagram. Suppose you are doing the hypothesis testing, right? You want to reach to a conclusion. Okay. And you are trying to do test. Now this tree diagram will help you guys. And this is about your population. Okay. So suppose you're doing hypothesis testing, right? And you know that in my, in my data, sigma is known. Okay, population variance is known, and n is greater than 30. Then you go ahead and use Z score or Z test. What is that? You remember I had taught. So you will take X bar sample mean, subtract population mean, divide by sigma by root under n. Okay, that's what we call Z test. Now Z test will also be of two types. So let me extend this a little further. Z test is also going to be of two types. One sample and two samples. Just like I have mentioned about t-test. One sample, it will be compared against a standard value. Two sample will be compared against each other, right? This is what we call as z-test. Okay. I will show all these things in hands-on format as well when will we reach there. Now, what is X bar? Sample mean. Let's get familiarized. What is mu? Population mean. What is sigma? Population standard deviation. What is n? N is your sample size. Any doubt on this, guys? This is your formula. Okay. Should be good. Give me a go ahead if you're clear about the formula and the bifurcation. If sigma is known and n is greater than 30, right, we will use that. This is all informative. We have to follow that. Means we cannot be questioning that how did it come. Uh, Definitely it has a history, but there's no point getting into it. Okay, we should learn how to use it. And that's where our focus will be. Then on the second side, we have a t-test, right? For the t-test, you don't know the sigma, so you come with S. S is your sample standard deviation, and n is less than 30. So these are the two criteria there that you don't know the population, standard deviation. You know the S. S is your sample standard deviation. Let me write here. S is sample standard deviation. And if you look at the formula, you will try to, so S is known and n is less than 30, right? Then what you will do, again, you will use a flavor of Z test, which is going to be replaced, my dear, please pay attention. Yeah. Going to replace your formula, which you have written Z. Now, since you don't have the sigma, what you will write? S by root under n. You have seen this as well. Okay. And this can also be one sample and two samples. Both are Z test only, guys. But the flavor is different, right? Now the question is that can we apply this Z test, n is less than 30? Then people say that, okay, X bar minus mu, and why don't we name it something else? Because it is similar flavor of Z test, right? But can be called like a Z test, right? No. When n is less than 30, right, you will name it as the t test, right? But if you see the inspiration is from here only. See, I'll take a pause here, guys. So similar to Z test, but you are renaming it given that your requirement of the sample size, and you say that it is t test. Okay. See, the only thing which you are looking at this as differently, my dear, is the sample size, and S is known. You don't know the sigma. So your t test, what I've written here, you will observe that it is close to z-test. That's what I'm highlighting, nothing else. Okay. What is the name of symbol of standard deviation? So I've written now, see, x bar sample mean, mu is population mean, sigma is population standard deviation, s is your sample standard deviation, n is sample size. I think I've written everything. This is what we call also as student t-test. So by default, we say loosely t-test, or you will say student t-test. Clear? Now, moving on, there can be, sometimes people say, what is one tail, what is two tail, right? So let's understand that one-tailed versus two-tailed test. Okay. First, understand two-tailed test. Right? Two-tailed test. So let me show you one nice diagram. So this is the two-tailed test where you say if the population mean is equal to sample. Can you see that? This is what we are saying. Population mean is equal to sample mean. That is going to be your natural hypothesis, right? Population mean is equal to sample mean. And here we are saying population mean is not equal. So guys, at the moment you say not equal, it can go in any direction. Say, if you say it is not equal, it can go either towards right-hand side where it is, more than the population mean is more than the sample mean, or it can go to the negative direction, sorry, left side direction when the population mean is less than sample mean. That's where you need, when you're trying to have hypothesis like this, you need a two-tail test. You cannot do one tail. Why? Because you don't have a direction there. Do you have a direction that you will go towards left or right? No, it's bidirectional. It can go any direction. So for that, you have already seen me doing this study, the whole game, the same game, right? Alpha is, are you able to focus, guys? This is your rejection region, also known as significance level. This is where when you reject your null hypothesis, let me write, and this is for alpha equal to 0.05, which is your level of significance or significance level. And when you say that your probability value, p value, is less than equal to alpha, what do you do, my dear? Reject the null hypothesis, which basically means H naught. The moment you reject, either you will come here, this part of the chart, or you come there. This is your rejection region. This region is known as what, my dear? 1 minus alpha, which is 95%. This is the reason where you will accept that your null hypothesis is true. Basically, you will say that your population mean is equal to sample mean. Let me shade. Now, this is two-tail test. There can be another one, which is one-tail. Now, one-tail test can be left or right, both. Because it's a directional one, right? So either you can go left or you can get right. Just for our reference, I'll use left. So when you say left, means your population mean is less than the sample mean. See, I'm saying, my dear, population mean is less than the sample mean. And alternate hypothesis is that null hypothesis is same only. Population mean is equal to sample mean. So now do you guys agree that, or you can see whether it will be a one-tailed or two-tailed will be dependent totally on the way you are forming the hypothesis. You guys agree? Now this is known as left one-tailed test. So you can clearly see that the whole of the 5% is sitting here. And I'm not going to share it now, it takes time. And this is your total acceptance region of 95%. Are we clear? And you can imagine the right hand will be what? Just opposite of it. Let me also quickly show you. So we'll see the rejection region on the right hand side, as you can see on the screen. See, total 5%. And So Rani is asking in the previous example, alpha was 0.025. No. In both the cases, alpha was, it's not alpha, it's alpha by 2. Total is this alpha, right? That's why you can see 1 minus alpha is 1 minus 0.05 will get you the 95, right? That you are going to use z-test when your n is greater than 30, even equal to 30 will work, and population variance is known. Always remember that. Population variance is known means what? Sigma is known, right? You will always use t-test, student t-test, when n is less than 30 and population variance is unknown. That's why you use sample standard deviation. Clear? Now there are different t-tests. I have already explained, but just giving a nice description about it. One sample if you're comparing it against a standard value, two sample if you're taken from two different population, right? And if the two samples are taken from the same population, right, you will use pair test. Okay, I'll give an example also. So I have a couple of examples to explain. I think that's what maybe someone is asking. One sample t-test, it tests whether the population mean of a single population is equal to a target value, right? Some target value. For example, mean height of female college student greater than 5.5 feet. So this is your standard or target value you are comparing against, right? That's your one sample. Two sample, when you say you are going to compare the difference between the means, right? See that? Of two independent population. So you say that, okay, you have a target value, but the target value is the difference between the means of two independent population. So then the example can be, does the mean height of female college student significantly differ from the mean height of the male college student, right? So there are two different colleges, right? One college is only for female students, right? So that's your sample. It is your female college. And you will take a sample called S1. Similarly, you have another sample, which is male college. And then you will extract another sample. And then you will compare the difference between the mean, right? Using these two samples. Got it? The difference between one sample, two sample? Perfect. Let's do a question, guys. The following data represents hemoglobin values in gram per deciliter for 10 patients. Okay. So number are 10.5, 9, 6.5, 8, 11, 7, 7.5, 8.5, 9.5, and 12. Question is the mean value for patients significantly differ from the mean value of general population? So guys, the data you are seeing is a sample, and the mean value of general population of hemoglobin is 12 gram decimeter per deciliter, right? At alpha equal to 0.05. My first question to you guys, look at this question and tell me that it is what kind of test you're going to do on this. Come on. Very good, Prabhat. T-test is correct, but what t-test? One sample, two sample, or paired t-test? One sample. This is correct. So guys, you are going to do, since n is less than 30, how much is n? N is equal to 10, which is less than 30, and you have the sample compared against standard value of 12 gram per deciliter, right? So this gives me, combinedly I can say, combining these two, it means I need to do one sample t-test. Okay, so let's do that now. So what is going to be X bar? And we know that N is 10, N is 10, X bar is what? Sample mean. So you have to do this sum of all these values. I'm not going to do till the last. And divide by 10. If you do that, guys, you can confirm it later. It will come out to be 8.95. Right? Then we need to calculate the sample standard deviation. The formula is root under xi minus x bar whole square, I equal to 1 to n, divided by n minus 1. So basically it will be 10 and this will be 9. That's how you calculate sample standard deviation. Guys, if you do this maths, you will find 1.80. So what is your t statistics? X bar minus mu by s by root under n, 8.95 minus 12, 1.80 root under 10. Don't worry, in the hands-on, you will be getting this as a result in 1 second or maximum 2 seconds. Python will do it. So now, guys, we have the t statistics value. What is it? Generally, what we do now, once we have the t stats, t statistic, we take mod of it. So if we take mod of, yeah, guys, so I think I'm audible, right? So what you're doing, you're taking minus 5.35 and taking mod of it, right? Clear? So what you're doing, you're taking the t statistics and taking mod of it. There's a reason for it, and you will understand the moment I show you the t statistics table. Again, you will look at the table. Please focus. So this is the table, guys. And in this table, you will have a couple of things. One is your degree of freedom. That is nothing. That is n minus 1. So your sample size minus 1 is your degree of freedom. That is something you have to keep in your head. So tell me what is n minus 1. 10 minus 1 means 9, right? So we'll come here, 9. Okay. Now it says that what is the critical value for this particular question? You have an alpha, which is 0.05. You have an n, which is n minus 1. So you have two things, or you need two things. Like, let me put it like this way. You have a degree of freedom. Yeah. Tell me for degree of freedom 9 and alpha equal to 0.05, where you are intersecting, guys. You are intersecting a cell called 2.26. Hello, very good. So it basically gives you the T critical value coming from the table, 2.26. What is the T stats? You have got it, T statistic. That is 5 point, although it was minus 5 point, what was that? Sorry. Minus 5.35, but since it's all in positive, we'll take a mod. So it is 5.35. Now, there's a condition that if your T statistic, and that's what you will learn step by. So I'll give the steps once you have these value steps. So number one step is what? Calculate T critical at given significance level or level of significance and degree of freedom from the above table, right? That's number one step. And you know that that is coming, T critical coming 2.26. You have done it. Step number two, if T critical is greater than calculated value, which we known as mod of T statistic, then what you will do, my dear? You will accept the null hypothesis. Maybe I'll use green. Accept the null hypothesis. Okay, that is 2 ka A. There can be a scenario where T critical is less than equal to calculated value T statistic, and then you will say reject the null hypothesis. If you compare this equation with this, remember, this you can compare like P is greater than alpha, and this is P is less than equal to alpha. This is just your reference point. Are we not saying the same thing, guys? Come on. Now let's look at the diagram also. So by the way, what is happening here? What, as per our question, what is happening? Your T critical is 2.26. T statistics is 5.35. Which one is what? Definitely T critical is less than equal to calculated value. Right, guys? Since T critical is less than T statistics mod, right? So what you will get, guys? The conclusion, you are going to reject the null hypothesis. So basically you are saying that sample mean is not equal to population mean. It is not a true reflection of that. And look at the values now. Your sample value came quite low, right? 8.95 sample mean. Look at the values, the different values, right? You have as high as 12. You have as low as 6.5, right? So that is definitely not putting you in that confidence that your sample is a true reflection of your population, and that's why you are going to reject it. Even you can visualize it, and you can also come to a conclusion from the T statistics, right? Now, if you try to put it into a understanding of the same distribution thing, right? So here, if you see, this is going to be two tails. So again, this will be 2.5%. This will going to be 2.5%. Let's say this is your T critical. What is that value? It came, guys, 2.26. So you know that your T critical is less than the T calculated value. T calculated value is what? 5.35. Although trust me, this is like, somewhere here minus 5.35. And this will be minus 2.26. Symmetry. That's why I'm saying positive, negative. Isn't it? It is in this rejection region, my dear. You know that this is your rejection region. Or you can say that it is significant, statistically significant. That's why you're rejecting it. So we also say, right, this T statistic is what? In one way, we will also write it as statistically significant. Why it is statistically significant? Because it is higher than the critical values, and you will reject the null hypothesis. So basically, it is going to be in this. So this is known as what region? Rejection region or significant region? Significance region. I have shown you that. If you're not able to recall, let me go up and show you the diagram. See, it's there now. Rejection or significance level, right? I hope you are following here, right? See, look at me. I'm getting into the details of the things, right? I hope you can see that efforts. Trust me, nobody teaches like this. I know what others are doing, right? So are you feeling that okay, it makes sense, right? The statistical tests are making sense. Even for a smaller sample, you can make a judgment and it looks correct. Generally, when you do in Python, it will be just telling you one line. It will give you this T calculated, this number, and then it will say that whether you can accept or reject, and if you reject, that's it. Behind the scene calculation I'm showing. I'll take a pause here, guys. Guys, give me a good to go if you are following this. Rest others are going to follow the similar kind of style, right? Pindran is asking with this example what decision can be taken. So we just understood now that sample mean is not a true reflection of the population, right? So you are saying that the hemoglobin sample is not a true reflection of the population, right? So you see different behavior in the sample and the population. You might need to do a different sampling approach or something else, right? But this sample doesn't reflect the hemoglobin level for the population because it is significantly differ from the mean, right? So you can write a conclusion like that. Yes, that's correct. So let me write also. So what is the conclusion? Sample significantly. So it significantly differ from the population from the mean of the, I should write here, from the mean of the population hemoglobin. Let me find some more questions for you guys. I want to do a 2-sample t-test. Now, why don't you look at this? So it's a more like a MCQ question, guys. You have to choose one correct answer for it, right? So you have me or a restaurant owner wants to test if her 2 managers, so let's say it's an organization, it's a restaurant, right? And Mio wants to test her 2 managers perform at the same level, right? You're comparing 2 managers, whether they're performing at the same level or not. So what they're doing that she collects the data about the number of customer complaints at 2 random sample of shifts, right? So there are 2 managers working in 2 shifts, one for each manager, right? You know, right? In restaurant, people work in shift. Someone will start at 6 and they will go till, maybe 6 a.m. in the morning. So shift 1 can be 6 till 3 p.m. So 6 a.m. to 3 p.m. And another guy can come at another shift, which will be 3 p.m. till 12 in the night. So what she's doing, that she's collecting sample for this manager and this manager. Sample is all about number of customer complaints. So far with me, guys? And then the summary of the result they have given to you. So mean is 4 complaints, 5 complaints. Standard deviation is 0.3, 0.5. Number of shifts they have done 19 and 21. So this guy, she has collected for, let's say this is manager A. This is manager B. So how many shift data she has looked into? 19, and here she has looked into 21, right? 21 days, so 21 shifts. In that, she is trying to come with the number of complaints. Now the question is, what you are going to use? Means how do you solve this? Do you have an idea? Definitely, this is going to be 2-sample t-statistics. No idea? So it's not that easy, huh? So guys, here you are going to do or use the statistics called T, and here you're going to use sample mean x1 bar, x2 bar. Here not you're going to write x bar minus mu, and then you're going to use this formula s1 square by n1 plus s2 square by n2. Okay. This is the formula we use all the time. Now, that's the reason that I am telling you this, because this formula can be derived. And I hope you know, right, everything here. X1 is, let me write. This is something you are not supposed to remember because you are going to code in Python, so you can easily use it, but you should write. This is sample mean 1, x2 bar sample mean 2 for the second population sample. Then S1 is what? Sample standard deviation 1. Follow me, guys. S2 means sample standard deviation 2. N1 means sample size 1. And N2 means sample size 2. So when you do two sample t-tests, you do the difference between the mean. This is much important. So guys, 4 minus 5 you will do. So this is correct, this is correct, this is also correct. So definitely out of these options, these two are gone. Right? Now standard deviation is what? 0.3 whole square. So I think this looks more closer, right? So what is the right answer? I think a lot of people are already there. Answer is C. Very good. But tell me one thing. This is so very close, but why this 0 is coming? If you look at the exact formula now, there will be one more term which we generally assume as 0. So the formula says sample difference. Definitely it is x1 bar minus x2 bar. But you are also subtracting, well, there is one more difference, and that is known as hypothesized difference. So basically, I'm saying population difference, if there is anything, and then standard error of the difference divided by standard error of the difference. So what I have seen, people missing this, x1 minus x2 bar, and you also do this, my dear friends, please pay attention, mu1 minus mu2. So this mu1 minus mu2, if you think that the population mean difference is also there, this comes from the null hypothesis. If there is no difference in the population mean, then what you will set mu1 minus mu2? Come on, tell me. If there is no difference in the population means, it implies that you put mu1 minus mu2 equal to 0. That's how you put this equal to 0, and that's how this 0 is coming. Are we clear, guys? See, I'm telling you everything. Denominator, no change. You will still write the same. S1 square N1, S2 square divided by N2. Good? Comfortable? I hope you like this question, right? It's easy. Then you can do a number of things. So if someone can calculate this T statistics quickly for me. What is that? 5 minus 4. Sorry, 4 minus 5. Do the maths, anybody? Root under 0.3 whole square by 19. 0.4 whole square by 21. 0.5. How much it is coming, guys? I hope someone is calculating for me this thing. Okay, Siddharth is telling it is coming to, what is the T statistics you have gotten? Minus 14.46. Okay, anybody else? I need a couple of guys to tell me. And degree of freedom you have to also take, na? So see, N1 is equal to 19, N2 equal to 21. So you know degree of freedom will be what? N1 minus 1 plus N2 minus 1. So actually it comes out to be N1, N2 minus 2, right? So how much is that, guys? 40 minus 2, 38. And alpha, if nothing is given, you can always take 0.05. Okay? I'm just confirming my degree of freedom. Let me open my notes. I think it is N1 plus N2 by minus 2 bits. That's correct only. So this is your degree of freedom. Now look at the table. I know this is 38. I don't know we'll have 38 in this. No. But these stats df equal to 38, alpha equal to 0.05. It's very tough. Generally, you should not get worried, because I think sometimes these things trouble us, but that's fine. There's a website called Mera Calculator. Significance level 0.05. And calculate this. So don't worry, this is here. That will give the critical value. I'll give you the calculator also, don't worry. Now everybody, guys, what is the value for that? So see, this is a calculator for critical value. I've taken 2 tail 0.05, 38 is my degree of freedom. So that gives me this value. What is this value, guys? So T critical comes out to be, please help me here. It is 2.0249. What is my T statistics mod? Come on, everybody, quickly. Minus 14.46. Earlier, you told me how much? Someone can also confirm that. So this is 0. Nobody is calculating, but I assume that this is what, but I don't want to assume. That's what the problem is. Leave it. 0.3, 0.5, right? These are the values. 0.3, 0.5, 19, and 21, right? So my equation is 0.3 into 0.3 divided by 19. I'll just do this. I'm using Excel, by the way, in case you're wondering what he is doing. This plus this, and I'll do square root this, and then I'll divide -1 by this number. It comes minus 7.7518. I don't know what you guys are doing, right? Okay, hold on. Guys, I'm getting totally a different value. It comes minus 7.7518. Why you are getting so many different values? Minus 7.7518, period. That should be the value. Why you are getting different values? What's going on? आप लोग calculation नहीं कर सकते. So it will be 7.751. Definitely you can see that it is higher, so you will reject null hypothesis. That's it. Clear? Prava, are you comfortable? I think this is what I'm looking at the table, getting it. So what you are saying that definitely there's a significant difference in the manager performance level, because they're not same, right? Which one is better, which one is not, that is a different question. So now guys, next thing we can look at is the F test. Okay. So I'm putting the heading F test. So F test is more to look at the variance of two populations, right? Not the mean. So when you want to compare the variances of two populations, you are going to come to F test. Okay. And there are a few assumptions similar to like t-test, normal distribution of the data is independent. So generally when you are trying to do the F-test, what you do, you try to check if my screen is up, right? If the variances of the two populations where the groups are taken from equal or not, where the groups are taken from equal or not. So there are, two populations, you have extracted two samples. Let me draw. This is gen population 1, this is pop 2, and you are extracting a sample 1, or group 1, and sample 2. So what you do, you try to estimate using two samples that the variances for the two populations are same or not. Are you able to understand, guys? What you're comparing? You're comparing the variances are same or not. Earlier you were comparing the means, remember? So what will be your null hypothesis? So null hypothesis can be variances are equal and alternate hypothesis is, you know that variances are not equal. Okay, null hypothesis, and this is your alternate hypothesis. Once you have it, then you calculate the value of F. And what is the formula we deploy? It is larger sample variance. Which one is larger? You will put it on the numerator, divided by smaller sample variance. That is sigma 1 square divided by sigma 2 whole square. Okay. And then degree of freedom you need. And that is going to be, there will be 2 degree of freedom, df1 and df2 because of two populations. So because of two sample, n1 minus 1 and n2 minus 1. Okay. It's very easy, guys. Trust me, it's more easier than t-test. This is the distribution table for F test. Can you see that? Now you have a degree of freedom 1, see, and you have a degree of freedom 2. Let's say for any of those, let's say hypothetically, your degree of freedom is one is 8 and another is 12, let's say. So where you will reach finally, guys, come on. What is your T critical? 2 point whatever this. What is this number? 2.50. Maybe I can shade it like this. So where you are intersecting, guys, 2.50196, that becomes your F critical. And then again, the same game. You will compare. They will try to, come to a conclusion. It is also known as, F test is also known as variance ratio distribution test, right? Some fancy name, but you have it. So trust me, there are a lot of distribution. One of the distribution is F distribution. But the problem is that we cannot get into too much of the distribution also because that's not in the scope of the syllabus. But you have a T distribution, you have a F distribution. So the sky is the limit. You have a chi-square distribution, right? There are quite a few distributions. But our aim is to, look at F distribution and try to get into any of those kind of analysis. But rather than looking too much into distribution, our focus is directly look into the, the test, and so that you can handle it. Okay. Formula is clear, Indrani? I think so. See, formula derivation, if you try to do, then you will get a little out of the place. Okay. Any sample limit, I think no. As you can see the notes, we are not talking about n has to be less than or more than, right? So you can use it. And this table is for different alpha, guys. So just one thing I missed to write is that this table which I've given now, this is for alpha 90%. So 0.10. You can also have alpha for 0.05 like that. So this is a very good website which you can look at it for the table. So for different alpha, different table is there and you can leverage that. Okay. So these tests I will show you in the hands-on. Don't worry about it. I have a good case study there. So I'll do that. But currently I'm just trying to acquaint you guys with the formula and what kind of, and how to do it, on a piece of paper. But when I'll have a right data for you and then show you, then you will understand, oh, there I have to use it like that. Okay, so let's try to do a question on this so that you get a better understanding of it. So this is the question, guys. An insurance company, let me give you the question. An insurance company sells health insurance, right? And motor insurance. So let's say you're looking at ICICI Lombard, right? It's an insurance company, guys. ICICI Lombard. They sell health and motor. Motor is like what, guys? Health, you know, right? Any Mediclaim. What is motor insurance? Motor insurance is a vehicle insurance, right? Like bike, car, right? So they are selling this, and the CEO of the, obviously customer will pay premium. We always pay, we don't get. The CEO of the insurance company wonders if either of the insurance segments are more variable than other. Variable means the moment you see this word variable means what? Variance. Are you getting? So he finds the following data for the premium paid. So I'm going to give you that table, and that is, I'll just write. So you have two segments. I have to draw this table, guys. You have health insurance and you have motor insurance. And you have motor insurance. Health insurance variance is in terms of dollar and the sample size. Perfect. Looks like a nice table, guys. I'll punch in the numbers. So variance is $200 and sample size is 11, $50 and sample size is 51. Okay. So now, guys, I'll solve this question for you. So first step, you have to frame the hypothesis. So you will say null hypothesis is what? You will say the population variance is equal. Hello? Null hypothesis will tell you to put what? Sigma 1 square equal to sigma 2 square. Alternate, you will frame H1 sigma 1 square sigma 2. What I have done? Sigma 2 whole square not equal. Step 2, you will calculate F statistics. The moment you say you want to compare the variances, you will go ahead and you will say, let us calculate F statistics. So we will use that. F value is equal to sigma 1 square, sigma 2 square, right? So we will do 200 by 50. Already they have calculated. You don't need to do it. So the ratio is 4. Step 3 will find the degree of freedom. Remember? So degree of freedom 1 is equal to n1 minus 1. So 11 minus 1. So 10. Degree of freedom is n2 minus 1. It will be 51 minus 1. So 50. So far with me, guys? Now they're telling that definitely it is going to be two-tail test because they're telling whether they're equal or not. So two-tail test, and let's say we take alpha 0.05, right? So now we will get into the table for alpha equal to 0.05. So I'll click on this and I need two-tailed, hold on guys, F table for 0.05. This is a good table. Why do you need the table? I'm giving the table in the chat and you can, I have already shared the link here in here. So when the notes will come and who you can take it, but if you want, you are insisting, I can share, not a problem. But you don't need the table. Yeah, guys, now come here. This is for alpha 0.05, degree of freedom 1. Degree of freedom 1 is how much? 10. Degree of freedom 2 is how much? 50. So we don't have 50, so we'll try and converge in between 40 and 60. Okay, so depends on it, right? You will not get everything what you need. Okay, but if you're solving the question, they should give you, but it's okay. So where they are going to cut, if you draw that line, somewhere here or here, right? So you don't see a much of a difference, right, between 40 and 60. It's all in the 2 range, right? So I can say F critical is how much, my dear? Equal to, let's take 2 now. And what is the F stat? We have calculated a 4. Tell me, 4 is greater than 2, so you will reject the null hypothesis. Now you're feeling it, right? Rejecting, accepting, you are like dealing like a boss. Are you guys feeling the same or it's only me? And you see, it's so easy, right? Once you have gotten the hang of it. It's not that difficult, trust me on that. The real value as per my solution is 2.026, right? For the F critical, this is 4. So what is our observation? Observation is that definitely their motor insurances are varying. Simple. In which direction we need to see. But definitely the variance is significant. And the C of the company, what he is wondering is correct, right? His hypothesis is proven true. So if the premium paid by either of the insurance segment is varying a lot. And as a matter of fact, right, I think last week only I did an health insurance. I paid 25,000 for 1 year, a year. I'm giving real data. This I took in SDFC. This is a disclaimer. I'm not promoting any insurance company. Don't get me wrong. And I also did a motor insurance. I paid something, 1,060 a year. And this I did with Echo. So I think our CEO is right. The CEO is not right. CEO is not wrong, right? It does vary, guys. And this is real data I'm giving. Okay. And even if you take a normal, so this is like a little premium one, but even if you take a normal health insurance, 8 to 10K you have to pay. Mine is a little expensive one, I agree, but even a normal one will do. It will vary. So coming back to the question, it will vary. Okay. Good, but I hope you are liking my examples. You're able to make sense out of it. I want to do one more question, guys. Another good question. So the bank has a head office. I'll help you with the data. The bank has a head office in Delhi and Mumbai. Has a head office in Delhi and a branch in Mumbai. Okay, head office in Delhi, branch in Mumbai. There are long customer queues. So a lot of queues are there at one office, while customer queues are shorter at other. The operation manager of the bank wonders if the customer at one branch are more variable than the number of customers at another, right? And then he does some research. So what he has done, the variance of Delhi head office customer is 31, and that for the Mumbai branch is 20. The sample size is 11 and 21. Carry out a two-tailed F test with a level of significance 10%. Okay. What I'm saying, guys, again, you know the hypothesis. I'll not get into it. So you know that you have this Delhi head office, HO, and the Mumbai branch. Okay. You have the variance in here 31 and in here 20. Sample size in here it is 11 and in here it is 21. Now guys, quickly tell me. So this is your table which I have generated for you after reading the question. What is the answer? I know there will be a obvious mistake people will make. I'm damn sure about it. See, always remember that the high variance will go on the numerator, right? Remember, I have given the line somewhere. Larger sample variance will go on the top. Now, out of these two, which one is larger? Larger sample variance, not large sample, larger sample variance. So 31 is on the numerator. Very good. I think that's correct. So you are right. on the right direction, sigma 1 square, sigma 2, this is your F. So 31 by 20, it comes out to be 1.55, right? What is N1? Sorry, what is degree of freedom? 1, N1 minus 1, so 11 minus 1, so 10. Degree of freedom 2, N2 minus 1, 21 minus 1, 20. And now alpha is what? 0.10, right? 2 tail test, 0.10. I think I have given that. So degree of freedom is 10 and 20, right? So we can look at this table. This is alpha 0.10. So degree of freedom 1 is 10. So you can look at here 10 and 20. So you can just do this cross. 2 point, what is that? 2.20. Guys, please pay attention. 2.20074, right? So your F critical is 2.20. And your F statistics is, it is 1.55. So definitely you can see that F statistics is lesser than F critical. F stats is less than F critical. So you are not going to reject. So null hypothesis accepted. There's no change. So the line, the queues are not varying, as maybe the operation manager is wondering. So it is accepted. There is no variation in the number of queues, right? That's what we conclude. Okay. So not every time it will be like what you think is correct, right? They're telling that if the customer at one branch are more variable than the number of customers, no. More or less the number of customer coming to the branches, whether it is head office in Delhi or a branch in Mumbai, they are more or less same. So you cannot just only look at 31 and 20. You have to also normalize this with the sample size. That's where this is coming. Okay.
Just a quick info, guys. Intellipaat offers data analytics course training. Through this course, you will master Power BI, data wrangling, data mining, and much more from the IIT Roorkee faculty and industry experts. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take the first step towards career growth in the field of data analytics.
So I hope you can see the screen. So let me put the heading ANOVA. So ANOVA is another statistical test, guys. Any idea what is ANOVA? Any idea, guys? Samina is telling more than 2 samples. But what do you compare in ANOVA, Samina? Mean. Okay, very good. That's correct. Very good, Samina. So let me share this and talk through. So ANOVA, also known as analysis of variance. See, till now we were only compare means variance between two groups, right? Either you were doing one sample or you were doing two sample. Let's say if I ask that if I want to compare between more than two or more groups, and I want to compare the mean, what method I should go with? Because these will not allow me, right? So that's where ANOVA comes into the picture. Although the name is analysis of variance, but it tries to compare the mean of different groups to understand that, how one group is significantly different from the other group. Clear? Again, then we have certain assumptions that samples needs to be independent, right? Another one is very important, that all populations should have common variance, right? Homozygosity. And samples are drawn from the normally distributed population. Okay, so ANOVA, there are different types of ANOVA, but the one which is we are going to cover in the syllabus is, let's say, one-way ANOVA. So one-way ANOVA is basically an extension of t-test, right? An extension of two independent sample to handle more than two populations. So for example, you have population 1, population 2, and you can go till end population K, 1, 2, up to population K. So you will observe that you have how many groups? You have total K groups. So here the idea is that, if I want to find the difference between the means, right? I'll follow an approach which will help us to, find the variation among the sample means. So everyone will have a sample coming out of it. Sample 1, sample 2, and sample 2K. So just for the three groups, right? Let's say for K equal to 3, I can show you one diagram. See that if that makes sense. So look at here. So this is how the different populations are running. But do you notice one thing? That all these guys are having similar variance, right? The length of this arrow. So the first thing you should observe that the three populations have the same variance, the common variance. You guys agree? Can you see that? Although their mean are significantly different from each other, but if you compare the means between these two guys, sorry for the very blurred photo, but it is very helpful. That's why I'm using it. So if you look at this, can you quickly see that there's not much difference between these two? So mu1 and mu2 are look closer. However, they are significantly different from mu3. Can I say that, guys? Keep following. So there are three population, 1, 2, 3, having three different means, and you're trying to compare it. So far with me, guys? Any question till now? Okay. So once you have a fair idea about that, what it does, why don't we get into the calculation, the approach, how do you do it? Okay. So let me give you the F statistics for this. So how they calculate, guys, they will use F and they'll try to find variation among sample means and normalize it with the natural variation, or you can just write variation within groups. Variation within groups. Okay. So, or you can write, mean sum of squares between the groups, mean square of errors, which is MSC, and mean sum of square between the groups is known as MSP. So finally, it boils down to, MSP by MSC. Just keep that in head. And we are going to deep dive on this. So let's understand first thing first, what is MSP? So as the nomenclature suggests, that it is mean square between groups. Okay. So how do we calculate it, guys? There's a formula called SSB K minus 1. Suppose you have K population, you will do K minus 1. Okay. There's a formula, you can't do anything, you have to keep that in your head. But I'll explain it later. So you actually write xj minus x bar whole square. You will not understand much here, guys. I'm telling you, you just note down the formula. And then here you write nj. Okay. That's your MSP, which is SSB by K minus 1. We have another one called MSE, mean square of errors. I'm going to explain, but first let me give you the formula. So this is going to be SSE, sum of square error, n minus k. So basically it is sigma nj minus 1, nj minus 1, then another sigma x minus xj bar whole square, okay, n minus k. So it comes to sigma nj minus 1, and this comes to sj square n minus k. So basically this n, which is you are seeing, is known as total number of observations throughout k groups. This is like the big total. So let's get into an example, okay? Because we need to calculate this in the, in a very simple step-by-step approach. Ideally, end of this exercise, you will be trying to create this table, which I call ANOVA table, source of variation. Some of the things you have not gotten yet, I know that, so please don't worry, just follow through. I'll explain with the example. Between groups, this is your error, and this is your total. The three segment, if you see. Now, number one thing, we have to calculate sum of squares. So you already know you have to calculate SSB between groups. Error will be SSE. So this is something you know, it is NJ. SSB on the top I have written XJ bar minus X bar whole square. Okay. NJ XJ bar. Guys, I missed the bar here. XJ bar minus X bar whole square. Okay. XJ bar minus X bar whole square. Okay. SSE is double sigma X minus XJ bar whole square. Total is SST, which is SSB plus SSC. Then you need a degree of freedom. So number one is DF1, K minus 1, DF2, N minus K, DF3, N minus 1. Okay. Mean squares. So MSB equal to SSB K minus 1, MSE, SSC by N minus K. Okay. Then finally we'll calculate F value, which is the ratio. MSB by MSE. Okay. So I know this is a little overwhelming, I think, but let me try to explain you by taking an example, and I think you will get it. I don't see any reason that you will not get it. So I'm sharing my screen, guys. I hope you will see the Excel, because Excel is going to be easy for us to calculate. Later on, anyway, we will do in Python later on. But let's see if you can see my Excel, guys. Can someone please confirm? So let's say I have a table which says that times required by 3 workers to perform an assembly line. So they are working in an industry. Assembly line tasks were recorded on 5 selected occasions. So let's say let's say we are the people. So this is first worker is me, second worker is let's say Dilip, third is Pratika. Okay, let's say I'm just picking names from the chat. So now let's say these are the numbers, guys. 8, 8, 10. Okay. 10, 9, 9, 9, 9, 10. Okay. 11, 8, 11, 10, 10, 9. Yeah. So these are the 5 days on the 5 selected occasion. 1, 2, 3, 4, 5. So far with me with the data, guys. And this is all in hours, okay? So let's say 8 hours, 10 hours, 9 hours, 11 hours, like that. Hello? So now tell me, and you have to tell me, there are 3 groups. Maybe I can give you 3 colors. Okay? That's why I'm coming to Excel. You like it, the way I teach this. The 3 population, 3 sample, right? So far with me, guys. If I ask you what is the sample average, what is the sample average? So I think you know, right? What you will write quickly? Average of what? Each of these kinds? 9.6. You find sample for Dilip, we do 8.8 and Vartika is 9. This is your sample average. What is sample variance? So you know that it will be variance and this will be S for sample. See 1.3, 0.7 and 0.7. Okay. So far with me, guys, come on. Not done any rocket science here. Nothing I have done. Give me a go ahead, guys. Yeah. Now there can be overall average also. And that will be what? Average of not across the population. It is going to be the average of the whole guy across the total N, right? So how much is that value? 9.4. So far with me, guys. Come on. Now also tell me what is the value of N and what is the value of K. N is to like what? How many total? 50. And how many groups are there? 3. Good. Guys, come on. Yes, sir. Now we need to calculate sum of square between the groups. How will you find sum of square between the groups? So guys, what is the formula says for sum of square between the groups? It says that you will use Nj, and let me write, and the beauty about Excel is that I can write also. So maybe I can write here. Nice. Doesn't disappoint me. What is SSB? SSB is equal to sigma Nj xj bar minus x bar xj bar minus x bar whole square. This is the same formula I've given. Yeah. Okay. So guys, let's understand that. What is the meaning of Nj? Nj is number of data points within each sample, which I had not written there. Now I'm writing. Nj is what? Number of data points within each sample. I'll share the Excel also. Don't worry about it with formula. Okay. What about Xj? This is your sample mean. And what is this X bar? There is no J means overall mean. Right? You can say just sample mean. Sorry, my bad. We'll say this as overall mean. And you know the numbers also, right? So sample mean is how much? This is what going to be the sample average. So I'm giving the arrow because I like giving it. Sample average and overall mean is this number, guys. Good. Now SSB we can calculate. So first thing first, how many number of, it is 5 into, now you have to write NJ minus, so this, oh my God. Yeah. 5 into sample mean 9.6 minus overall mean, right? Whole square. I hope you know a little bit of Excel. Please don't say no. Plus, you will do the same thing again. You'll write 5 into, come on, what is it? 8 point. You know why it is happening? Because of this idiocy I have done. I don't want this also. Sometimes arrow is not good. Yeah, let me write now. Fast. So 5 into 9.6 minus 9.4 whole square plus 5 into, not unusual, the next group. This a minus 9.4 whole square plus 5 into 9.8 minus 9.4 whole square, and that will give me the value of sample mean. Sum of square between that. Right, guys? So far with me. So this is your sum of square within the groups. That's why you're doing, right? 9.4, 9.4 all the time. So far with me, guys. Come on. So this is known as variation. This is known as variation between the groups. Interesting. Now I need to find sum of square error, which is actually within the group itself. So for that, what is my approach? Approach is very simple. I'll do n minus k, right? Sorry, nj minus 1. So it is going to be, right? Remember the formula, nj minus 1. Let me write the formula. What is sum of square error? It is sigma nj minus 1 into sj square, so variance, divided I will do later. No? That's it. For now, you need to follow this. Okay. So now what's happening, guys? This nj, which I've written. Yeah. So let's calculate this equal to nj minus 1. So each group has equal number of sample. This is a very simple case. So you do 5 minus 1 into C12. What is C12, guys? For me, it is variance, right? I have calculated it now. What is SJ square, guys? Your individual variance plus 5 minus 1. Then I'll do this variant, 5 minus 1. Are you guys following with me? Then you are doing this variance. Done. 10.8. So you have the variance already calculated within sample variance, right? Remember, what is this SJ square? This is your within sample variance, right? Guys, give me a go ahead if you are able to follow this. So that gives you SSE. So what is your SST? Sum of these guys. So what is it? You will sum it up 10.8 plus 2.8, 13.6. That's your total. Okay. This is SSB, SSE, SST. This is not your MSB. So to get into MSB, remember I had given a formula. To get into MSB and MSE, you have to use a formula, and let me show you what is that. You have to divide it by k minus 1 in 1, and 1 you have to divide by n minus k. So ideally, MSB and MSE will calculate by the division. Remember, what is the division? You will take this SSB and divide by, come on, help me out here. What you are going to divide by? K minus 1. What is K? 3 minus 1. So how much is that? 1.4. SSB is what? This divided by what? N minus K. 15 minus K. Remember? That gives you, what did I do? I7. Let me rewrite. Sorry, yes, something I missed. This value at 7 divided by N minus K. Right? Perfect. This is cool. Now you tell me now, what is the value of F? It is the ratio of MSB by MSC. 1.556. Wow. Guys, isn't it easy? Now, once you have the F statistics value, right, what you will do? We need to find something, right? So what we will do? Let me share back my OneNote. I hope you can see. I'll take the screenshot of this example. Don't worry about it. Can you guys see the OneNote? Now you tell me, you have F statistics. What is going to be your F critical? Calculate it now. F critical. So F critical is going to be calculated. So this is what you have calculated is known as F statistics. Remember? And that is coming 1.555, whatever, 1.55. It should be stop here. F critical is what you will find, and that's going to be a question mark for us. Now you have to use certain rules. So first number, alpha is 0.05. One of the degree of freedom is k minus 1. Another of the degree freedom is n minus k. So this is equal to 3 minus 1, our case 2, and this is equal to n. N is 15 minus 3 is 12, right? And you will be looking at a table, and this is what I have to show to you. Maybe I'll write here. Well, this is good. So guys, tell me degree of freedom. So this is between the groups. So you will come here, right? And one is you will come here, and then you will draw a line and compare. Where are you able to circle it up, guys? Here, 3.89. This is the F table for the degree of freedom for the significant alpha level 0.05. Guys, are you seeing that? So now you tell me your F stat is what? Less than the F critical. What do you do in this case? Accept the, nothing changes. Accept the null hypothesis. So, and what was the null hypothesis? That your means are not significantly different. So, what means that the means are more or less close. And let's see that. One of the mean is 9.6, one of the mean is 8.8 and 9.8. So, it's not significantly different. You might be wondering, is there a way that we can show that the other case? So, why don't I move on to the same example? Right? What I'll do now, guys, I'll just copy paste the whole thing, and that's the beauty about Excel. You can just replicate in nanoseconds. See, you have to just update it that okay, Akash is very hardworking, as you know, right? I'll just put some weird numbers like he's working 18 hours in 24 hours, right? So definitely I'm in line to beat Narendra Modi, our PM. Can you see that, guys? My F statistic is 21 point something. I hope you can see my Excel. Right, guys? Come on. Now, definitely I'll go back to my sheet, OneNote. Now, if you see, tell me, again, get back. So, what is the value of critical? Critical will not change now. because it depends on the alpha and blah, 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 right? So what is the value of F critical? It is, what was that, 3.89. What is the F stat? What do you see? So you see that F stat is more than F critical. So what? Reject. Reject means you say that the difference in the mean, in the sample means, is significant. Are you feeling it, guys? So what I have made you learn today, and now I can see that you can understand, and give me a word if you are with me, that looking at, so for, when I gave you those mathematical sigma and all, I know a lot of people are from non-mathematical background. So for me, it's like back of my hand. I can do like this. But for you, it can be tricky. That's where I, strategically weighted you, put you on hold that, okay, come to this table and then you suddenly understand. Wasn't it easy, guys, getting sample average, sample variance, overall average, using into the formula, right? How was my approach? You guys agree that rather than talking too much into the mathematics, why don't I show an example and then you'll say, wow, this is easy. I mean, I feel that it works, but I don't know. That's, you have to confirm. And let me put this Excel save as before it gets crashed. So yours is 11th October, right? 11th October. And I will say ANOVA example so that you know. And date is December 8. Let me share this file first. But did you get ANOVA, guys? I think so, right? Yeah, a lot of people already commented. Thank you. This is good. Take the Excel, guys. Please confirm. It's not letting me share it. Wow. Now I want to give a question. If you have no question, and I hope you like it. Shall we do it? Yeah. Suman. So K is number of sample group. Yes. In this question, it was 3. Suman, is it possible to share Excel sheet? I just did it now. Okay. This is a literally a very good question and we love it. Okay. And here you go. No, I'm just formatting. I was just formatting the question so that it looks good. Can you see the question, guys? A pharmaceutical company conducts experiment to test the effect of new cholesterol medication. Very much required. It's a real pharma question. The company selects 15 subjects randomly from a larger population. Each subject is randomly assigned to one of the 3 treatment groups. Within each treatment group, subject receive a different dose of new medication. In group, whatever they have given, 0 mg per day, 50 mg second day, and 100 mg per day. So actually they're telling, my dear, is this, that first group 0 mg, group 2 50 mg, group 3 100 mg, medication difference. After 30 days, doctor measured the cholesterol level of each subject and the results for 50 subjects appear in this table, right? Different, these are cholesterol values, okay? In conducting this experiment, the experiment had 2 research questions. Does dosage level have a significant effect on cholesterol? It's a very obvious question, guys, right? Second, how strong is the effect of dosage level on cholesterol? So about significance and the degree of strong. So guys, take your time. I think it will take some time. So, but you have to do this. This is the only one exercise which I feel that you should do it. So take your time and do it. You can use my Excel sheet. That's what I've given. You don't need to do manually writing formula. I hope you are thinking on that line, right? Be smart. Yes, right? You can use my Excel sheet now, update the data. Because I'm going to do the same. It will not take them more than 2 minutes. If someone asks me question in the Q&A, I can try sharing. Or if you are in Discord, you can get it from there. I've just pasted it there. But it will be taken as an image. Because you have to write. I think it will not take much time. Pratik. Good. Indrani has gotten F equal to 4.146. That's not correct. Something you missed. Anybody else? I hope you guys are doing it. Okay, let me know once you are ready. Okay, so you guys are getting 4.16. Okay, let me also try. Maybe you guys are right. My answer is not correct. And share my Excel again, which I have shared with you. So the number are 210. I'm going to update 240. Guys, can you see the Excel? Right, 210, 240. What is that? 270, 270, 300, right? I think I can copy this. No, it did not work. What about this? Yeah, it did work. Right, guys? So now you tell me what is this, obviously the color formatting has gone, but we can only say we need to text. And we can quickly color so that we can see that it's different. 3 groups. And here you go, right? So you can clearly see that the average is what? 258. I'm just making sure that N is 15, K is 3. Overall average looks correct, right? So it's coming 4.16. Okay. You guys are good. The answer key was showing something else. I'm just checking the formula, guys. Just hold on. Okay. So we have F equal to 4.16. And we know that F critical is what? Let me put this back in the OneNote and sharing back the OneNote. Again, we have already calculated that 3.89 at 0.05. So we know the maths. What is it? F statistics comes out to be 4.16. F critical is 3.8. It was no 3.89. So definitely F statistic is more than F critical. So it is going to be reject the null hypothesis, right? Definitely it looks meaningful that, right, the different doses will have different impact on the cholesterol level, right? Can you see that? So they differ. See, different mg will impact on the cholesterol level differently. And look at the sample average. It looks that 210 is little better. So 100 mg medicine is making your cholesterol level little lower, guys, isn't it? Means we have a view, right? 260 and 210. Definitely there is quite a difference. You cannot say these. See, you can say more or less these are similar range, but it does impact. So if I have to put a visual, so I can say that, hello, you have 0 mg, you have, what do you mean by 0 mg? 50 mg, 100 mg. So you have cholesterol level 258. You come here, you have a cholesterol level 238, and that's 246. And then you come here, you see that your cholesterol level has come down to 210. And this is like, guys, not from 0. This is like, let's say 150 range 2. Can you see that you have a downward trend coming down? Not like drastically, but it does come down. I have done this so that you can feel this coming down slightly, but it is coming down. So guys, we are going to import certain libraries, like, import NumPy as NP, import pandas as PD. These are standard ones. Import operating system for working directory. Import matplotlib dot pyplot as PLD. Import cbon as SNS. Right? Cool. This should work. Yeah. These are the libraries, guys. Please type in so that you have it ready. Now we will start with first test, which is our Z test. Maybe I think this is okay. Z test is good one. Let's do it. Okay. So from SciPy import stats. So SciPy is Science Pi. So I'll ask you to install this. Means call, not install. So guys, let's start with one sample Z test. Okay. So you know that one sample Z test, if I can give you a point, you know that what it does, checks whether the sample comes from a known population, right? Remember, where population mean and standard deviation sigma should be known, right? Standard deviation sigma should be known, right? So I need to find certain data to do this. Just wondering which one to take. Okay, guys, please pay attention. So do you recall, right? One sample Z test we do to do what? Just to give you a flashback. So let's say you have let us say that you have a sample data and you want to test, I'm writing in plain English, you want to test if the sample mean is significantly, you don't need to type, I type fast because I do it all the time, different from the population mean. That's why do we do this? That's the reason for you doing it, right, guys? Come on. So what I'm going to do, I'm going to just create a sample data, like you just type in a list. So sample, I can give number 3, 4, 5, 6, 4, 6, 4, comma 6, comma 5, comma 4, 6, comma 3, comma 5. Okay. And let's say the population mean and standard deviation I assume is this. Follow me. So I say that population mean is pop mean 4.5 and population SD standard deviation is 1.2. Okay, there are two variables I have created, guys. Now I'm going to perform one sample Z test. So for that, what I'll do, I'll write Z statistics. So there are two multivariable I'm creating, guys, and P value. And then I'm going to use my function stats dot Z test. Did I run this? Yeah. Sample is my sample. Then I need to give value. In this, it has no attribute called Z test. Really? Import SciPy as stats. Maybe this is another one we should use. So guys, it's also in SciPy only. SciPy little big one, right? SciPy stats as stats. Okay, let's run it. Now I think you should get interesting. Hold on. Stats dot Z. Okay. They have updated Z statistics, they're called. But this is not the Z statistic. This is to my variable name now. Z score. Hold on, guys. I'm missing the, what to say? I'm missing the formula. Is it Z score or not? Because I don't want to keep breaking my head. Let me just refresh my memory. SciPy Z-test. Let me get into the, I think it will be Z-score then. But then I have to put in array and all. I don't want to do that. That's why, see, I'm not going to use SciPy. SciPy is like, how to say, like not good. I don't like it. Okay. So the Z-test one, which I was trying to do, guys, it seems that it's not working out for us. Okay. So guys, the reason is that I was not importing maybe the right libraries. So we have to import from stats, the models, stats, that's why it's missing. Maybe let's see that. Wait, stats, import Z-test. Wow. Now it will work, guys. So we have to call. So I'm giving two value, to be honest, Z-score and p-value, and I'll say just Z-test. Simply, right? Yeah, it picked up sample, and value will be equal to population mean, pop mean, and pop standard deviation. Okay. And let's see. Did it do anything? Oh, I missed one thing, na? My bad. Sigma is equal to pop. Now see. Oh, sigma is not there. What is it? Value alternative 0 use variance pooled. Showing different. Suddenly my all the older ones, it doesn't work. That's it. Like it's a very simple one. I don't know why it's not giving the right answer. Did I run this, guys? But how can we? It's 0. So alternative fraction. No, guys. Let me do one thing. I'll do away from this because this approach, this library is not helping me anything. Okay, here. So what I'm going to do, I'm going to install another library. You guys also do it. It's not a very good one, which I was trying to do. So it is known as BioInfoKit. Okay, let me put in the chat. You also install. This is not going to be there for you. Oh, for me it is already installed. Can you guys try it out? Sorry guys, let's not go there. Using this Z-test from SciPy, it's not giving me satisfactory answer. Please try installing this, guys, and let me know once you're done. We'll use this library for all the statistics. Can you guys confirm once you're done? Okay, perfect. Now what you have to do, you have to call this bioinfokit dot analyst import. This is to get data. So you can also get some data which is inbuilt data for doing Z sample, one sample Z test. So to give you some background about this data, forget about the data I was looking at, because that's anyway some mocked up data. Now let's come to this data. So guys, this is to get sample data for understanding the statistical test. Okay. Now let's say I have a data, which I get it from this function, get data. So this is the function you're calling, get data, and there you will call Z1 sample. You have to write Z1 sample. So, and you have to say data. This is the way you get data, guys. Okay. Wow, perfect. This works, right? So it's a data frame, right? And if you see it is a series, right? If there's only one column, it's a series. What is the key to install? You have to do pip install. I have written in the chat. See, Suman, I did not get your question. Are you asking how to install? You have to do pip install by InfoKit. Now, this data is, guys, it's a factory data. Let me talk about a little bit more about the data. So I can give a factory produces. I have it, guys. Why to type? So this data talks about a factory produces. A factory produces, the tennis balls of diameter of 5 centimeter. But due to manufacturing condition, every ball may not have exactly the same diameter. Maybe I can put it into, Then the standard deviation they are telling of the balls is 0.4. Now the quality officer would like to test whether the ball diameter is significantly different from 5 centimeter in a sample of 50 balls randomly taken from the manufacturing line. So did you understand the problem, guys? There is a factory which manufactures the tennis balls, right? The ideal size is 5 meter. So they have taken a sample from the population, right? So let's say you have a lot of tennis balls. You have taken a sample which is of size 50, right? And these samples you are going to use for the one sample Z test, because your sample size is greater than 30, and you are going to say that, okay, whether your sample size uh, mean is equal to 5 or not. That's the sample Z test you will do. Okay, I'll take a pause with this. Are you clear with this data and question, everybody? This is more interesting, and this library has everything. I am not doing anything from my side. So now, guys, once you have the data, what you can do, you're going to use the Z-test function available in the BioInfoKit library. So to do that, you have to import from bioinfokit.analyst import stat. So first you imported the data, now you're importing the function, and then you will call the function using rest. You can put some result result dot z test. Now z test needs a data frame number one. Suppose you have your own data, you can also run it, right? So you have to give a data frame x equal to your column name. What is the name of the column? Just go on the top and read sizes. So you'll put the sizes there, and then you have a mu. So what is the population mean you want to compare against? 5. And what is your x underscore standard deviation? That is 0.4. And test type is equal to 1. One sample is test type 1. Let me show you the documentation. The documentation issue is that it's a library somebody has written, right? But I can give you the documentation screenshot because it's written by people like us. So see, pandas data frame containing X group. X is the column name for the X group. Mu is your, hypothesized or known population mean. Standard deviation for the group. Alpha you can also set, and type of Z test, use one for one sample Z test. The moment you run this now, you are done. And then you can print the result summary by using the function result summary. And you will be happy to see the output. And if you look at the output given by SciPy library, right? Let's say, for example, I show you one sample Z test SciPy stats output. Let me show you this. If it is in the image. No, one sample Z test SciPy stats. Let's see. Right, so they calculate the Z score, guys. I don't know if they've given some example, but look at that. No, this is not the Z test. One sample, yeah, it seems to be this one is Z test. It's a T test. First of all, finding the Z test has become like something, I don't know. why they are not able to do. But anyway, but if you say this is the t-test they are doing, and if you look at the output, can you see the result? Look at that. This result is like very lame. Hello? See, z-test, t-test, same now. So t-test result, look at that. The result we get in our function, look at this. So structured. You can take a screenshot and you go. So first thing first, it shows sample size 50, mean 5.0176, Z value is 0.317. And now they're giving p-value for one tail, two tail, lower, upper, everything. Now you tell me, what is the interpretation of this? Soumya, tell me. Is the p-value significant? What is the concept? Concept says, if your p-value is less than alpha, you reject. Less than equal to alpha, you reject. What? Null. If your p-value, don't forget the basics, is greater than alpha, accept. Remember that? Now tell me, for alpha 0.05, which is our standard, what is the p-value you are getting? 0.75. Even one tail is 0.37. So it is p is greater than alpha. So are you going to accept the null hypothesis or reject? Accept, right? So what is the interpretation, my dear? What is the interpretation? So interpretation is, I'll write p-value obtained from the one sample z-test. One sample z-test is not significant. And you can write z value, since p-value is more than alpha, right guys? And therefore, we conclude, what do you conclude? That the mean diameter of the balls in a random sample is drawn from the same population. I hope you understand. Are we good, guys? Okay, so I think we'll continue from here, but this is how we are going to use this library going further as well. So the jet test we will do. So we'll go sequentially, hypothesis testing, everything we'll do what we have done hands-on on the manual or manually we have calculated. Okay. But do you think it's an important tool for the quality managers? Think about it. Is it practical for any quality manager that, okay, you open every tennis boxes ball and try to check, right? It's impossible. So what they do, they take the batches of production and they will take sample and they will run a Z test, right? And if they are statistically they are getting this, what we have gotten, they'll say, okay, pass. They are not going to check each and every ball, right? They will just, obviously they'll check each and every ball in the sample, not in the population, and then try to quickly, estimate against the population and say that, okay, it is not significantly different from the ball sizes which I need to produce. So I'm more than happy to pass your batch. So that's the whole cycle goes through here, right? Okay. They have updated so I'm not using SciPy stats library. I'm not used for long. I always taught inferential by using this library. But let me ask you guys, did you install this? Everybody, give me a go ahead on this. Were you able to install pip install bioinfokit? It's very important. You love it. You will love this library. You will forget about SciPy stats. SciPy is also famous for other, like SciPy has a lot of, you see, SciPy has quite a lot of functions. It's not only one. Look at that. But you will love the bioinfokit a lot because it has good example. It has data itself to learn. So I really liked it for inferential statistics. So I found this library and then I started teaching using this library. And that's where I'm not using stats. And it seems they have updated few things. That's why I was not able to use that function, but you can take a shot. Soumya, Prava, you guys can see that you can do it, try doing it using SciPy as well, using SciPy stats. I'm missing it, but I can also spend time to refresh. Something I'm missing, I'm damn sure. Okay. Okay, so Indrani library installed kernel restarted with getting this error. Okay, so let me give you this. Can you put exactly? So that's what I was trying to do. I thought you can just put me saying asking this. I'll put in Q&A. You just copy and paste because if you make one mistake in the spelling, even one character you forget, it will not work. So I can give you this. I think Vinay is asking. So this is the library you should use. But Vinay, don't forget to install it first. To install, you have to use pip install. So why not I should give this also. Okay.
Just a quick info, guys. Intellipaat offers data analytics course training. Through this course, you will master Power BI, data wrangling, data mining, and much more from the IIT Roorkee faculty and industry experts. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take the first step towards career growth in the field of data analytics.
Now we can move on to do the two sample jet test, right? Okay. Who can tell me that what do we do in two sample jet test and how is it different from one sample? Anyone? Two samples from two population, okay? And then, so guys, what you do here is this. The two sample unpaired or independent jet test calculates if the means of two independent groups are equal or significantly different from each other, right? Make sense? Now here, what is your assumption? Assumption is that your population standard deviation, sigma 1 and sigma 2 should be known, right? Uh, and then you are also aware that your null hypothesis will be two group means are equal. I think I can write that as well. So that's your null hypothesis. Alternate hypothesis will be two group means are different. Okay. So just make, yeah. Let's take the example. Okay. So it's the same example I'm going to take. Now, this time in this example, we started with a factory population we started with a factory which manufactured the tennis balls, and then we were comparing with the certain parameter in the one sample. What we will do here you will have two factories. So here you have two factories in two cities, and here we are saying that there are factories A and B in cities. Sorry, a factory in cities A and B produces balls of different balls of a diameter of 5 centimeter. The defect is reported in the B factory, which is known to cause a change in ball size. So if you observe this line, there's some defect in the B factory, and that is leading to some change in the ball size. Standard deviation of the balls is 0.1. The factory quality officer randomly select 50 balls from both the factories to test whether the ball diameter is significantly different, from each other, right? So if I can show that visually, it looks this. Correct? Factory A, you selected 50 balls. Factory B selected 50 balls. Both the factory have standard deviation equal to 0.1, and then you're going to compare it. Okay? This is the premise of the problem. What you're going to compare here? you're going to compare that the two sample means. Which are the two sample means, guys? You have two samples. You're going to have two sample means. Are you going to compare these two? Let me highlight and you can say yes, no. Yeah. So this sample and this sample will have some sample mean, right? You're going to compare that whether these two are equal or whether these two are unequal. Right, guys? Come on. Remember? Let's do that. So again, you have to, I think everybody has this library by InfoKit. And from here, you can need to get the data first, remember? So take the get the data, that's the command, get data, and you will say Z underscore to sample. See, this is my data. Looks nice, okay. So there are two factory A and factory B, and you have the tennis ball sizes there. Now I have to call my function stat, okay, and I'll say result z test, and data is my data frame, okay. X will become my factory A, Y will become your factory B. So you're giving the column names, guys, and see these are here, factory A and factory B. Shiva, you are raising your hand. Is it by mistake or you have something to discuss? Standard deviation. Although in this case, standard deviation is same for both of the guys. And test type will be 2 because you're doing 2 sample test. Okay, guys? And this syntax is something very intuitive, right? Obviously, if you're comparing two sample, you need two columns. So you're going to put x equal to and y equal to something here. X and y standard deviation, you can put it here. Alpha is by default 0.05, but you can set it to some other alpha like 0.01, 0.10, all that. Okay. And print result dot summary. It's so simple, means if you look at that syntax, it's intuitive, yet the results come very nice, right? Look at that. Sample size for X 50 count, sample size for Y 50 count, mean of X 5.01, mean for Y 5.99. You can clearly see that they have some difference, but let's see. P-value for P-value for one tail and two tail is 0, 0. What do you say? P-value, whether you are doing one tail test or two tail test, it is 0. So what is the interpretation, guys? Z value is what? Minus 48.86. So if you have minus 48.86 and the p-value is this 0, right? Now, I think if you remember the concept I had given, if p-value is less than equal to alpha, what you do? Reject or accept? Reject. So null hypothesis you will reject. So you will say x1, x2 is equal. You will say no, means h1 will be accepted, means there is some defect in that, right? So can I write the commentary, guys? P-value obtained from the two samples. Z-test is highly significant. My throat is not good, guys, so bear with me. Highly significant, and you can write in bracket P-value is less than alpha, and then you can also write, which is 0.0. 0 is definitely less than 0.05. This indicates that there is a significant difference in the ball size produced in factories A and B. A and B. So can we conclude there is defect in the machine for ball production in B? So we can hence conclude, hence we can come to a conclusion that there is indeed a defect in the machine for a ball production in factory B. Okay, this is it. And that concludes our two sample jet test. Shall we go ahead? What is next in the sequence? We'll do t-test, right? Student t-test, because I think we just did the z test only, right? Okay, so let's do the t-test. T-test. Guys, t-test is also known as student's t-test. I don't know why they have mentioned that as a name. So t-test is similar to z-test, to be honest. The only difference is that z-test follows a certain rules. So z-test says that n has to be greater than 30 sample size. T-test is for the small sample size. Okay, specially developed for the small sample size. So I can write as a point the t-test. Let me write is specially developed for the small sample size. You don't need to type, guys, ignore this. So where we say data has to be n less than equal to 30. N less than equal to 30. Now, guys, there are similar to one sample t-test, one sample z-test, we have one sample t-test. So let's do that. It's similar to what we have done for z-test. So I'll write one sample t-test. Okay. So it is similar to what you have done for the z-test. You are going to, it is used for comparing the sample mean with the specific value. Okay. Generally it is known as mean of the population value, right? That's what we compare with. Second thing, just to recall, in the t-test for you, the population variance, which is sigma square, is unknown. Population variance, I need the symbol. Sigma square is unknown as compared to z-test. Z-test says that you need to have population variances, which means, so basically they're interested in the population standard deviation. Here, population sigma square variance is not known, and hence it is estimated from the sample variance S. Okay. Okay, cool. So again, we'll start with the one example. So here I'm going to, load the data as data frame, pandas data frame, get data, and you have the data t underscore one sample. Okay. And this is the data looks like. These are the symbols which you have to keep handy. So you can either write sigma square in English. Right? How can I see that, right? Now, if you compare this, then you say, oh, the sample size is more than 50, right? I think this is not a good data for us. By the way, guys, it doesn't harm you to do the t-test, okay, first of all. So even you can see this data is only for one sample, and this is for t-test only. But if you observe and if you're with me, it is like 50 records. But still, nobody's stopping you from running the t-test. But it's not the other way around. If your sample size is less than 30, then it cannot run the z-test. But if the sample size is more than 30, you can either run the z-test or t-test. However, just to make a point here, that t-test is specially designed for n less than equal to 30. But let it be what it is. I can run this on this t-test. So I will again, similar syntax called res equal to stat. So that's your function. Then you will call t-test. Data frame is data frame. Test type is 1. This is equal to size. That's your column name. If I recall correctly, yeah, size of the balls, right? And here you want to compare it with mu equal to 5. Now, if you let me take you back to the one sample jet test. See, isn't it a similar? Yeah. If you see here the syntax wise, see x equal to size is mu equal to 5, something like that, right? So syntax is pretty much similar. You can just run this and print the result summary and you can use it. Now here in the syntax, df equal to data frame, test type 1 means one sample t-test. What are we doing? One sample. One means, okay, Shubhangi is asking also. One means Shubhangi, one sample t-test. Size is your column name and mu is your population name. Are we clear? Now, what is the value? See, degree of freedom, it is calculating nice. N minus 1, very good. 50, average is this. T value critical is 0.36. And then you have a comparable value as well, right? So now here you can see that you have a P value and you have a critical value, correct? So either you do the critical value comparison with the, with the alpha value, or you can always use the P value as the base. So now you tell me here, P value here, and doesn't matter. I think in this case, you can use two tail. Two tail is 0.71, is less than 0.05. No, it's more than. So definitely it is not significant, right? Come on, Janta. This is 0.36. Even if you put this and you have a T critical for the P value, so lower is 4, hold on, 5.33, 4.77. Now you are saying that your T value is 0.36. Okay, so according to that, you will find the value here or here. So you will see that if this is in the critical region, you will reject it. But if you're saying it is 0.36, means you know that end of the day, this value can be compared against the critical value. So what I'm trying to say, hold on, T value calculator. Can you see my screen? Yeah, I think you can see that. So now what is the degree of freedom? You tell me. 49? Calculate. So what is your T value? It is plus minus 2 or 1.67. Depends on the one tail or two tail, right guys? And by default, your alpha is 0.05. Let me show you. Again, what is alpha by default, my dear? 0.05, right? So now you tell me if the T value is like where? 1.67 and 2.09. So your T critical, which you have gotten, is where? So you do to take mod. So your t value is how much? 0.36789. And then if you remember, I had taught, and what is the concept? I'm giving the screenshot. Hold on. Give me a sec. Can you read it, guys? So what we are saying that if the t critical is greater than the calculated value, right? You will accept the null hypothesis. Focus this. This is coming from your notes only, guys. If you are not able to recall it, right, you're definitely missing it then. This you remember, I had given that either you can compare the p-value, again I'm telling you again and again. So if t is greater than the critical value, less than critical calculated value, critical less than calculated value, we reject the null hypothesis. So which one we will do here? You tell me. What is the calculated value of t? 0.36. What is the critical value we just saw? You take any one of it, 1.67 or 2, depends on our test. Let's take 2. If you take the mod of this and then say, is it less than or greater than? It is less than. No? So it satisfies what? T critical is, so T critical is 2. It is greater than the 0.36. So you will accept the null hypothesis, guys. Which one is calculated? This one, which is coming out of the distribution, right? The test. So this is your t coming from your test. Critical is fixed, which is 2, right? Plus minus 2.09. So I'm taking mod of it and then saying that, okay, this value is definitely, t critical value is definitely more than the calculated value. So you are going to accept the null hypothesis. Other way around, you can say that if the p is greater than alpha, right? So take the two-tail p. So this is your value 0.71. Is it greater than 0.05? Yes. So again, you will accept the null hypothesis. Revise in your head. Okay, so Indrani, you got it? Can I move on, guys, to the next one? 2 sample t-test. So again, it's similar. It compares the means of two groups, determining whether they are equal or significantly different, right? So what it does, guys, it compares the means of two groups, okay? And in the 2 sample t-test, we compute the sample 2 means because of the reason that we don't know the population variances, right? So we need to do that, okay? So now what we are going to do, we are going to take 2 genotype of the plant. So in this particular example, we are going to say we have 2 plants and 2 plants have 2 genotypes. Geno is like genome types, right? And we are comparing the yield. So if you talk about, if you know anyone knows about agriculture, they would know this, that different types of crops are there. They are doing a lot of crops DNA sequencing to get a better yield. Okay, and that's they want to compare if the genome type A and genome type B have a different yield altogether, right? I'll just highlight it, this part. That's the data we are going to talk about. Okay, that's the situation. So, yeah. So I'm going to load the data set, guys. Load data set as pandas data frame. You will say df getters underscore data. T sample dot data, right? And see here. So you have 2 different genome type, right? And you have the yield. Now the issue with this data is that the genotype A and B both are in the same column, right, guys? Can you see that? So we have to do a little bit of data manipulation. So what we will do, now this data is coming from the library itself in Rani. Well, I think you were present in the last class, right? This all data is coming from a library called BioInfoKit. And to do that, you have to import, I can write again, dot analyst, and here you have import get data. This is what I'm running. Okay. And in case you're not able to see this command, you have to pip install by it. Clear? I'll not do that. Okay. So this is my data. So maybe I will convert this by using df.log, and I'll say df genotype. And what I'm doing, guys, here, I'm saying that I'll take the A genotype and the yield for it and convert into NumPy. So this is, you might be seeing for the first time, but it's very intuitive. You're taking the data frame and you're putting into an array. Oh, something I missed here. So you see now this is coming as an array. See, guys, it's like you're filtering in the data frame for the genotype A. What I did in this command, in this, what we have done, we have taken genotype A and we have filtered for the yield, right? And then converted into the array, right? Similarly, you can do for genotype B as well, right? So be smart, just copy paste and just say this and bingo. Now what you have to do, so you have A and B, two arrays, separate arrays. Now you can say, I'll call this st dot, so t test independent, A equal to A, B equal to B, and I will compare equal variance. But I think I'm missing something. Here, I think this is I'm doing using SciPy's library. Okay. This is just to showcase you that you can also use SciPy library, right? And so from SciPy import stats, yep, as st, and there you will say st equal variance true, and to get the output, so this will get you the result. See, very poor result, to be honest, but you can use it. You can say that, okay, p value is what? P is what? 0.0029. So you can round it to 0.003. Is definitely less than 0.05, right? So you're going to reject the null hypothesis, right? That's one way of looking at. And I want to also do it by using bioinfokit, which generally I have done so far. So that is very much simple, to be honest. So what you have to do, guys, you have to just call the result stat, and you need to do nothing in terms of data manipulation. You can just write data frame equal to data frame, and you can say X factor because you have two genome type. You will use the column. Remember that you don't need to convert into array. You know that this is like a factor data because it has two levels. So you'll just write the column name genotype. You will say result equal to yield, and test type will be 2 because you're doing two sample t-test. And you will say print result dot summary. Everybody is comfortable with this. What I'm doing, guys, now that's a way of showing that this doesn't even need any data preparation. You can use the column which has different levels. You can use the other column called yield. Test type is 2, means 2 sample t-test. By default, alpha is 0.05. Let me show you that in the syntax. You can do this and see alpha is 0.05, right? And look at the result. So detailed result. Look at the result this guys get. One line, just read and understand. Here, mean difference, t-value, standard error, degree of freedom. My God, p-value. And it's not like that it's giving you some wrong answer. 0.029. Are we not getting two tail elves to the same number? But it gives you some more insights about the data. And now you know that since the p-value is less than alpha, so you can interpret that, and that I'll do it one line. Here it goes. So see, the p-value is less than 0.05, right? And therefore, we conclude that the yield of genotype A is significantly different from genotype B. I had told you, this is very easy, very easy. All these statistical tests, it just looks little awful in the beginning that what is going on. So many things are there. But again, when you come to me thinking that statistic is tough, and I say you that, oh, it's very easy, then definitely doubt at once. But then as we go into the details, you will realize that, wow, this is very simple. And you're right that exploring things and telling my students. Shubhangi is telling, is it possible to change significant level to 90? Why not? Yeah, yeah. Let me go there. So you can put here, you can call alpha. See, you can put 0.01, that's your 90%, right? 10%, 1 minus alpha is 90%, that's your confidence interval. And then you will see that, see, this value has slightly changed, but not much, to be honest. But you can clearly see that it is, no, lower is 99%. So my bad, I put something wrong. Yeah. Now see, this is your alpha, 0.1. Morning can be a little tricky. It seems I am sleepy. Yeah? Alpha equal to 0.1 is 90%, not the other way around. See, you will not see a significant difference in the values, to be honest. Let's move on. Yeah, paired, I have not done, it's not different, right? It's similar to that. If you want, I can show you if you are interested. I have not even tested for paired Z test, but if you want, I can quickly show you. So in terms of the approach, nothing changes, to be honest. The only thing you have to be careful that it is used to compare the different means of the two samples coming from the same population Zyva, right? So it's going to be the same population, but it will be taking two samples, just like you do in exit polling. So you'll go to the constituency, which is the same population, and you keep asking different set of people. Okay. Okay. So it's not a different thing. Some of the things I leave up to the students to explore. So if you're cool, I'll take it up. But for now, I want to get into ANOVA. Okay. ANOVA, let me ask who remembers. So what is ANOVA does for what it does for us? How is it different from anybody else? Remember, this method, ANOVA definitely is a statistical method. But how is it different, guys? It compares analyzing the differences, not variance. Differences in means, but in three or more groups. That's the difference. Till now, you were doing only two groups, right? Now ANOVA comes and says, what if you want to compare the means in three or more groups, right? And then I had taught you one-way ANOVA. So which is in one-way ANOVA, there's one independent variable and two or more groups, or it can be levels also. Let me show you this. You know that null hypothesis will be all the means are equal, and alternate hypothesis will be they are not equal, right? See, clear? So what we are going to do, we are going to take an example, and there are 4 treatment groups for ANOVA analysis. So if I can show you the data, this is the data, guys. So there are 4 treatment groups, A, B, C, D, and all these treatments are independent variables. And since there are 4 treatment groups, so there are 4 treatment levels as well, the factor. Now we have to compare it. Okay. So now I think we need the data also. So what I'm going to do, I'm going to read the data from this website. Okay. So everybody, I hope you have imported pandas as PD. Cool. I'm going to read this data, pd.read underscore CSP. And I'm going to put this website link, right? And you will see that the data is there. But I can see that there is a separator called tab. So I'll also put that. Ta-da. Now it will look nice. Yep. Don't worry, guys. I'm going to put this in the chat. Can somebody say hi on the Q&A? I'll put this in this line in the chat so that you can take a look at it. So you can pull the data like this. Okay. No need to copy paste. Because you cannot copy paste if it's an image. So you have to actually get the data. That way you can learn that you can also read data from websites. See. Let me know once you have it. Done? Okay, cool. Everybody with me, give me a go ahead. I see some of the guys are okay. Now, if you talk about this data, so before you can do one-way ANOVA, you need to do some data transformation. So basically, I mean to say that you have to reshape the data frame, or if you are trying to do it by data frame DF, in case we want to use SciPy stats, right? But see, that's the reason if we keep need to changing the data frame, we'll not use it. So what we'll rather do, so let us use the bioinfo kit. Okay. Spelling is correct now. File not got. Can you check in the Q&A, Dilip? So what I'll do, guys, but I think I'm just wondering that do we have to do the melting of the data in this case as well? Because that's what it seems to me. Got it? Okay. So let's melt it. Okay, fine. So what I'll do, we are going to melt the data. So let us melt the data. Okay. So I'll show you there's a function called melt, pd.melt. That's an advanced pandas function. So what you will do, you will take your data frame, reset index, and then you want to meld it under the variables index. Let me do it and I'll explain the code, and then value will be this, and then put A, we'll put B, C, we'll put D. If you see, guys, what I've done, you'll realize that I have taken the whole data frame. So I've taken the whole data frame, this whole guy, and I've taken each of the columns, guys, each of the columns, and put it into one row. Can you see that? So you have variable or ABCD, just opposite of what you were seeing in genome, right? Remember? All the levels are coming in one column. It's opposite, ulta of what you have seen there, right? Now you are going to replace the column names. You can say TF melt. You rename it. You can say that it is, I've taught you this index, treatments, and value. So now your data frame has been renamed also, the headers. Guys, give me a go ahead. Are you clear with this df underscore melt data frame, how I have created? Everybody? So now you will see that only ABC has come. D is gone. It's lost. So if you want to filter the data for certain levels, you can also play with this, right? So you have to try these things, guys. Once you have it now, so why don't we understand that all these treatment levels have some difference or not? Remember, I can create box plot. So we can quickly plot or plot the box plot. You know the visualization I have taught you. To understand the distribution by treatments. Okay. So for that, what I'll do, I'll import maybe Seaborn as SNS. Remember, import matplotlib plt, and then we can say SNS dot boxplot, right? X can be treatments, Y can be data frame, value, bingo. Could not interpret what? Now, you forget about it. SNS box plot. Yeah. DF underscore melt treatments, right? DF underscore melt and value. Okay. Yeah. See, guys, what happened? It was not able to interpret the column name directly, so I have to give the names like this. Clear? And you can say plt.show. I'm not beautifying the chart, guys, okay? Can you see there is indeed some difference in the level of treatment, guys? It's quite visible. Distributions are not same, guys. Are you feeling there? So what I'm gonna do, I'm gonna run the, again I use this only. Okay. That, and we use data frame as df melt value equal to value ANOVA model equal to value of treatments, and I'll say ANOVA dot ANOVA summary, and here you go. Right, guys? So this syntax is little weird. I also forget all the time. So I keep it noted somewhere because this is a little tricky, but this is how it is. Okay. But can you see that the p-value, look at the, we don't need to worry too much into it, but you have the degree of freedom, you have sum of square, mean square, right? Everything you have. You have the f value, right? And then you have the p-value. Isn't it the p, excuse me, isn't the p-value is less than alpha? Guys, 0.05 by default is the alpha. So you tell me whether it is less than alpha, 0.05 or not. Yes, right? So can I say that there are, the difference is very much significant here? Can I say that the p-value is significant? I'm just making it here bold. And we can conclude that there are significant differences among treatments, and that we can highlight here. The only difference here is that ANOVA never tells you that which one is, which treatment groups are which treatments are significantly different from each other. It just says that all these treatments are not the same. So what you have to do later, you have to go from 4 groups to 2 groups at a time, or you can do t-test or z-test to get into better shape, right? Makes sense? So if you compare 4 means, right, then you come to a conclusion that yes, the treatment groups are different, they're statistically significant. Then which one is different from which one? To do that, you have to get into 2 at a time. So you can start selecting that, okay, first let's pick these 2 guys and then understand. Then pick these 2 guys, then understand. Then pick these 2 guys and understand. Or you can visualize it like I have done in a box plot, and you can clearly see that maybe the impact on the treatment is highest in the D, as you can see, right, guys? Use the graph. Look at the median is on the higher side, followed by the orange, then comes your green, then comes your blue. So at least visually you can make some sense, and then by statistical test you can make more sense, and from there you can get it. Are we clear? Next is chi-square test, but we'll do it chi-square. A lot of people say chi-square. Can you explain the code in line 57? Why not? See what we have done. So this is your ANOVA package or library. So this is your library, and within the library you're calling this function, right? Now this is your data you're using. So remember, this data is your melted data. Okay. Now you will put the value as the column here. So this is your column value. And now you have to give ANOVA model, and that's how they configure, right? So if you see a little bit into the documentation, you realize, see, ANOVA model, you have to give something. So now if it is going to be one-way ANOVA, that's where you have to read. Well, there's no documentation available here, but let me get. You see, this is someone has written, it's not me. But this is one-way ANOVA, and you have to put it like this. So what you're doing, you are actually forming an equation. And if you're able to see, so what we are doing here, that you are taking y as a function of your x, right? So treatments is going to be the input. So let's say you treat A, B, C, D, different groups. Then how is your outcome mapped to the ANOVA? Clear? Those who have done a little bit of R, they will be knowing this a lot, because that's how you put a model in the Y. In the linear regression model in R. Let me show you. Ta-da. R is another programming language. So see, I told you, no? So this is the formula. Obviously, I'm not promoting any. It's just that I'm promoting myself, but I want to show you this. So R is another programming language, guys. Can you see that it is equivalent to what you have written here? Data is here, age and height. Here, data is df underscore that. Okay. To chi-square, or chi-square or chi-square, how do you pronounce? But chi-square test is another important statistical test. So let's understand chi-square test a bit. So chi-square test is also known as Pearson chi-square test. Is a non-parametric test, or I would say non-parametric method to be correct with respect to English, used for comparing the relationship between the two categorical variables in a contingency table. Chi-square is very important for anybody who is in, research, and you want to, take some conclusion out of your research. So for example, if I can show you one table and you will understand, it's a contingency table. Contingency table is more like a pivot table. So you will put something in row, you will put something in column, and the values will come in the middle. You have done the Excel pivot, right? So this is known as contingency table. Now, this can be as simple as that, in this case, we are saying that are we going to have some dependency or independence behavior while determining the treatments related to the treatment outcome? So you have treatments, you have treatment outcomes. So you are treating some person. If he gets cured, so those are 16 people. If you're treating some of the guys and they are not getting cured, those are 10. Some of the guys are non-treated and they are getting cured and they are not cured. So some of the guys say, how can you be non-treated and still get cured? Immunity, guys, immunity, right? The body also has antibiotics. Body also, detox. Body has a lot of healing powers. I know I sound like more like a Insta influencer, but that's true, right? I hope you know. So earlier, those with immunity or the immune system was really working very well in the ancient time. Trust me on that. Uh, with the advent of a lot of medical support, a lot of medicines. So it's like I can give a very good example. I always take this example. So global warming is what? Suppose you have a sun, right? It's really hot. Those who are going to live in Gujarat and Rajasthan, they know that. I have lived in Rajasthan, Kota for quite a lot. So that's where you feel the real hot weather. So people put what? People will put an AC, right? They'll say, okay, let's have an AC in the room, right? Tada. Then this AC will do carbon emission, right? Definitely all those gases will go out. And it is a chain reaction, you understand? So it will keep increasing. People will keep adding AC to their rooms, right? 1 ton, 1.5 ton, right? So the same thing has happened with your, medical system, to be honest. So now the way we eat, now uh, the whole things have. I'm just making a commentary about the kind of food we eat, the kind of medicines we eat. A lot of things we take. A lot of things are having side effects. Uh, I think I was reading one article, and there they mentioned that now in metro cities, to be honest, there's not a single vegetable without having something not good for your body. You guys agree with me? So when I say metro cities like big cities, tier 2 cities is okay, tier 3 villages are the best. But still, if you realize that even the villages are not, now they are in the safe bet. So why is it that so? Because we use a lot of pesticides, and just to cope up with the population's demand, everybody needs to eat, and we need to produce more and more and more. That is taking huge toll on the body in the long term, right? That's why if you observe the number of cancer cases, number of heart attacks, everything have increased in the recent time. The recent time when I see, I think not that like 20 years back, but I have seen the change in a decade. In the last 1 decade, I can totally feel that uh, this is becoming very common. Then we have medicines as well. So we have the healthcare, treating those different diseases that has impact on the body. But somehow it's like the same situation, which I gave an example. You're putting AC to cool down. Unknowingly, you are increasing, knowingly, not so unknowingly, unknowingly, you are increasing the overall global temperature, right? AC is one of the key reasons. That's why I'm taking that. And then again, you'll need more ACs and more ACs, and it will keep go like this. At least I am contributing a lot to the environment of Bangalore. So I live in Bangalore. I don't have a car. I don't have any AC in my house, right? So at least I'm doing my bit, and I always try to communicate everybody. So if you don't need an AC, you can manage. No need to buy AC, just you can buy. I hope you guys agree that I could buy a car, right? At least a small car, but I don't have a car because anybody who lives in Bangalore here, they'll know that putting a car on Bangalore road is like you have done some sin. You have done some crime. That's at least I feel. So I cannot do it unless until it's very important for me, right? Because buying a car seems very cool, but if you are putting some logic to it, doesn't make sense. Okay, so that's my 2 cents on it. But that's where at least you have a you have a you have a subject to do chi-square test. At least you have treatments and the treatment outcomes. You can do some chi-square test. So chi-square test is what we are going to do in this data. With the help of this data, we are going to determine, let me write and talk, to determine whether treatments are related to treatment outcomes or not. Ideally, it seems so, right? Means if you are treating somebody, you would expect that they are related. And for that, people use chi-square to the test for independence. So chi-squared, guys, it's chi-squared in this T. I just realized it's not chi-square or chi-square. It's D, chi-squared. Chi-square test for independence. Independence on two variables. And what are those two variables? Treatment and treatment's outcomes. So what we can do, we can again bring our bioinfo kit, load the example data set. We'll say df get data plug data dot data. So this is your data. It's the same thing what I'm showing in the image. Okay. Now I'm going to run the chi-square test. Chi-square test for independence. So you have to call the function. You have to call the chi-square. It's very easy. And bingo. Then you will say print result dot summary. See. Now if you observe, you have a p-value. Now it gives you two p-values. So there are two methods to do chi-square. What I was deliberating was what? It is more of a Pearson method, but it also gives you log likelihood method. So there are two methods to calculate it. But if you look, they are very much close, 0.26, 242. So not a big difference. But you can clearly see that if you want to interpret it, right, that p-value, if I can write a point, p-value obtained, concept remains the same, obtained from chi-square test for independence is significant. As you can see, it is less than 0.05, and therefore we can conclude what we can conclude, guys. If they are significant, you will reject the null hypothesis. Generally, the null hypothesis is what? Right? There is no association. It's independent. But here we can conclude that there is a significant association between the treatments and treatment outcomes. It will come nice, don't worry. So it's significant. I'll just highlight it. Let me do this. As p is less than 0.05, and there is a significant association between the treatment and the treatment outcomes. And that concludes our chi-square test. By looking at this, you might say, okay, I am treating, I'm getting most of the guys cured. I'm not treating, I'm getting 25 guys not cured. But you get a little bit confused looking at this, that 30 guys are the ones whom I'm not treating, but still they got cured, right? So you get a little confusion. And that's where you need to say, okay, whether the treatments and the treatment outcomes are related or they are independent. In this, guys, generally, you always keep in mind, hypothesis is very simple. Oh, I missed to write. Let me write. So hypothesis is very simple. It analyzes, so the null hypothesis says that, what is the null hypothesis, guys? So null hypothesis, sorry, I missed to write, is no association between the two categorical variables. An alternate hypothesis, it says there is an association. Okay. Okay, guys. So that's all we had to do in inferential statistics. Let me share the notebook. But I hope you got a hang of it, right? You got a flavor of inferential statistics, right? Now you can at least start thinking that how to use it in one of your analysis, right? So that gives you a little bit of confidence also and a view to it, okay? And sometimes in machine learning, you might have to do some hypothesis testing, like generally in linear regression also, before you can come to a conclusion, okay? So idea is that you don't jump to a conclusion by looking at the data, right? The whole idea here is that you do some test, get some sense out of it, and then you come to a conclusion, okay? So I always believe that if you have the data, let the data talk. You don't talk. Let the data talk, right? If you try to say anything, then it means that you're trying to go beyond the data. We should never do that, being a data scientist. First of all, never ever jump to a conclusion in life, in data science.
Just a quick info, guys. Intellipaat offers data analytics course training. Through this course, you will master Power BI, data wrangling, data mining, and much more from the IIT Roorkee faculty and industry experts. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take the first step towards career growth in the field of data analytics.
So that is pretty much how you can get started with data analysis. Simple, right? But this was just one implementation. We are now going to look at a data set that will help us understand human behaviors and will detect the churn rate. After that, we'll analyze a sports data set. Finally, we'll work with time series data. Also, make sure to follow along for a better understanding and practice. By the end of this section, you will be able to do most of the analysis by yourselves.
Analytics, you have to do the EDA, and in that EDA, you have to perform the task accordingly. So whatever the task, what is the aim, first we make a roadmap. Whenever I'm giving you any data set, the first approach is load the data set. You can load the data set. Once your data set is ready, then perform the EDA. In EDA, number of things are there like cleaning, outlier detections, descriptive statistics checking, and etc. So we can perform these two steps with one of the data set, and till now you guys have only used CSV file. And I think everyone knows who is HR and what is the work of HR. Any one of you who is not aware about what is the work of HR or anything? Anyone? Please let me know if you're not aware. The work of HR. Everyone knows who is HR and what is the work of HR? Guys, yes, no, aware about that or not? Yeah, everyone knows. So I'm loading one of the data set, and that is the Excel file. In that we have to check each and everything in detail. First I have to show you that Excel file. In the Excel file number, whenever I'm talking about Excel file and CSV file. So guys, first you have to aware about the difference. CSV means comma separated file. Excel means whenever you have a multiple sheets. Whenever you have multiple sheets, we call that as a Excel. Like example here, objective is there. 3 sheets are there. In one sheet, objective, second sheet, variable, and third sheet, data. So I am loading this particular sheet in my Jupyter. I hope I am clear. This is the data set. In this data set, you have some columns and number of rows. The first column is satisfactory level. Like whenever you're working in any company, so how much you are satisfied, so you have to rate. So that is the satisfactory level of every employee. Second is last evaluation. When is the last evaluation happen? Then number of projects, how many projects you have done till now. And after that, what is your satisfaction level, last evaluation? Average monthly hours. So how much on an average monthly you are working? How much time you can spend? Means that is like in the year, you have spent with the company 3 years, 2 years, 1 year, 4 year, like this. Any work accident happen or not? You are left or still you are there? Promotion in last 5 years, you're getting any promotion in last 5 years, and how many promotions you're getting in last 5 years? You are in which department, and your salary is coming under which range? Low range, medium range, and high range. So it's totally on you. Ki, so it's totally on you. So now if you want to do the analysis of this particular project, what is your objective? What you try to do it here? If you want to find the analysis also, what is your aim? What is the objective? For me to analyze the customers, the satisfaction rate, and each and everything. I can share my screen and my data set is ready. My file is ready. We'll discuss that file in detail. Here is the file. Let me load the data set and I will write the comment after each and every line. So we'll discuss each and everything thoroughly. And as you know, in my Excel sheet, total 3 sheets are there. In my Excel, total 3 sheets are there. Objective, data, and variable. So first, load the libraries. So here, what we are doing it, load the necessary libraries. Load the necessary libraries. Once it's done, so we are using some libraries like pandas. Pandas for data manipulation. NumPy for numerical Python. Matplotlib for visualization. And same for Seaborn is also for visualization. These two libraries we are using for visualization. So now I am loading the data set df. It means df is the variable and I am loading the data set. pd dot read underscore excel. If you are using CSV file, pd dot read underscore CSV. If you want to load Excel, then Excel. Here is the path of the file. So I am changing the path. Here I am changing the path, guys. So in the above path, and in which sheet you want to access. Out of 3, I want to access data. So I am giving sheet name and I am giving data here. Sorry, I have to load this first and then this. Now my data set successfully loaded. And if you want to check the head means checking the top 5 values. If you want to see bottom 5, then you can use tail function. So here satisfactory level is there, last evaluation is there, number of projects, same, whatever the column we discuss, all the columns are present. So guys, what next? Anyone have any idea? See, is there any problem in any of the column? Because I am able to see that, the problem. Are you able to see any problem in any of the data set, in any of the column? Because time spent dot company and dot we are using it whenever we want to call something in Python. Yes, no. So you have to rename the column. If you are not renaming it on the time of calling, it will throw back the error. It will create a problem for you. So now in the next step, I am doing the same. I am rename time spent dot company to time underscore company. If you want, you can use any other name also. Whatever you think, you can give any name. But dot, we can't use it. And I am using one more parameter here. In place is equals to true. What does that mean of in place is equals to true? Why I am using it here? So guys, as you know, Python is same as your English language. In place means you, instead of time spent dot company, you are placing another value, that is time spent underscore company. So in place of time spent dot company, you are placing time spent underscore company. So you want to replace in the main data. That's why. I hope I am clear. And if you check the head, that is also working perfect. Yeah, that's also worked perfect. Good. What next? Right now we doesn't know how many rows, how many columns are present in my data, correct? Good. So now if you are right now, if you doesn't know how many rows, how many columns, how many columns present in your data, so the best thing to check that is dot shape. After that, my choice is checking the duplicates. Is there any duplicate in my data or not? Yes. So I am doing the same step after that. I am checking the shape and I am checking the duplicate. So shape is 14999, means 14,999 rows and total 10 columns. All the columns you already aware about that. Yes. So in your data set, total 3008 rows are duplicate. So I think in my data, no one likes कि duplicates are there. Yes, no. No one wants na कि any duplicates are there. So what I am doing it, I am dropping all my duplicates. So on the time of dropping, I have to make sure that when I am doing that particular step, then what first duplicates, like example, Harsh is coming 2 times in your data. So first one I'll keep it, second one I'll delete it. When the second time Harsh is coming, you can delete it. Understand? Like example, there is one row. Here some data is there. Like example, 1, 2, 3, 1, 4, 5. So first one he keep it, second one he is deleting it. Understood? So here I am using df.drop duplicates, keep the first one, remove the second times repeated one. I hope I am clear for giving the confirmation. So after that guys, I am checking the info. So do you know in the info how many information we are getting? Info means the information of your entire data set. Information of your entire data set. So here you know how many rows you have, how many columns you have, name of the columns, all the names. Is there any null value present in your data set or not? Data type of every column, how many float data types are there, how many integers, how many object, and how much memory it is consumed. Clear? So right now, as I see, no null values are there, but for the safety purpose, I think we have to check. So can I check df.isNA? So dot sum. So I don't find any null values in my any of the data set. So in my data, no problem. After that, time to check the normality of my data. Normality means check whether the data is normally distributed or not in the satisfactory column. And if you are aware about Shapiro walk test, then I think it's good. So we are going with Shapiro walk test. So I think for if you want to check the normality, if you want to check the normal your data is normally distributed or not. So if I am correct, then histogram is the best choice to know the distribution of any data. Guys, yes, no. Distribution is the best choice. Yeah, good. So I am doing the same thing. I am using distribution graph, means histogram, to plot the distribution. So matplotlib we already imported. So plt.figure, I am giving some figure size like 10,5. 10,5 is the length and width of the data. Then which type of graph I want? Histogram. So plt.histogram. Which column I want to check the normality, satisfactory level, and then plot that. So anyone, this data is normally distributed or not? If it is not normally distributed, so on that time, can can I prove that with the help of statistics? Because as a programmer, you are able to see in the graph. But if you want to prove with the help of statistics only, you can prove it. Skew values, we can use it. Correct, you can check the skewness also. Very good. You can check the skewness also and you can prove it. That's also correct. Or any other options, any other thing you know that. If I want to check statistically, then what to do, Lavanya? With the help of hypothesis, can I check it? Very good. With the help of p-values, very good. So what is hypothesis? The data is normally distributed and alternative is data is not normally distributed. So I am using from sci-fi stats import. Okay, then stats p-value, df and my column name. So if you do that, your p-value is 0.000. That is less than 0.05. That means it's less than 0.05. Data is not normally distributed because reject the null hypothesis. And my null hypothesis is data is normally distributed. And alternative hypothesis is data is not normally distributed. So I think if I'm correct, Lavanya, so with the help of p-values, now we are very clear for sure that data is not normally distributed. What about you? What next? Guys, I think visualization you have done number of times, if I'm correct. Yeah? So can we do something fruitful? Can I show you something like example, if I'll show you two, like very simple. If you do a proper visualization, proper EDA with making one report, according to you, how many lines of code it is? If you have 10, 12 columns, almost 14,000 rows. So according to me, it will minimum take 70 to 80 lines if you do proper EDA. Agree with me? Yeah. Can we do, Rajesh, with the help of in just 3 lines? Can we do that? All the EDA with a proper report. Can we do in just 3 lines? Means whatever you are saying like skewness, checking the distribution, each and every parameter will there. And in just 2 to 3 lines, you can do that. Is there any possibilities? Or you means if you are not aware, it's fine. I can help you. But tell me yes or no, according to you. So Arvindji, how? Arvindji, is it fine if I'll give you mic access? What about you, Nandini? Kaustubh? Maybe description will give. So, no, Arvind, means you can fetch entire HTML report where each and everything with graphs and all the details. No idea? Okay. So, rest of the things we can go later, but I want to show you something. So here, there is one library. That library we called as, that is, you called as a tool, library, whatever you want, you can call this. I'm calling that as a suite visualization. So with the help of that, whatever EDA you have performed till now, in just 2 to 3 lines, you can create one fabulous report, and I know that no one knows till now. No one use it till now. It's my guarantee. You have never know about that, so I don't think so you ever use it. Dash. No, suite viz. That library we called as suite viz. So here you can write pip install suite viz. First you have to import that particular library in your Colab or Jupyter, wherever you are working. Once it's done, once it's successfully done, then import suite viz as SV. This is same as your pandas, matplotlib, any other. Now if you want to, no problem, Lavanya, actually sometimes some things are coming totally new, and you have to aware about that whatever present in the market. So now, like example, I'm taking as one variable as a report, as a variable, and here I'm giving sv dot analyze df. What is df? Df is my data set name. Report dot show html, and I'm giving my report name is as a I'm giving my name Harsh first class HTML. Can I give this name? You can give any name. Can I execute this? See the magic. He will check each and every column and create a report within 3 seconds. 14,000 rows in just 3 seconds, and your report is present here. Can I show you this report? I'll download this report and I'm opening this report in front of you. Tell me after that, any EDA is required? Satisfactory level column. And first, how many total rows? How many total duplicates? How much RAM it is consumed? How many features means how many columns? How many categorical numerical columns? Now satisfactory level, maximum value 95 quantiles, 75 quantile means third quantile, minimum, median, average, quantile 1, 5 percentile, minimum value, range, IQR, standard deviation, variance, kurtosis, skewness, sum, and that data and their correlation with which column and how much correlation it is with all the data. Not only one, entire data set, each and everything is there. Like example here, total 6 categories are there. So category 7 have only 2% of record. Category 6, 8%, 16, 18, 27, 29. So you know which category, how many percentage also. Each and everything guys in detail. I hope now it's helpful for you. Rajesh, you ever seen this type of report, Lavanya ji? And I don't think so I'm writing any difficult code. Just one line of a code. Thank you, Gustav. So with the help of that, each and every column you can check. First, now one question is coming, Harsh, if this thing is possible, why you teach me the means why we are not directly getting this type of things, why you are teaching me the basics? Guys, because these are the tools. If your fundamental is strong, you know how the things are working. On that time, no need to do anything. Right now, you know, if you want, you can make your own tool. Because you know each and everything, how that tool work, how to find that particular value. Correct, Rajesh. But Rajesh, I know this first time you have heard about this library. This is only one of that. Number of more libraries are available and you can use it. This is one of that. And next time when I'll come, I can show you one more library. Or if you want, right now I can show you one more library. Whatever you want. It's not possible for me also to share each and everything. But one or two library I can show it to you. Okay, perfect. So I will do one thing. I'm open one of my file in collab. I think I'm making it. So in that I have done that particular thing. Let me open that Harsh tools. Yeah, perfect. I'm teaching that particular tools also. So SweetWiz, you know that. One more library is AutoWiz. I can show you. That is easy. Number of places, number of people I have giving number of document, but I suggest please refer the official documentation because some people have suggested many libraries which are not currently in working phase. And slowly, I think when you have start knowing about the library, you can go and search. Everything is open source. Nothing is private. Guys, I am loading one of the data set. So guys, I am loading pip install AutoWiz, one of the library as we done SweetWiz, and I am loading the class library which is required here. And after that, nothing else. Same as it is C. No changes, nothing different, nothing difficult. Only use that much of the code. And here I am giving my data frame name. So he is creating one report. In that report, he is suggesting in which column what is the issue also. What is the official place? Official place, Mahesh, like example, if I'm talking about SweetWiz. So you can go in the next tab in a Google, you can search SweetWiz, not EDA, SweetWiz only. So this is .py.org. This is the official website. Official website of Python, and he will suggest you SweetWiz, one of the libraries updated on November 2023, each and everything. How to install it, how to work on it, each and everything. Good. So here means like that. If you want to go for AutoWiz or SweetWiz or NumPy, means like example, if you want NumPy also, na, official website is this. Here documentation, installation, different ecosystems, how to do that, you can go for community. Each and everything is open source and free for everyone. And okay, now coming for this, guys, I think code is very simple. Very simple code. He will also suggest how many rows, how many columns, every column and their category. Now column wise, first column is satisfactory level. Data type is float. No missing value, no unique value. Minimum is this, maximum is this, and this column no issues. Now if I'm talking about time spent on company, customer have 824 outliers greater than upper bound, means in this outliers issues are there. Either you can cap them or remove them. If there any issue in any of the column, he will directly suggest you. I hope now it's clear. With the help of that, you can create this type of interactive report. If you want to know which column, is there any issues, if you don't want to go check and manually, you can use this and check it. Understand? Done? Good. Guys, is it clear? Anyone have any issues in this library or coding part or anything? I think that is the easiest thing which we have done till now. I don't think so coding or something is very difficult. Everything is easy to use. So now go down. So now guys, I am checking how many unique values are present in my salary column, because in salary there is a object data type. So low, medium, high, or any other column also none or anything may be there. So I am checking with the help of unique. The work of unique is to check how many unique values are there. If you want to check the number total, the number of unique, then you can check any unique. Guys, three functions are there. No need to confuse between all three. One is unique, which gives you the values, like example low, medium, high. Three types of unique values are there, low, medium, high. If you want to see number total 3, you can check any unique. So low, medium, high, 0, 1, 2. Yeah, now coming back, one more thing is there, we called as value count. Value counts gives you, like example, how many low, how many medium, and how many high values and their counts. Understood? So in this data, the higher number of people are getting low salary, then median, and high are very less. 7,316 are getting low salary, 6,446 are getting medium salary, and 1,237 are getting high salary. Correct? And now what I am doing it, I don't want to change anything in my real-time data. So I am creating a copy. I'll store my entire data in DF1. So my DF is as it is there. So whatever the changes I have performed, everything will be changed under the DF1. So now in your data set, there is some object columns are there. And guys, how many of you know that the machine never works with the object column? We have to encode it and make it numerical, correct? Machine never works with the object data. Yes, no. Machine doesn't know who is Lavanya, who is Rajesh, who is Harsh, who is Mahesh. Machine consider everyone as a number. Very good, Lavanya. So now you have to encode it. Very good, Kostov. You have to encode it. But now question is how to encode and what actually the encoding means. Because according to me, if I'm not aware about what actually encoding, then according to me, like in cyber security, encoding, decoding, like encoding of messages, decoding of messages, these type of things are there. But right now, encoding means simple, means converting object data type to numeric or float. Clear? Converting object to numeric. That is the work of encoding. Guys, you have any idea about label encoding, one-hot encoding, or ordinal encoding, or I can give some idea about that. If you are aware, that's fine. If not, I can give you idea. 3 types of encoding generally we use: label encoding, one-hot encoding, and ordinal encoding. And the work of all 3 encodings are same: converting object data types to numeric. Because machine never understand this. Machine only understand this. I hope I'm clear. Cost of learning, everyone is aware about label encoding, one-hot encoding, ordinal encoding, or if you want, I can explain it also. I don't have any issue with that. And if you're aware about that, that's good. So I can directly start the hands-on. So guys, label encoding means, as I say, three types of encoding, starting with the label encoding. Like imagine low, medium, high is there. If you apply label encoding, so the work of label encoding is only giving low to 0, medium to 1 and high to 2. Understand? Like example, right now he will assign low to 2, medium to 1 and high 0. The reason is the work of is this only assigning 0, 1, 2 to any number. Means like example, if you have gender column, male, females, transgenders. So generally he is assigning 0, 1, 2 to all the values. Like example, he will assign 0, 1, 2. Normally converting alphabet to numbers. Clear? That is label encoding. But label encoding encode alphabetically. That's why I'm saying H is coming first, so you'll assign high to 0. L is coming second, so he's assigned 1. And M is coming after that, then 2. 0, 1, 2. Label encoding is clear? 0, 1, 2. Simple. Now one more encoding as I discussed, that is ordinal encoding. So the work of ordinal encoding is very simple, means order wise encoding or rank wise encoding. So if I'm talking about order wise, then low is the less, medium is next and high is second. If you want to assign order wise encoding, then you can go with the ordinal encoding. Whatever the order, according to the order, you can assign the values. Ordinal and label encoding, I hope it is clear. Yeah, good, Kostov. And if I'm talking about one hot encoding, guys, so one hot encoding is something, he will create 3 new columns: salary low, salary high, salary medium, and salary high. Low, medium, high. Low salary means example, first one is salary. Okay, here is the column. So column is coming like this: low, low, high, medium, high, low, medium. So we'll assign the value like the first value is low. So we'll assign 1 here and rest of every place 0. Second value is again low. So here 1, rest of every place 0. Third one is high. So here 1, rest of every place 0. Fourth one is medium. So here high, both the places 0. Like this. So he will create the values individually. He will create 3 new columns and assign the values accordingly. I hope it is clear. Yeah. So guys, label encoding and ordinal encoding use cases, you know that. Can anyone tell me the use case of one hot encoding? Where to use one hot encoding? Wherever you are using it on that time, it will increase the dimensionality. And if you increase the dimensionality of your data, it will take more time, more space. And if you increase the more size, space and time, on that time indirectly that will affect your cost. Yeah? Yes, no? Then where to use one hot encoding? Cost of J. Any idea where to use this? Okay, I'll give you one real-time example. Now, I think everyone is aware about cricket match. So imagine World Cup is going on and your target value is win. Your aim is to win. Number of team participate: India, West Indies, Pakistan, South Africa, New Zealand, England, correct? So all these teams as a column and your target is, your aim is to win. Correct, no? Your aim is to win. So on that time, all the row means like if now in that time we have to use one hot encoding. The reason is all the 11 players are not playing well. And if you want to know which particular, like example, India have the highest possibility to win the World Cup. That doesn't mean all 11 players are playing well. If you want to check statistics of all individual category, you have to create 11 new columns and then check every column how much important means how much role is important in the World Cup or to win the match. If this particular player hits the runs on that time, that particular team will win the match. If this particular player taking the wickets on that time, India won the match. Clear na? Whenever you want to know thoroughly, like example, one more example I can give you. Okay, if you are working in any company, that is the cosmetic company. On that company, when gender column is there, so male, female. So I think in the cosmetic industry, gender column is one of the most important column. Yes or no? So you know that your gender column is highly correlated to your target column, means price or profit or anything. But that doesn't mean that both the genders are equally play the important role. How you know which particular gender will play the important role? You can only know when you are using one hot encoding. You can divide the data into two parts: gender male in one column, gender female in one column, and then you check which particular because of which particular category this column is important. Now it's clear. So now here I am using label encoding. So you have only one column which is object, that is salary one. So I'll apply label encoding on my salary column. Of course, so I already shared. Again, I am sharing the chat box. I hope everyone received. So guys, I am loading one of the library from sklearn pre-processing, import label encoder. Then I'll store my label encoder in L1. I don't want to use label encoder again and again, so I'm using L1 as a variable. You can use it any variable, it's totally on you. Then where to apply label encoding? In my salary column. L1 dot fit transform on my salary column. So let me re-execute my entire code. Perfect. So see, in the data dot head, your salary column is now encoded 1 2 like this 0 1 2, and whatever I'm saying, is it correct or not, you can check it from. First is low, second is median. So it's assigning 1 2 and high is 0 automatically. Correct guys? High automatically 0. Guys, L is coming first, so 1. M is coming after that, then 2. H is coming first, then L also, then 0. 0 1 2. So can anyone tell me what is the use of correlation? Anyone have any idea? Guys, the use of correlation. What is correlation? Relationship between variables. Very good, Lavanya. So checking the relationship between the variables. Do you know 3 types of variables are there? 3 types of correlations are there. Positive correlation, negative correlation, no correlation. Good. Positive correlation means when you increase one thing, second thing is also increases. When you decrease something, second thing is also decreasing. That is the positive correlation between both the variables. Negative correlation means when you start increasing one thing, second thing is start decreasing. No correlation means you can increase it, decrease it, doesn't affect on your second variable. Clear? Can I give you the example to explain the same? Okay, no problem. So Kaustubji, very simple example, like you are my manager. So if you want to increase my salary, so you notice now you can check my performance also. So you notice whenever you can increase my salary, my performance is also increases. Whenever you can decrease my salary, my performance is also decreasing. That means salary and performance, these two columns are highly correlated to each other, highly positively correlated to each other. Negative correlation is something, whenever you can increase my salary, my performance start decreasing. Whenever you can increase the speed, automatically it will take less time. If you want to go somewhere and you can increase the speed of your car or your bike, it will take less time, na? That is negative correlation. No correlation means, example, if you increase my salary, decrease my salary, my performance is constant. There's no relationship between two variables. I hope now it's clear for everyone. So now coming back, so I'm checking correlation. So there is a direct code, means your data set name .corr to check the correlation. Here you can check the correlation with the table. But I think if you see in the visualization form, it's easy to understand. In the table, direct numbers are there. but if you see the same thing in a visualization form, that will make more sense. So only one graph is suitable to plot multivariate in one go. That is heat map. If you want to plot more than 2-3 variables together, on that time heat map is the best choice. So I am going and plot the same. I am using plt.figure, figure size I am giving, and sns.heatmap, df1 correlation, a naught is equal to true means I want a notations. If you are mentioning a notations false, on that time this number is not coming inside the graph. And I'm giving the color coding as a cool warm. You can give it any other also, it's on you. Okay, wait a minute, let me run before. Guys, it will take little time because auto vision speed is going on in between, and now it's work. So guys, I think my kernel is dead. Wait, let me restart my kernel. Interrupt execution, restart session. Because sometimes your kernel is dead, so it's not showing you any output. And let me comment these things because again it will take more time every time execution. Now you know the use cases, so I can comment it also. Later you can uncomment it. It's on you. Perfect. So let me run before. So now it's automatically coming. See, that means my kernel is dead in between. And in Python it generally happens, guys. So see here, so now instead of that, if you want any other color coding, you can give it. Like example, instead of cool warm, I want rainbow, all 7 colors. So I can give rainbow here. Clear, guys? No one have any doubt, any questions, anything? If anyone have anything in this coding part, any questions related to that, please let me know. A notation is clear. C map is clear. Everyone, the code is clear. Perfect, Lavanya. Now going down, I am checking the head. And okay, so as a HR, our aim is कि satisfactory level is greater than 0 and more than 50 is also good. And at least they will spend 2 years with us, and working hour is that, and average monthly is also that. So if you want to know, actually this is like the assumptions which we can do, that as a HR we have to check like number of possibilities are there. Maybe that much working hours they have done, they are staying with us with more than 2 years, 3 years, or minimum 2 years. So we know how many people with us. Accordingly we know which type of environment is there in our company, right? So this is some filtering part. We are doing it with the help of that. We are giving our analysis at last. But right now we are doing some filtering part. I'm using AND operator where these two conditions are satisfied and all 4 conditions are satisfied. I want that data. So here is the data where satisfactory level is 0.13 and they stay with the company with 2 years. Correct? Average working hour is more than 130 but less than 200. So you know how many people are left, how many people are not left. So with the help of that, you know that now when you check, so total 6 people are not left, and 0 means on 0 means not left is 211, and 6 people are left the organization. So that means this is the perfect monthly average. If everyone have done all on an average whatever they are doing it, they will happily stay in the company because rest of all also means rest of all are also doing the same thing. Yes, no, as per your data, guys. Like example, you notice that some people have done 160 hours of a work in a day or in a week. So on that time, and they are staying with us. So I think that is the good choice. So if everyone is doing that many hours, my work is going good, they are staying with us, and everything will going good. So I am checking on an average hour is 167 hours in a week. So guys, now second thing we have to check, like example right now, whoever is staying with us with 2 years, that monthly average hour is 167. So if people are staying more than 2 years, that working hour is also same or not? This is one of the question coming in your mind. Why we are only checking for 2 years, we have to check for everyone. Done. Good. So now guys, and the same thing I'm doing it whenever you want to compare two things. So I think t-test is the best thing. I'm using one sample t-test. It tells us whether the mean of the sample and the populations are different or not. So now as we discuss, our question is the average monthly hour of an employee having 2 years of experience is 167. So is it same for employee having more than 2 years of experience? Condition is satisfactory level of employee is from 0 to 5, means 0, 0.5, and average monthly hour it's from 130 to 200. That is the condition which we have given. So same condition again I am giving it, and I'll store everything in the employee. Any doubt here till now, any one of you? Everyone clear? So now I'm doing the same filtering part. Once the filtering is done, so my null hypothesis is average monthly hour of an employee is having 2 years of experience, and the employee more than that have 167 monthly hours, correct? Average monthly hours. An alternative is opposite to that, average monthly hour of an employee having more than 2 years doesn't have the same average. So guys, I am taking sample size as 100 and employee dot sample. So with the help of that, I am taking a random 100 sample out of 1462 data. Out of 1462, I am only choosing 100 sample data. What is your mean? Mean is 167. Your POS mean is 167. So guys, when I will try to check my sample one monthly average, that is 154. That is less than that. That is less than that or not? That is less than that. But we have to prove statistically. Right now we know that the average monthly hour is not equal. So now we are checking with the help of T1 sample test. And as I think last time Lavanya ji is saying, we can use P value to check it, right? Both are same or not. So what is my P value? P value is less than 0.05 or greater than that. So reject the null hypothesis. And my degree of freedom, what is degree of freedom, guys? You know that what is degree of freedom? Because in this step we are doing the same thing. So guys, what I am doing it here is very simple. I am using n minus 1. So with the help of that, we know the degree of freedom. So 1462 is your total sample, and when you reduce by 1, that is 1461. Why we do that? Because in Python indexing starts from 0. So total length is always 1461. Guys, one simple question. If indexing start from 0, okay, 0, 1, 2, 3, 4, 5. So what is the maximum point here? 5 or 4? How many maximum element? Total elements are 6, not 5. Right? So that's why we are using n minus 1. So my dear n is 1462 and my dear is 1461. So I am using alpha as 0.05. What is alpha? The p value. So I am giving ppf test, and now again if we check the p value, so what is the t test suggest? Again p value is less than 0.05. We already know here. We already know here, as Arvind ji is saying. Correct? We already know here. But If you want to go more depth and you want to prove it to someone, then this is also one of the steps. So you can perform that one also. Understood? Then one sample Z test for the proportion. Where we use Z test? Guys, where we use Z test? Wherever you want to check the variance, right? So the percentage of employee leaving the company is less than 3%. Having experience of 2 years. So is it same for the employee having more than 2 years of experience? So here you are checking the variance between both. So null hypothesis is saying percentage of employee leaving the company having 2 years of experience is same as employee having experience more than 2 years. An alternative is opposite for the same as opposite of that. Percentage of an employee leaving the company of experience 2 years different from the employee having experience more than 2 years. So I am using proportional Z test. Here I am using sample size is 100. Sample 1 employee dot sample size random state. So sample 1 left count. So here 0, 37 and 163. I am taking total 100. So in 100, 0 are coming 37 times and 1 is coming 63 times. Okay, how many are left? So I am using noob. Noob, what is the noob? Left. Left is, you know, that 100. So my noob is automatically 100. By default, you can suggest it or you can do it manually. It's on you. In these 3 steps, any one of you have any issues, any questions? Giving noobs as 100, as you always give. And what now your P0 is 30%, correct? Sorry, 3%. So I am giving 0.3. So guys, left value count divided by your noob. So that is 63% left and 37% not left. Now this is statistics 1 proportional, P value 1 proportional, Z test. Count, I am giving count as it is. Count, you know that value count. Noob is 100, you know that. Value I am giving P0 means 0.3%. Alternative is check two sides and variance is now I am giving as a false. Now what is your P value? 0.57. That is greater than 0.05. Yes or no? P value is greater than that or not? So means P value is greater than 0.05. Accept the null hypothesis and reject the alternative hypothesis. So here, what is the assumptions? You can say that. What is the assumption? Assumption is the percentage of employee leaving the company having the experience 2 years is same as the employee having experience more than 2 years. Means experience is same. How we know that? With the help of P value. And what is P value? Is a hypothesis. Assumption. Clear? Very good. Appreciated. So now after that, two sample t-tests for the mean. Compare the mean of two independent groups. Correct? So I am checking time spent. These are, I am doing it for the manual purpose. Now the question is the mean average monthly hour of an employee having experience more than 20, experience of 2 to 5 years is the same as the experience of 6 to 10 years? The same question which we have asked earlier. Before it is 2 years or less than that, now it's 2 to 5 years or 6 to 10. So guys, I think the same step we have to perform again. Only the conditions are changed. Only the conditions are changed. So here in E1, I'm taking time spent, which is greater than 2, less than 5. And E2, greater than 6, less than 10. And E1 dot head, if you check, these are the values. Filtering part is clear. I think this is a normal filtering, which you have done normally, right? E2 shape is 11167 by 2 and E1 shape. And E2 shape is also 824. Means more than 6 years of employees are very less if I am comparing with any other one. If I am comparing to 2 to 5 years. So if you want to do the hypothesis, guys, as usual, you have to take some sample size. So it's on you. You want to take 100 sample, 200 sample. It's totally on you. Right now we are taking 200 samples. So I'm taking 200 of both and directly apply t-test, monthly average, S1, S2. This is your statistics and this is your p-value. So p-value is greater than 0.05. That means accept the null hypothesis. If you accept the null hypothesis, what does that mean? The mean average monthly hours of an employee having experience 2 to 5 years is same as that experience of 6 to 10 years. No changes in that, the same thing we have done earlier. That's why I'm doing directly in one step. Clear? Very good. So now here's one more concept called F test. So guys, in the F test, you are comparing two groups, and here are two different groups. Because if you remember, if you learn, T statistics is also doing the same, F is also doing the same. The difference is T you can work for the small sample size, and F you are doing for the large sample size. So now this is one of the sample variance and this is the another variance. Check the variance. There is so much difference in the variance. Sample mean also are very different because the size are very different. In the length, as usual, we can do -1 because of the length we are checking it. And here, if you divide, the average is almost 86%. So if you apply stats, CDF, cumulative distribution frequency, F test, DF1, DF2, then that is somewhere around 15%. Then again I'm checking percentage because of checking both the groups. I'm doing 1 minus alpha. I hope I'm perfectly clear. Good. And here also the p-value is less than 0.15. That means null hypothesis. P-value is greater than 0.05. That means accept the null hypothesis. Means if you go with any of the test, result remains same. Whatever result you are getting it from here, that will accept the null hypothesis. It will accept here also in the F test also. So no difference. Any difference in both? But in 2 times when you are checking, so you have make sure you are for sure ki means whatever the assumptions, whatever the result is coming, that is 100% correct. Guys, right? Lavanya, any one of you, if you apply T test, F test, Z test, if you know the result is same, that means you are for sure whatever the result is coming, that is correct.
Just a quick info, guys. Intellipaat offers data analytics course training. Through this course, you will master Power BI, data wrangling, data mining, and much more from the IIT Roorkee faculty and industry experts. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take the first step towards career growth in the field of data analytics.
Introduction to IPL auction data. So the IPL auction data consists of various players that have been sold in the IPL auction 2022. The dataset contains all the batters or the batsmen that have been sold in the IPL auction. It contains all the bowlers that have been sold in the IPL auction. Amongst those are the all-rounders and the wicket keepers as well. Because these are the categories in which the players are being sold in the auction. And after that, we also have the uncapped players who has not yet played any IPL matches. So we are going to filter those out later on in the session so that our analysis is foolproof to the point where we don't have to consider those players for now. Alright, so this is the information about the IPL auction data. And with all these players, we have parameters like nationality. There's a parameter of runs they have scored in all these matches. And amongst those are the average and the strike rate for the batsmen. And there are parameters like bowling average and bowling strike rate for the bowlers. And then again, we have parameters like catches, stumps, and runouts made for the keepers as well. So this is a brief introduction to what the IPL auction data contains. And we'll quickly go through the summary of whatever we're going to discuss in the session, and then we'll move on to the hands-on part. Before we begin, let's quickly introduce data analysis. So whoever is not aware of what exactly is data analysis can get on the session as well. Data analysis is where you gather, clean, transform, and reduce useful information from any unstructured set of data. So we can define data analysis as, let's say, for example, we have unstructured data. We will gather that data. We will then put it to some use. Through computations, we will clean that data of the noise and reduce redundant values. And then we will transform the data into something that can be used in a programming language. Or we can use, let's say, for example, Python to analyze the data. And after that, we'll reduce the useful information or insights from that data through visual representations. We can use machine learning models and other things that are being covered in the data analysis part. So now that we have a basic idea of what exactly is data analysis, let's move on to the next part, which is how many steps are involved in analyzing the data. For example, let's say we have this IPL auction data. How are we going to analyze this? First of all, we have to gather the unstructured data. After that, we move on to transforming the data into something that we can load onto a program. For example, if we are using pandas, we'll have to make sure that if we are loading the data into our program, it has to be in a compatible format so that we can actually make use of that data. After that, we are going to clean the data of all the redundancies, which can be null values, which can be irrelevant values that are not needed for our analysis, and all those things that we have to clear in the step 3, which is cleaning the data. After that, we analyze the data. For analysis, we can just use basic computations, and for that we'll figure out how many parameters are useful for us and how we are going to derive any useful insights from that. And visual representations also help a lot in analyzing the data. Once we have cleaned the data, transformed it, and have loaded the data on our program, we can gather visual representations using matplotlib and cmon library in Python, and we'll get a clear idea of how our data looks like and is there any relationship between the parameters that we have inside the data. So these are the basic steps we can use to derive any useful insights from any structured or unstructured data. So after this, let's also take a look at how we have analyzed the IPL auction data in our session that we'll begin in just a short while. First of all, we have gathered the IPL auction data from various sources, and we have consolidated all the information in a CSV file where we have the player names, the nationality, and what kind of a player that particular person is. Is he a batter, bowler, keeper, or an all-rounder? Then we have also mentioned values like capped or uncapped. Have they played an IPL match before or not? Those values. And after we have gathered all these data points, we have cleaned the data and removed the noise. For example, since we are not going to be analyzing the uncapped play because there is not enough information on those players about the statistics related to the game, we have decided to remove them from the data for now. And that is basically how we have reduced the noise from the data. And any null values or redundant values, we have also reduced them to either 0 or we have completely removed them from the data set. After that, we analyze the data for useful insights, in which we basically gather is there any relation between the parameters that we have used. For example, if we want to see how many players have average more than, let's say, for example, 130, we'll have separate computations for that, and that's how we are going to analyze the data. Similarly, when we have analyzed the data through these computations, we'll put visual representations to good use, and we'll visualize the entire analysis so that we'll be able to make our decisions more efficiently. And finally, when we have gathered all the insights and we have looked at all the visual representations of all these parameters, we'll come up with the best 11 according to the analysis. So that's how this session is going to go, and let's move on to the hands-on part where I'll explain you how the code works for the IPL analysis. So this is a simple notebook we have curated for this problem statement, in which we have consolidated the data that, like I have told you, for all the sold players in the IPL 22. And in this data set, we do not have the unsold players, and we also have accumulated all the retained players from all the franchisees and put them with these players again. And then again, the data contains information like matches played, runs, wickets, average, strike rate, bowling average, bowling strike rate, economy. Then there is a number of wickets they have taken, catches, run out, stumps, etc. That we're going to take a look at those data points just in a short while. And our end goal is, based on these data points, whatever we have mentioned until now, we will try to create the best 11 from these set of players from the current campaign. And basically, I'm just going to summarize whatever we're going to do in the session in these 5 points. First of all, we are going to extract and load the data. Extraction, we have already done, consolidated the data set. And after this, we have to clean the data and remove all the noise, which is the redundant values and all the data points that we do not need for our data set. And then again, we are going to analyze the data on different parameters, visualize the important statistical findings that we are going to get from the data. And after that, we are going to make the best team of 11. Now, this is the fun part. What we have done is we have consolidated the information from the winning team from the ICC T20 World Cup, which was Australia, and how the squad formation was there for them. And then again, for the last IPL campaign, whoever has won the formation, the squad formation that they had used in the final match, we have considered those, and according to those, we will put our best 11 in the exact same squad formation. So now we can begin. First of all, we will import all the necessary libraries which we are going to need for this particular data analysis. First is NumPy. Then we have to import pandas, matplotlib, and seaborn. So NumPy is going to help us with any computations related to numbers, and then again pandas is going to help us load the data and display with data frames and everything else. Matplotlib and seaborn is primarily going to be used for data visualization. So after we have imported all these libraries, we'll move on to the part where we load the data. So to import the dataset, we have used the package from the Python programming language, which is I have just told you about these packages that we have loaded, and PD, which is an acronym for the pandas library that we have imported over here. We are using the read CSV method to import the IPL dataset that we have curated or we have extracted from various sources. Now to look at the data, or the first look, here it is, guys. I'm just using the head method, which is going to return the first 5 rows of our dataset over here. Now this is the first look at our dataset. So you can see we have all these players, then there is a team which they belong to in the current campaign. There is a nationality. Nationality we have used because we want to make sure that only 4 overseas players are going to be in our best 11. And that's how the analysis should be. Before we were going down this path, because we want to make sure that at the end of the analysis, only 4 players should be in the best 11. Then player type, basically just to segregate the number of batsmen, number of bowlers, and number of wicket keepers and all-rounders we are going to keep in our analysis. So these are going to be 4 different analyses based on the player type. After this, we have the capped information, which means they have already played an IPL campaign. And if it is 0 or if it's 2 for some, for example, in the entire data set, there are 3 values we have used for capped. One is for players who have already played IPL campaigns, and 0 is for those who do not have any prior experience of playing an IPL campaign. So we'll filter those out later on in the session. After this, we have the information like matches played, the runs they have made so far in their campaigns, how much they are averaging, the strike rate, number of wickets if they have, and the bowling average, the economy, everything, bowling strike rate, catches, runouts, and stumps. So these are the values, and as you can see here, you can notice the NaN values, which is basically the noise in our dataset, and this is what we have to figure out later on so that there is no noise in our data also. Moving further, this is the describe method, which basically gives you the information regarding the count, the mean value, the standard deviation, minimum, all these values. This you can check just to get a vague idea about what the entire dataset looks like. And we have already checked the number of null values using the isNA method. So if you use this isNA method, it will tell you if you have any null values in the dataset. And then again, we are using the sum method over here, which returns the number of NaN or NA values in the dataset. As you can see in the matches played, we have a lot of NaN values, and then for runs also we have, for average we have strike rate and all these values. For catches, runouts, and stumps, we have more than 208 values, because we have only consolidated the information regarding these 3 parameters for wicket keepers. For bowling strike rate and bowling average, economy, wickets is entirely for the analysis of the bowlers, and including these and the batting average, strike rate, runs, and matches played is going to be used for all-rounders and batters. So now that we have a vague idea about how our data set looks like, how many null values are there, and what is the mean and standard deviation of all these values we have in the data set, we can also get the data type of each of the elements or each of the columns. So for player name and all, we are getting object here. Then for the rest of the values, the data type is float, and it's actually returning us with all the non-null values. So for player name, there is no null values because we have 235 rows in the 16 columns, and we have 235 non-null values. So we have the entire information regarding the player name, which we got from the IPL auction from various sources. Now for team also, we have the exact data, the nationality, the player type, we have the exact data. if they're capped or not. We have also for matches played, we don't have a few values. There are 20 null values here. Then for runs also there is some inconsistency because we have not mentioned that for bowlers. And then again for strike rate we have some redundancies for wickets and all those things. So since we have a clear idea about the data, we have loaded it into our program. The extraction loading has been done. Now comes the part where we'll transform our data, basically clean the data from all these redundancies and narrow our analysis to a point where we don't have to worry about these things. So in the above data, as you can see, players have been segregated on the following parameters. First is capped. There are batters, bowlers, all-rounders and wicket-keeper. So we are going to focus on these players only. The uncapped players, since these players do not have a lot of statistical data available from the internet, or let's say wherever we have gathered the information from, we have decided to keep these out of the loop so that we can only focus on capped players for now. So the uncapped players basically are playing IPL for the first time. So these players, if you do your further analysis, can be the surprise package for any franchisee. And since we have only limited our parameters to just the basic statistical figures, our analysis is not foolproof because there has to be number of parameters that we can include. For example, let's say batters. We have to consider how many runs they're making in the power play, how many runs they are making in, let's say, for example, the death overs, and how many times they have been, caught out, or how many times they have been out on, for example, a full length delivery, or how they are playing the short length deliveries. These are the other parameters that people also can consolidate and consider for their analysis. But we have stuck to only the basic parameters so that it's easier to explain to everyone, even though they are a beginner or not. So let's begin where we clean our data set. So cleaning the data set basically is getting the only values that are going to be required for our analysis. So here we are just segregating the capped batters, which means the batsmen that have already played an IPL campaign. So how are we going to do that? So we are going to locate only those rows and put the entire data frame in a data frame called batters, where the player type is a batter. So this will limit our search from the data frame and create an entire data frame for just the batters. After this, what we have to do is filter out the capped and uncapped players as well. So for all the batters that we have consolidated in batters, we have created another data frame called batters new, in which we have located all the rows where capped is equal to 1. So this will create a new data frame which will contain only the information about batsmen who are capped. And after that, we have created a final capped batters dataset in which we only have the columns that are going to be required for our analysis, which is player name, team nationality, matches played, runs, average, and strike rate. Because to analyze how a batsman will play, we only need these parameters initially. I mean, we can further narrow down our analysis by adding more parameters, but that's for later. We're just going to stick to these parameters for now. Now, when I get the information about the capped batters, this is how the dataset looks like. We have all these batters, their team nationality, matches played, runs, average, and strike rate. Similarly, we have done that for bowlers also. Then again, bowlers, we have changed the bowler type or the player type to bowler. And we have located all the capped players. For the parameters, we have taken player name, team nationality, which has been in the batters data also. And then we have stuck to matches played, wickets, then there is bowling average, economy, and bowling strike rate. So these are the parameters that we want our bowlers to focus on for our analysis. Now then again, the final capped bowlers dataset looks like this. So this is how we have consolidated the information for the bowlers. And then after this, we have the capped keepers. Now for keepers, we are using only the data which will showcase their batting performances and how they have kept the ball behind the wickets, which is basically how many catches, runouts, and stumps they have made. So this is how we have consolidated the information about the keepers by using the keeper as the player type over here. Then the capped is equal to 1 because we only want the capped players and all these parameters. So this is how our data looks like. So we have all these keepers that were sold in the IPL auction. We have all these matches played that they have, the runs, average, strike rate, catches, runouts, and stumps. Similarly, we're doing this for the capped all-rounders also. Basically, what we have done is the type or the player type is the all-rounder over here. We have done the capped is equal to 1, and we have got all the capped all-rounders, in which now this is a fun part. We have kept the batting and the bowling performances for the all-rounders, because in the game they're going to be used for both of these options. So we have kept all the batting parameters and the bowling parameters as well. And this is the first look at our all-rounders data. So we have all these all-rounders, and this basically this entire data set for all the capped all-rounders is longest, because these have the most number of elements or the most number of columns where we'll do our analysis. Now, since we have segregated the data, we have done only the first part of the entire cleaning the data part over here. After this, we move on to filling all the null values with 0, because we don't want to keep it as a NaN value, because it may cause redundancies in our data. So we just kept it to 0 so that it doesn't make any difference at all. So we have done that for capped batters, for capped bowlers, all-rounders, and keepers also. Here you have used the fill NA method, which basically fills all the NA values to whatever we have provided over here in the argument, which is 0 for our case. Now, to check if you have made the corrections completely, without any mistakes, you can check if there is any null values in your final batters, bowlers, and all-rounder data. So we have used the is NA method that we have done previously also. So here you can see there are no null values, or even if there were, they have been replaced with 0. After this, we come back to our initial analysis. So now that we have all these data sets which have only the batters, bowlers, all-rounders, and keepers data, now what we'll do is start with the analysis of batters data or batsman data. So here what we'll do is we narrow down our analysis to the batters only who are averaging more than 32. Since, let's say, for example, from out of the 235 columns, let's say there are 100 batsmen, and for our team, what we are going to aim for, we only need, let's say, 3 or 4 batsmen. So we don't want to analyze all the batsmen. So to just narrow it down to only a specific group, we have used the average of each of those players, and whoever has more than 32, the average, we are using then again the LOC or the log method over here, which is going to segregate the data further to only those players who have average more than 32. And now we sort the data based on each of the parameter, right? So for that, we are going to use the sort values method, and this is basically going to sort the entire players who have average more than 32 into ascending or descending orders. So this can help in our initial analysis before we visually represent all these values. So we have done this for averages, we have done this for strike rate, we have done this for runs, and for matches played. So let's take a look at how each of these data frames looks like. So first of all, we have the top batters average. In the top batters average, you can see we are going down in the descending order. So the most average anybody in the campaign who have been sold has 47.43, and the last one who has more than 32 average is 32.90. So we have narrowed it down to how many? I think 8 players over here, which we need for our analysis. And out of these 8 players, we'll choose, let's say, 3 or 4 batsmen that will be in our best 11. So we know for sure that out of these 8 players, the top 3 are KL Rahul, Ruturaj Gaikwad, and David Warner, who have the top 3 averages among these lot. Then again, we do this for strike rate, and we have all these values for strike rate, where the highest is 139.97 and the lowest is 126.60. Now, based on this, we can figure out some similarities in our data, like who is going to top these charts. If we just analyze the strike rate and average, the top 2 players we have already got, which is David Warner and KL Rahul, because both of these players are in the top 3 here. So we know for sure that these 2 players are going to be there if we just consider the strike rate and the average. Now, since we are using 4 parameters, we have to keep our analysis not limited to just 2. We have to do it for the other 2 parameters as well. So now we check the batsman's run again in descending order. So the most are from this gentleman Virat Kohli over here, and the least are from Ruturaj Gaikwad over here. So this also creates a little bit of imbalance in our analysis. Right now we were looking at, let's say, David Warner and KL Rahul. Now we want to consider Virat Kohli, Shikhar Dhawan, and David Warner again is in the top 3 over here. So this basically means that David Warner is going to be in our batsman list when we come up with the final 11, because he is already topping the 3 charts over here. And now again we look at the fourth one, which is the how many matches the batsmen have played. And here then again Virat Kohli is topping the chart. Then we have Shikhar Dhawan and David Warner. Since David Warner is in all 3 or 4 of the parameters that we have used, we're going to keep David Warner in our team first of all. After that, if you just rank down these players from 0 to let's say 10 on each of these parameters, for averages, for strike rate, for batting runs, and for batting matches, you will come up with a list where you'll have 3 top players, and those are going to be David Warner, KL Rahul, and Virat Kohli. Since Virat Kohli is topping the charts in 2 of these 4 parameters, and then again he was somewhere around the 7th position in the strike rate, and in the averages he was also not very behind. So that's why we have kept Virat Kohli. And KL Rahul also, again, the number of matches he's down the middle somewhere, and for the runs also. So this is how our initial analysis looks like. Then again we'll visually represent all these information and look for better insights. For now, we are keeping David Warner, KL Rahul, and Virat Kohli in our batsman list that are going to be in the final 11. Now we move to the bowlers data. Now we do the same thing again. For top bowlers, we have done one thing. For bowling average, whoever has less than 24, we have kept only those players in the top bowlers list. The reason for doing this is because the more the average, it's not looking good. I mean, it doesn't look good for the bowlers. The average has to be less, which means they are basically getting more wickets. And now we have done the exact same thing, the sorting values for the bowling average, the bowling strike rate, and for wickets, economy, and matches. As you can see, I'm not mentioned the ascending parameters in these 3 values because we want these values to be in a ascending order. Now after this, we take a look at each of these parameters one by one. So for the top bowling average, we have all these values. Now again, there were a few redundancies when we were extracting the data. That's why we have all these values over here, because they've only played 1 matches, and this gentleman has also played just 3 matches, and that's why they are showing on top of the chart over here. So we'll consider players from, let's say, here. So all the values are for bowling average. So the most efficient is the guy Joseph, who's in the Gujarat team, and after that the least is Varun Chakravarti from the Kolkata side. So these are the top bowlers for the bowling average. Then again we do the analysis for top bowlers strike rate, and we have done this for ascending order as well. So you can see we have Joseph and Varun Chakravarti at the end. We have players like Angidi, there is Kagiso Rabada and Arshdeep Singh, and all these players who have the strike rate over here mentioned. Now we have done this same thing for the economy as well. Now this is where the chart actually changes. So for the least is Chakravarti over here. The gentleman has only played 31 matches, and then we have Jasprit Bumrah, then we have Nathan Kuntal, there is Yuzvendra Chahal, and at the end we have Alzari Joseph, because we're not considering Rasik Dar and Sean Abbott. There's one more player we are not considering, which is Kuldeep Yadav. So these 3 players, I think we have missed it during the extraction, the data extraction. These players are not capped. I mean, they have not played IPL. I may be wrong, but I'm not pretty sure about these values. And since there are only very limited information about their matches and the statistics, we are going to negate these values for now in our analysis. For the next part, we analyze the wickets that these people have taken. Then again, we have different values. This gentleman, Kagiso Rabada, has been showing consistently. So we'll keep Kagiso in our top bowlers list for now, the number 1. And then we have players like Jasprit and Yuzvendra Chahal, which have been showing in economy. They've been showing in the number of wickets that they have taken. Then again, if we take a look at the matches, Yuzvendra Chahal and Jasprit Bumrah again, they top the chart. So we'll keep our bowlers, or the initial analysis tells us that these 4 bowlers are going to be in our best 11, which is Kagiso Rabada, there is Jasprit Bumrah, Yuzvendra Chahal, and Nathan Coulter-Nile. So all these gentlemen will be in our best 11 for now. We will take a look at the visual representations of these parameters, and we'll get a best idea about how these people are performing accordingly. Now we'll take a look at the all-rounders again. So all these all-rounders, we have narrowed down our search, or narrowed down the top all-rounders according to the strike rate. Because any all-rounder is, let's say for example, plays in the middle order, and there we actually need, or they are going to play in the death overs. Like that's the best probability we have with the all-rounders. So we have kept the strike rate as a parameter over there. So we'll have all the bowling all-rounders and the batting all-rounders, which we can help in our top all-rounders list. So according to that, we have kept the multiple parameters here, which are basically the batting parameters and the bowling parameters. So we have average, strike rate, runs, matches, and then we have bowling average, bowling strike rate, wickets, economy, and matches again. Okay, so we have done the matches twice, which we can only use once, because this is exactly the same value, which we can ignore one of this. And then again, we have done only the ascending for a few of them. Bowling average and bowling strike rate and the economy is in ascending order. The other all parameters are in descending order. So this is the final data set that looks like according to the averages. So we have this gentleman Kieran Pollard, and this is also one of the redundancies from the data set, which we have not which we have got wrong during the extraction. This gentleman here, I think, haven't played a lot of matches in the IPL, and we have missed that during the extraction. And then we have players like Krishnappa Gautam, then there is Jofra Archer, Mohammad Nabi, Andre Russell, Hardik Pandya. All these all-rounders are in our top list according to the averages. Now this is how we segregated them into the top all-rounders list, which is according to the strike rate. And this is how it looks like. The most is 178.57 and the least is 140.44. Since we have already taken the values above 140. Here averages also I'll tell you once. I think the average is starting from 29.98. This gentleman has a very good average, and then it goes down to 13.3, or we'll take 14.3 as the least amount of average. After this, we have parameters like all the runs they have made. So this gentleman again tops the chart with 3,268 runs, and in the least we have Mohammad Nabi, which has 180 runs, and then we have Glenn Maxwell, Andre Russell, Hardik Pandya, and Sunil Narayan, and all these people respectively. When we take a look at the matches over here, we have all these values for the number of matches they have played, where again Kieran Pollard actually tops the chart. And then we take a look at the bowling average, where the statistics have changed a little. So now Kieran Pollard is at the place third from the last, and the most number of bowling average, or the most average from a bowler, has been from Jofra Archer, who has played 35 matches, and the bowling average is somewhere around 21.33, and it goes down from here. The last is Krishnappa Gautam, who has 43.23. Now we have the bowling strike rate again. Here also the statistics have changed a little. So the strike rate goes, the least is for Andre Russell, and then we have the most bowling strike rate is for Krishnappa Gautam. And now we have the all-rounders wickets. So the most wicket goes to Sunil Narayan, who has somewhere around 143 wickets. The least is for Mohammad Nabi, who has 13 wickets. Now looking at all these information from these data, just by visually checking, or just by doing the initial analysis, you can figure out a few players who are going to top these charts. What you can do is rank these players starting from the first chart itself from 0 to 8. So whoever is on the, let's say, first rank, that's kind of how you can narrow your initial analysis. So that player, how many ranks he is getting among all these 8 parameters, that's how you can decide. Whoever has the least can go down in the final list. So this is for the economy. Then again we have Sunil Narayan, and the least is for Hardik Pandya. So from the above analysis, we can rank down from the place from 1 to 10. Just I've told you how you can do that. And the top all-rounder options are Andre Russell, Sunil Narayan, Hardik Pandya, and Jofra Archer. So these 4 players are going to be amongst the best 11 that we are going to decide after this. Now, analyzing the keepers data is also the similar task that we have done, but we have narrowed our search based on the average that these people are scoring. So we have kept it for more than 25, and according to that, these are the players who are in the list. So the most goes to Johnny Besto, who has the average of 41.50, and the least goes to Dinesh Karthik, who has an average of 25.80. After this, we have the parameters like strike rate, then there is keeper runs, and we have matches, catches that they have taken, the runouts, and the stumps. Now this one is an easier analysis for us because in most of these parameters only one person is going to top the chart, but we have narrowed it down to 3 still. So for the keeper strike rate, then again we have Josh Butler, who is topping the chart with 150 strike rate, and the least goes to KS Bharat, who has 122.40. After this, we have the top keeper runs, where MS Dhoni has 4,746 runs, which is the most. And then we have Dinesh Karthik and Ambati Rayudu. And at the least, we have KS Bharat, who has only played 8 matches and has scored 191 runs. After this, we have the top keepers matches, how many matches these guys have played. Then again, we have KS Bharat at the bottom with just 8 matches, and MS Dhoni topping the chart with 220 matches played. And Dinesh Karthik has played 213, then 175, and then again we have the second last at Johnny Bastow, who has 28 matches in his kitty, and he has already scored 1000 runs with the most average. Now again, we have these people who have made the most catches and the most runouts and stumps as well. So without any doubt, we have MS Dhoni topping the chart in all these 3. Then again, we have Dinesh Karthik at the second spot, and the third spot keeps changing according to the parameters. For runouts, it's Ambati Rayudu. For catches, it's Sanju Samson, and for stumps, it's Quinton de Kock. So these are the parameters and the players that we have initially analyzed through these findings, and we have narrowed our search down to 3 players, which is MS Dhoni, Dinesh Karthik, and Rishabh Pant. So according to the matches played, the runs scored, the average, strike rate, catches, runouts, and stumps, we have ranked them down from 1 to 10 according to where they are standing in the list, and according to that we have come up with the 3 players. So we have done the same thing for all these players. We have basically ranked them based on where they are standing in the list according to one parameter, and adding all those positions or the ranks, whoever has got the less or the least rank is topping the charts in our findings. So this is the basic initial analysis that you can do for any data, and you can find the relationship between how these elements will perform on different parameters. Not only, since this is a very simple data set, we have curated this according to our analysis, and it's very easy to just make out these findings. Otherwise, if you are using some complex data, for example, the analysis has to be somewhat extensive. It has to be a little bit more complex, where you will use more relationship wise on how each of these parameters are aligned towards each other. For example, let's say the number of matches somebody is playing is going to be linearly related to how many runs they're scoring. Because, for example, let's say somebody has played 500 matches, so they have got more number of chances to score runs, and let's say they have scored 5,000, 6,000 runs. So that's how the relationship will go inside the data. So matches played, runs, or let's say for example, if somebody is making 126 catches, that is because they have played more number of games. Now if we average it down to how many catches per match, then that is another question which we can use in our extensive analysis, where we use more number of parameters. Like I've told you, for batsmen, you can do the same for keepers, you can do the same for bowlers, you can do the same for all-rounders as well. Like these parameters will keep on growing if you narrow down your analysis to a point where you want the exact results, or you want the exact information about any of these statistics. And now that we have done the initial analysis, let's move on to the visualization of each of these parameters, so that we get a clear understanding of these findings that we have done. For visual representation, we are going to do it on the segregated data we have done so far, and we are going to plot the exact same graphs we have done for our initial analysis. That's what we have done in our basic initial analysis, which is nothing but getting the information about averages and strike rates and all those things. So first of all, we are going to visualize the batters data. Now the plot shows here the top batters strike rate. So here, instead of looking at the data set with all these values of top strike rates, what we can do is just visualize them, and based on this we can just figure out which player has the highest strike rate. So David Warner, then there again, then we have KL Rahul somewhere along the same lines, and then we have David Miller also. So we can do the same thing for runs. So this is how it looks like. So the most runs is by Virat Kohli, and then we have David Warner, there is Shikhar Dhawan, KL Rahul is also among the top 4 here. Faf du Plessis is also just behind KL Rahul. So this is how easy it becomes to just visually analyze the data using Matplotlib, or we are using the bar plots here from Seaborn library, where you just give the x-axis, which we have used the player name from the data set, the top batters, and this is basically the runs we are getting. We just change the values over here in the y-axis. Now we are getting the averages from each of these players. Now if you take a look at this, the most number of the highest average is with these two people, KL Rahul and Ruturaj Gaikwad. Then somewhere down the lane we have Kane Williamson, who also has a good average. There is David Warner. So if I take a look at just Warner's finding in these 3 charts, or let's take a look at 4th one and we'll figure out. 4th one is for the number of matches played. Here Virat Kohli is topping the chart. Then the second one is Shikhar Dhawan. Then there is David Warner, and KL Rahul and Faf du Plessis looks like just above each other. Maybe a few numbers are here and there. Somewhere around 100 matches both of these players have played. Now the question is, just by looking at David Warner's data, can we not just figure out he's actually in the top 5 of all these 4 and almost topping the chart in one of them? And then again, if we take a look at Virat Kohli, he's also somewhere around in all the 4 charts over here. And the third player that we have with KL Rahul, he's topping the chart here almost. Then we have him here also, where we have mentioned all the runs. Then we have him here at the average, which is the highest with any batter. And then in the matches also, he's not the one exactly in the top, but he's not at the end also. He's somewhere in the middle. So that's how we have narrowed down our search for the 3 batsmen like that. We have KL Rahul, Virat Kohli and David Warner. Now we visualize the bowlers data. Now again, for bowlers data, we have a few redundancies where we have null values which we replaced by 0. So that's why we are not getting enough values in these 3 columns. Otherwise, we have the values for other bowlers here. So first of all, we have the bowling average. So the lowest bowling average sits with these 3 people. And Alzar is Joseph. There is Kagiso Rabada, Lungi Angidi and Hendrik Nokia. And the highest is with Varun Chakravarti and Jasprit Bumrah. So from here we can figure out that these 2 people might be in our list. Now we go down the second parameter, which is the economy. So who has the lowest economy among this lot? So we have Varun Chakravarti, Nathan Coulter-Nile is also not doing so bad. Then we have Yuzvendra Chahal, Jasprit Bumrah and Hendrik Nokia. So these people are lowest in the economy section. Then we analyze the bowling strike rate. So the lowest sits with Lungi Angidi, Alzari Joseph, Kagiso Rabada, and then we have Hendrik Nokia. Arshdeep Singh also has a bowling strike rate which is considerably low compared to these people. And then we go to wickets. Here, Yuzvendra Chahal and Jasprit Bumrah are topping the charts by considerable numbers. For matches played, if we consider, the same thing happens. So from this lot, we have analyzed our 4 players according to these particular parameters that we have used for bowlers. Then for all-rounders, we are considering more number of parameters, which begins with strike rate. So we have Andre Russell topping the chart over here. Then for average, we have Kieran Pollard, who is having the most number of average. And then we have players like Hardik Pandya, who's I think at the top 3 over here. Here also he's somewhere around the top section, but let's say in the middle. Krishna Bhagavatam here is actually having a good strike rate, but in the second one he's considerably low compared to the other people. So similarly, when we take a look at matches played, two people have considerably higher number of matches, and the others are not there exactly. Then when we come down to runs, of course, since Kiran Pollard had more average, more number of matches played, he has also created a lot of runs. And that's the exact same thing with these people also, Glenn Maxwell, Hardik Pandya, and other people who have played more number of matches compared to the others. And that's how these two parameters are actually related to each other, number of matches and runs. We have the bowling average, where the lowest is with Sunil Narayan, Jofra Archer, and then the highest is with Krishna Bhagavatam. And then again, for the next parameter that we have, which is the economy, the lowest I think is with Sunil Narayan. Then we have Moeen Ali. Aman Khan we are not considering because this was kind of an outlier, we can say, or a noise in our data which we could not get rid of, because during extraction this was the anomaly we could not get rid of. And there is Jofra Archer, Mohammad Nabi, but Andre Russell and Hardik Pandya are actually not very efficient when it comes down to economy. But when we rank them down, let's say for example Hardik Pandya, if we consider in these charts, he's actually, let's say, amongst the top 5 players that we are getting. Only in the section where we have economy, the bowling strike rate, and all these criteria, there I think he's lacking a little bit and coming in the middle. Otherwise, he's actually topping the charts in all these parameters. That's why we have kept him in our list of all these bowlers. Now, if we take a look at the wickets also, Sunil Narayan compared to any other player has the most wickets over here. Then we have Andre Russell. Hardik Pandya also has a lot of wickets. Kiran Pollard is there, and Jofra Archer also is having a lot of wickets. And here also the economy, I think the bowling strike rate is very low for Jofra Archer. Economy is also among the middle over here. And then if you take a look at the bowling average, it's considerably the most efficient over here. And that's why we have kept Jofra Archer in our list also. After the wickets, we come down to analyzing the keepers data. Now here, let's say this is MS Dhoni in the olive color over here. He's going to top at least all the charts over here, because he's considerably the most dominating keeper in this section, and that's why we have kept him in our best 11. The other players which we kept, like Rishabh Pant and Dinesh Karthik, if we see for the average, Rishabh Pant has a very significant amount of average over here. Although Dinesh Karthik is not topping the chart here, he is considerably ahead of all these people in runs. Rishabh Pant is also among the top 5 here, and MS Dhoni is again topping this chart. When we take a look at strike rate, Dinesh Karthik might not be in the top 5 over here, but Rishabh Pant is actually among the top 3, with MS Dhoni just below, or we can say just above Dinesh Karthik over here. The most sits with Josh Butler. And then again, if we take a look at the catches, Dinesh Karthik and MS Dhoni are topping the chart over here, with Rishabh Pant being in top 5 compared to Sanju Samson and Ambati Raidu, who are also doing considerably good over here. So visually representing the data helps you in analyzing it much more efficiently, because ranking down players like that can be a little bit trickier, and you can just look at the data from these charts and decide on your own. So over here, if we take a look at the runouts, most sits with the MS Dhoni, and then Rishabh Pant is among the top 5. Some of them have no values over here. Ambati Raidu, Dinesh Karthik also I think is the second highest over here. That's why we have kept Dinesh Karthik in our top 3 list, because except 1 or 2 in all the parameters, considering stumps, runouts, catches, Dinesh Karthik is actually at number 2, and that's why we have kept him with Rishabh Pant in our top 3. For matches played also, Dinesh Karthik is at number 2, MS Dhoni at number 1, Ambati Raidu at 3, Sanju Samson 4, and Rishabh Pant at 5. So considering all these visual representations, we have narrowed down our search, where we have finalized 3 batsmen, 4 bowlers, 4 all-rounders, and 3 wicket keepers. Now from these people, we will visualize some more information and according to our problem statement, we'll come up with the final 11. So now to form our best 11, we have to focus on a few things. First of all, we have to consider the number of players from each category that the T20 World Cup winning team had in their squad. And I also told you we'll consider the IPL's winning team for the last campaign. So Australia won the T20 World Cup, and they had 3 batsmen, 3 all-rounders, 4 bowlers with 1 spin option and 1 wicket keeper in their squad in the final match. And for Chennai Super Kings, the squad had consisted of 4 batsmen, 3 all-rounders, 3 bowlers and 1 wicket keeper. So taking into account these two statistics, we can narrow down our search for the best 11 according to 3 batsmen, 3 all-rounders. We keep 4 bowlers with 2 spin options, or we'll try to stick to 2 spin options, and we'll have 1 wicket keeper. So now after this is a very simple representation of all the batsmen with all their parameters that we have analyzed them on. So for example, we finalized David Warner, Virat Kohli and KL Rahul for our batsman category. So we have stored their all the values in whatever information they had in their data frames and visualized them on our graph over here. For each graph displays certain information, which is matches played, runs in the IPL, average and strike rate. So for the top 3 over here, KL Rahul has the least number of matches, but he has the second highest strike rate and the highest average over here. Even though David Warner has the matches played in the range of let's say 150 matches only, the strike rate is the highest among the 3, and the average is also in the middle. And when we consider Virat Kohli, for the number of matches he has played, he has been consistent with the average, and there is enough data on strike rate which is more than 120 and 6000 IP runs. So this is how we have just narrowed our analysis to just the parameters we want our 3 batsmen to look for. Similarly, we have done the same for the all-rounders. So we had finalized Andre Russell, Sunil Narayan, Hardik Pandya, and we left out Jofra Archer because we are only allowed to keep 4 overseas players in the best 11. That's why we have kept Andre Russell, Sunil Narayan and Hardik Pandya only. Now we have gathered all their values for specific parameters from the dataset top all-rounders. I forgot to mention this for batsman data. So we are just locating these rows where these people or these batsmen have been placed in the dataset and extracting that information so that we can display it on the graphs. And we are using the subplots to plot these graphs in the same space, and we are using the bar plot from the Seaborn library. If you have any questions, you can mention them in the comment section below, guys, because this might be a little bit complicated for a few beginners, how we have used these axes and all. We have just declared this subplot 2 by 2 where this is 0 by 0, this is going to be 0 by 1, this is going to be 1 by 0 and 1 by 1. So this is how we are subplotting these 4 plots in just one big image. And we have done the same for this also, where we have used 4 by 2 subplots where we have 2 subplots each side, and this is one big image where we are getting all these information. So we have done this for bowling average, wickets values and economy values, and all these parameters we used the all-rounders to analyze. So for these 3 players, we have matches, the runs they have scored, considerably how many number of matches Sunil Narayan has played. The runs are a little bit on the lower side, but the number of wickets are on the top here, and that basically shows that Sunil Narayan is kind of a bowling all-rounder and a spin option again. That's just additional information I'm giving out here. That's not mentioned in the dataset anywhere, guys. Also, if we take a look at Hardik Pandya, we have the number of matches played more than, I think, 80 mark over here, somewhere around 100 or less than 100, and the runs he has made is almost as good as 1400. The strike rate, the average, the bowling average is on the higher side, So this basically shows that he is kind of a batting all-rounder, but he has been taking wickets, which is kind of around 40 wickets he has taken. The economy is also on the higher side here. Andre Russell is a complete package in that sense, because the number of matches played, the runs, the wickets he has taken, economy is a little bit on the higher side, but the bowling average also is a little bit lower, because we have narrowed it down to just 3 people. That's how we are getting these values for just the three of these all-rounders. Similarly, we have done the same thing for the bowlers. So the bowlers are only analyzed on 3-4 parameters, which is the number of matches they have played, bowling average, strike rate, wickets, and economy. And this chart basically has been left empty because we had initialized the 3/2 plot over here, and we didn't initialize anything for here. Alright, so this is how we can just represent our analysis, or these are the findings we got from our analysis. We are putting it down to our visual representation so that we get a more clear idea on how these players are looking like according to these parameters. Similarly, if we do it for example, let's say, so we had 3 players in the data over here for wicket keepers, but we have narrowed it down to just one, because only one player will play as a wicket keeper in the entire team. So we have narrowed it down to just the top player, which is MS Dhoni. And if we take a look at the matches and the runs, so this guy has played somewhere around 220 matches, and the runs are more than 4,000, closer to 5,000 mark over here. If we take a look at the average and the strike rate, average stands somewhere around 40, and the strike rate is more than 130. Then again, the keeping stats, number of catches is 120 plus. If we take a look at we can compare these values to matches according to our analysis. We can add hue over here, add number of matches, and compare the values of catches, stumps, and runouts to get a better picture of the analysis. This is how you can extend your analysis based on more parameters. You can figure out how many catches per match or statistics like that. Now, after we are done representing all these values or all these statistics about our final 11, we consolidate that information in a single data set, and that's how we have done it over here. We have used the concatenation function from pandas to concatenate all these different data frames. We have consolidated using the LOC method for pandas, and we have consolidated final team and dropped all these different values or parameters like matches played, which we have analyzed them upon. Now we just need the team that they are playing for and the nationality, because we have to decide how many overseas players can play in that team. So coming back to our presentation, guys, so results from our analysis shows that these are the final 11 according to the parameters that we used in our analysis. That stands a good chance. So this is the best 11, which consists of KL Rahul, David Warner, Virat Kohli as batsman, Andre Russell, Sunil Narayan, Hardik Pandya as all-rounders, MS Dhoni as keeper, Nathan Coulter-Nile, Kagiso Rabada, Jasprit Bumrah, and Yuzvendra Chahal as bowlers. And we still have 2 bowling options that are going to offer spin, which is Sunil Narayan and Yuzvendra Chahal.
Just a quick info, guys. Intellipaat offers data analytics course training. Through this course, you will master Power BI, data wrangling, data mining, and much more from the IIT Roorkee faculty and industry experts. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take the first step towards career growth in the field of data analytics.
Now, what we did, we very firstly loaded this data. What was the aim we were having? We were having the air passengers data set, where we have the data given by any airline company, where we have the monthly data, like every month, how many passengers traveled through that airlines, right? So we can see that, okay, so what very firstly we try to clean it. We check the null values, we don't have any. We check the duplicates, we don't have any. Then we saw that the data type is not proper. So we just converted my object months into your data time format like this, using this period to data frame date time function. Okay, after that what I did, I kept it as an index so that, as I said, it would be more easy for me to perform the upcoming code. We just directly have to pass the df instead of passing df of that column or something, and eventually in ARIMA model that could be much easier basically. Okay, then okay, we try to see the plot of the data, that what trend we have in the data. Okay, so just a second, I think I skipped this done. Okay, so here is the data that we can see that what kind of seasonality trend we have in the data. Okay, now if we just do the seasonal decompose, remember seasonal decompose was just a function which will allow me to break down and see the various components of my data. So trend is there, seasonality is there, yes, repetitive patterns, and the residuals are there, right? Now what we did, we can see that the data was already a non-stationary. Okay, but still to verify that, we just perform a statistical test, that is ED Fuller test, which is called as augmented Dickey Fuller test. Okay, so this test was supposed to return me the p-value. Since p-value is greater than 0.99, which means we have to reject, we have to accept the null hypothesis. And what does the null hypothesis of ED Fuller test says? That the data is a non-stationary. So thus we accepted that the data is a non-stationary. Fine. Okay, after that, now what we did, okay, so since I've told you that rolling mean and rolling standard deviation should be constant, then I can say that there is a there is a stationary data, right? But now let's check the rolling mean and rolling standard deviation. So we see that window we have kept 12, so that I've shown you yesterday itself, since there were seasonality of months, okay, in a year, basically in 12 months I'm having the seasonality, so I'm just keeping the window 12. We can keep anything else also, but for the better results we suggested to go with the seasonality. Okay, so 12 we kept. Okay, so now I'm just checking the rolling mean here. Okay, let me run this command first. Okay, now here I'm checking the rolling mean, and after checking the rolling mean and rolling standard deviation and with the original data, we saw that standard deviation was almost okay, I can say constant. Okay, but not almost, like about to get constant, whereas the mean is very much far. Okay, so the reason of mean is very much far, since it's the data is having a very much high trend. So what I'm trying to do is I'm trying to smoothen my curve by detrending it. So I just perform np.logarithm so that I can just make my curve more smoother and detrend the data. Okay, so after performing this, let's say logarithm, I again check the rolling mean, and I saw that okay, the mean is slightly little the curve is more smoother now as compared to the previous case, and also the mean is now almost getting the constant, whereas standard deviation is very much constant, I can say that, right? The mean is also getting constant, but not exactly. Thus we know that alone performing log transformation, it is not giving me a stationary data. Thus I have to take one step of differencing. So differencing was something I've told you guys, just assume it something like very costly, so we should always go with the least number of differencing steps to get a better results. So yes, we try to perform the differencing first time. Okay, so we are performing differencing, and we saw that again rolling mean, and we can see that after just performing differencing, we found almost mean and standard deviation are constant and are parallel to each other as well, right? But still we feel like maybe a little bit thing left, but I can feel that it's almost stationary, right? And thus when we check the p-value again, it came to be 0.07, which is very much close to the rejection level. Okay, if the value is less than 0.05, which means we have to reject it, but still we are accepting that data is a non-stationary, right? But as I said, I don't want to utilize again a differencing step, okay, just to fix this small non-stationarity. Okay, it's almost stationary data. Okay, just to fix this small non-stationarity, I don't want to waste again a differencing step, because as I've told you, multiple time differencing can actually create and cause problems or issues in your uh, predictions basically. So that's why differencing step should be as minimum as possible. Fine, that's the reason. So what I assumed that I would go ahead with this itself. Okay, I would go ahead with this data only. I'm assuming that it's almost stationary, so it's stationary only. I'm not considering it as a non-stationary. Okay, thus what I get to know that thus to make the data almost stationary, we have to perform at least once a differencing, right? So we have noted down the steps, how many times differencing are supposed to perform, that only one time. So that thus what conclusion we made, that here you can see only one time differencing is needed to make the data stationary, that is d equals to 1. Fine, this much is clear guys to all. Now see guys, so since we were working on the model implementation now, so here in the model implementation, what I told you that I want here some of the rows to be predicted, some of the rows that based on which machine will learn, and the remaining rows that I want machine to predict. Okay, that's basically train and test split. Okay, so here we don't have any criteria of 70% to 30% something. It's up to you, but yeah, give more rows to the training and less rows to the trace testing. Okay, so here what I did, out of total 144 rows were there, right? So I think we know that in the given data there were total 144 rows. That's just dropped one. In the actual row, if we see, okay, so there were almost 144 rows. Okay, fine. Now, thus there were 144 rows. What I'm doing is randomly 120 I'm doing, so saying that it will be training. Okay, the remaining 24 we have, which means, yes guys, if you have 24 steps, right, or like I'm saying, let's say 24 rows, so which means how many years I'm talking about, guys? Yes guys, 24 rows, which means how many years? 2. Very good. Since we are saying about the 24 rows, which means each row represents a month, which means 24 months, which means I'm saying I want the remaining 2 years for the prediction part. I want to do the prediction of the remaining 2 years, and the starting years I want to give as training. Okay, so you can see first 120 rows will be coming as training, and the remaining 122 till 144 by the end it will be your testing. Okay, now after that, if you see here, let's say, yeah, so this was a training data having 120 rows, and this is the testing data which is having 12 months 24 months from 1959 January till your 1960 of your December, right? So which means 1959 and 1960, both the years are completely there. Fine. Now what I was doing, I was building up a ARIMA model here. Okay, I was importing ARIMA model from stats model.tsa.arima model.import ARIMA. Okay, one more thing, let me run this previous rows. Okay, just a second, because I think I haven't run this previous rows from here. Okay, I'm running these rows. Just a second, Gauri Shankar is saying something. Prediction is being done from testing data. Yes. See, basically one thing, okay, yes, Gauri Shankar, I'll tell you, and to everyone also. Here, this dividing the data into testing and training, that is eventually an optional, let's say here. Okay, I'll tell you why. It's not like optional, like we can pass entire data. That's not what I'm saying. Listen very carefully what I'm saying is, okay, I'm saying that this is training data, testing data, which means only, it's not like only I have to divide it separately. If you want, okay, what you can do, let's say this is the ML model, or let's say time series model you have. If you want now, what you can pass in my df.iloc data, if you just slice out this much, I want first 20 rows to be treated as training, right? So while training, you can pass out that sliced data also. And for the prediction, eventually when I'm going to do the prediction, okay, in the actual data itself, I want to mention the indexes for which index to which index we have to do prediction. Okay, so if you don't want to get into this training and testing speed, directly also you can do how that first 20 rows you'll be putting as training, and from 121 to till your 144th row, basically that would be your, sorry, 120 to 143 row, I want to give that as your testing one. Okay, so in that way also you can do, Gauri Shankar, but why I'm doing it, so that it can be more classy, more clear to us that this much is training and this much is testing. Okay, fine. So it's, yes, eventually we will be always doing the prediction for testing data only, correct, Gauri Shankar? For the training data, we'll not do the prediction. Okay, I'll show you how. See, now since we perform the train and test split, okay, after that, if you see, this is the training data we have, and this is the testing data, the remaining 24 rows. Okay, now what we were doing, we were performing the ARIMA model. Here you can see this is the model's name, ARIMA. Okay, here I'm creating an object for this model, that is the model's name, ARIMA model, and this is the model. Here I'm passing the training data, train, okay, and order of ARIMA. What is this? This is the order of ARIMA where we have to give the P, D, and Q value. P is basically your partial this, the autocorrelation value, or I can say D is the autoregressive value, okay, and sorry, this is Q for the moving average, P for the autoregressive, and D for the differencing one, guys. Okay, so since we know that the value of D is what, guys? 1, right? That how many times we have performed differencing? We have performed 1 time differencing. Okay, so we know that D is 1, but we are not aware of P and Q. We just randomly take the value of P and Q just to see that what output we can expect. Fine, we were not choosing yet the best model. It's just randomly we have put it up the 1 1 1 value to see that how the model will run and what output I can expect in such case when I'm not choosing the optimal values, I'm just choosing the any random values here. Fine. So I just ran the model with 111. After that, I have to give the fit command to my model. Okay, so basically this is the data we have, but yet it has not learned until unless I'm not giving the fit command. So giving the fit command, and yes, make sure here you can have a mistake, guys. Usually we give directly model.fit, but whatever the fit command will return, that instance or whatever it will return, that has to be saved in the same variable itself. Okay, or your model name basically. Right, it's basically kind of whatever you have learned, it should be I can say commit basically. Okay, so thus I'm making my model to learn and saving it back to the same variable. Okay, now if you see after doing this, now you can see what I'm doing. I'm saying here either directly I can say ARIMA model should predict, okay, in the logarithmic of DF, okay, in the data frame, okay, what I want to create another column, ARIMA prediction, that should be the that should predict from 120th row till 144th row. Okay, or else if you don't want to give this actual number, okay, because sometimes we might can get confused, isn't it everyone? We might can get confused like the upper row, the next row, or something like that. We can get confused in the index numbers. So there is a general code. So general code we can write here length of training data. Okay, I want to start from length of training data. Okay, since we have length of training data, we have 120 elements in the length of training data, right? And you know that 120 will be the index of first element of the testing data, isn't it, guys? Correct, everyone? If I'm saying like this, let's understand in a simple way. Okay, let's say if I'm having this data, like I have these rows. Okay, here I have 2, 4, 6, 7, 8, whatever we have. Okay, so let's say there are total 10 rows. Okay, there are total 10 rows. Let's say the first 6 I'm saying for training, I want to predict for the remaining 4. Fine. So tell me one thing, guys. Indexes will start from 0 to 9, correct? Everyone, if we have total 10 elements in the data, indexes will start from 0 until 9, right, everyone? Correct? Okay. Now, since if I'm saying first 6 I want to give for training, so 0, 1, 2, 3, 4, 5. Only till 5 it will be including, correct? Doesn't matter the length of training data is 6, but it will be including till 5, right? That's my training data. But what I'm saying is I'm saying my model to start predicting from the length of 6, length of training data. What is the length of training data? 6, correct? So I'm saying to start predicting from 6th index. Now, the 6th index, don't you think so? It's a part of testing data, isn't it? Correct, everyone? If I'm saying the index should be length of training data, that is 6. So 6 is the index of your training data, testing data, isn't it? The first element of your testing data. So that's what I'm saying. You have to start from length of training data, that is 120th index. So 120th will be the first element of your testing data, right? And you should end at okay, at what position you should end? You should end here with this. Okay, so that is length of training data, that is 120 plus length of testing data. What is length of testing data? 24, correct? 120 plus 120 plus 24 would be 144, right? But I want -1, which means eventually the indexes are always one less, correct? I think everyone agree with that. The indexes are always one less. Thus, if I run this and you see here, we have 143 as the last index value, correct? So we can use this general code here so that I can pass here to my model to predict. Okay, so starting value as length of training data, ending value as length of training plus length of testing -1. Yeah, this much is clear to all, everyone. Can I have the confirmation to all from all, like what we did here? Just generic logic here. Instead of me putting the values, I've created a general logic. Now if we're using this general logic every time, we don't have to struggle with which index and which all, whatever data we are working with, we just have to use this general code. Okay, but if you want to use a general code, that training and testing split what we did, it's mandatory. Fine. Okay, now after this, let's say if I'm checking this original data frame after running this code, okay, and here you can see here. See, this is the original data we have, where we see that for the starting values it's showing NN. Why? Because I've told my machine not to predict for starting value, only predict for that last testing data. right? So if you want to see here also, let's say I'll add here this data log df. Okay, so this log df should be, let's say, dot head dot tail. Let's say I want to see the last values. Okay, so since last 24 values are the prediction, right? Let's, for the reference, I'm saying, let's say I'm checking the last 30 values. Okay, just for the reference, guys. Okay, so here you can see I'm checking the last 30 values. So can you see, guys, here I can see the predictions 1 2 3 4 5. Okay, so I might can see the last till 24th prediction, right? Last 24 predictions are present. That is, this is the index number 120 and this is the index number 143 that I've told to start predicting from 120 to 143. Before that, whatever we have, all are NaNs, guys. Okay, fine. Okay, now what we tried to plot this into a graph. So when I'm plotting it, okay, so in the given data, what all two values we have? I have the original data, passengers, and I have the ARIMA predictions. If I create a normal graph, so we can get that original data is like what it was already earlier. Okay, but can you see this orange line is representing the prediction of ARIMA? Okay, then definitely we concluded that the predictions are not at all good right now, isn't it? Right, everyone? Predictions are not at all good right now, right? It has to. Okay, tell me one thing, guys. In case if I'm looking for a best prediction, don't you think so? The prediction or this orange line should exactly overlap with the blue line. Yes, guys. Only then I can say my model is predicting good. Correct? If the orange line is properly overlapping with the blue lines. I think everyone agree with this. I think everyone can understand this thing, what we are talking about here, proper line and proper not, right? So since if I can expect a good prediction, if orange one is overlapping with the blue one, because blue one is actual data, this is the predicted data. So there is a difference between actual and predicted, which means that the forecasting, sorry, the prediction is not good. Okay, 2 you are saying in the PDQ. Yes, we can take that also. Definitely. Whichever various combinations you want, Gauri Shankar, we can take that also. Okay. Let's say if Gauri Shankar is saying randomly take 2. Okay. We'll see that also. Okay, just a second. Others, okay, I'll repeat here, but I've already cleared this thing, but see here. So basically, it's not reading the test data that I've told you, others. Splitting testing and screening is not mandatory here, but just to make a general code, yes, testing is required. Okay, so we don't have to pass separate testing data. One thing you guys have to make clear in your mind, guys. Okay, when we are going with time series, it's not very much similar to the normal supervised algorithm where we pass training data separately and testing data separately. It's not like that. Okay, here I am passing the training data separately, but when I'm testing it, okay, what I'm saying for the testing, I am passing the original data only. Can you see here? In this command, I am saying the log data frame itself, the original data, not the splitted one, original data, just start predicting from here to here. That is, now I'm giving the indexes of training data, others here. Okay, I'm giving the indexes of training data. So index of training data will be from 120 to 143. Correct, Adarsh? Now to get it in the generalized form, what I used here, length of training data, that is 120, and length of training data plus length of testing data. Here I'm using this testing, you can see here, right? So length of testing data minus 1, thus to get the 143 as a number. Okay, so I don't have to separately pass testing data to test my model. From the original data itself, which is not even splitted, from that data itself, I'm saying from this index to this index to the splitting. That's it. Okay, even now, as I said, this training testing split is step is non-mandatory. Okay, why? Because if you want, you just pass some slice of data for training over here. Okay, and here you can directly mention the number. You don't need to use generalized code. Directly mention number from this index to this index. I want to predict basically like that. Okay, but testing I create so that training and testing, why I did mandatory, so that I can create this generalized code basically. Okay, instead of manually entering the numbers, I can use this generalized code. Fine. Okay. Okay. Now coming to the Gauri Shankar's query again. So Gauri Shankar was saying that can we do 2 to 2? Yes, we can do 2 to 2 also. Right. So if we do 2 to here, let's say, since Gauri Shankar said, so let's say I'll say here 2. Okay. But one thing I'll say Gauri Shankar, let me try 2 1 2. Why? I'll tell you. Because differencing is has to be made sure that we should be 2 only. Correct, Gauri Shankar? Because we already clear that differencing should be 1 1 only. Correct? So let's not take 1, let's take 2 1 1. 2 1 2. Right? So I'm randomly taking here 2 1 2, let's say. Here only I'm doing the changing. Fine. Let's see what changes we can have. We might definitely can have changes in the prediction. Right? Let's see. I'm running it, and here I'm running it again. Same thing I'm running again, and let's see the prediction. Yeah, still I can say the prediction is not much changed. Okay, little bit change was there, but not that much. Still, it's a straight, correct? Which means that value is also not a non-optimal value. Okay, so we have to look for a good optimal value, guys, for this model. Okay, so let's do one thing. Now to get an optimal value, guys, we have various options, different options are there, different methods are there. Okay, can't cover all of them together, but yeah, I'll cover at least one or two here. Okay, so I'll write down here, okay, to get an optimal values. Okay, to get an optimal value of P and Q, okay, we have multiple options. The first option over here, okay, is there any code to get up? Yes, that's what we're discussing, Gauri Shankar. Okay, so first option over here is to go with ACF and PCF plot. Okay, so first is ACF and PCF plot. Okay, second option is basically the ITER tool. Okay, second option is basically with the help of ITER tools. Third option is basically your AutoArima. Okay, now I'll tell you uh, how we can use this thing. Okay, now tell me one thing, guys. In case if we have to optimize, or you know uh, we have to improve the prediction of my supervised algorithm, let's say random forest, let's say decision tree. Okay, how can I optimize it, guys? Tell me, any idea? You might have done it, guys. I think in order to do that, how will optimize it? Reduce the cost function. Okay, do we have any techniques or something that can help to optimize the my supervised algorithms like random forest, decision tree and all? Okay, I think I'll give you a hint. In a decision tree random forest, we have various parameters also, right? The n estimators, or we have minimum sample split, right? Something like that, correct? So we change it differently. Okay, we give different value, and accordingly we select the best one, correct? Exactly, Shampa. I was looking for this word, hyperparameter tuning, correct? Everyone, I think most of people are aware of it. So basically, we try with a different combination of the okay parameters, and we see that where I'm having the best answer, right? So same thing we have to do here also. Okay, ACF PCF, I'll tell you what is it. Okay, but before that, let's come to this ITER tool. ITER tool is basically performing the model with various combination manually. Okay, what is the IDEA tool will do? Performing the model with various combination manually with the help of loop. Okay, you might have seen that, guys. Sometimes if we just iterate the loop for various n estimators in my random forest, and we can increase the result, right? So this IDEA tool is basically one of the technique here with which I can perform multiple combination of P and Q, PDQ, and run the model, and we find out that which combination is giving the better result, right? Whereas AutoArima is something like optimizing algorithm. Okay, just like I'll give you alternative. Well, don't relate it like that, but just for your understanding, I can say, guys, just like grid search CV and random search CV in decision tree and random forest model, TT and RF model. Fine. Have you heard of this term, guys? Grid search CV and random search CV? If not, so I'll tell you. Basically, these are some of the optimization algorithms. Basically, not algorithms. Basically, techniques, I can say, where I have to tell that model name, and I usually find out the best combination for the given model. Right. So AutoRema is kind of like that, not exactly, but kind of like that itself, which where we have to implement this AutoRema model, and it will return me the best value of PDQ. Okay, second option we have ITER tool, which is just manually checking the various combination of this PDQ. Fine. And the first option is here, which is called as PACF and ACF plot. Okay, now what is this PACF ACF plot? Okay, that is basically the autocorrelation plot and the partial autocorrelation. Okay, so these are the plot basically that also help me to get the PDQ values basically. Okay, but you know what, guys? I'll suggest you something over here. Okay, one thing that getting P and Q values from this is not always optimal. Okay, getting the P and Q values from this method, okay, are not always optimal, guys. Okay, because it depends on data to data. If there are some issues in the data, I might cannot get a proper correlation in ACF and PCF. Thus, getting the actual proper value of P and Q might be little difficult from the ACF and PCF. Okay, I'll show you the ACF in PCF code here. Just a second. Let's work on it. Okay, so let's say ACF and PACF. Okay, so what I'll do, I'll import it from I think stats model only. Okay, I guess it's in the TSA plot, I guess. Yeah, I got it. So I'll just use here, let's say, fine, from stats model dot graphics dot TSA. Oh, no, that is for AD filler, guys. I'm done. That's for AD filler. In what scenario we will try to use ACF and PACF? Is auto remark? Can you get? Okay, fine. I'll tell you that also, Shampa. I'll come to that point. Okay, let me just show the ACF PCF first. Just a second. Dot TSA plots. I want to import here. Let's say plot ACF, comma plot PACF. Some mistake is there over here. Just let me check here. Okay, it's working, I guess. Yeah. Okay, so what I'll do here, I want to plot this PACF first, okay, ACF first. So let's say here I'll pass the DF. Okay, this is your ACF. Let's do one thing. Okay, so I'm gonna do here plot ACF of log DF. Fine. Okay, just a second. Okay, not for this prediction. Okay, fine, my bad. Because just in the log this one, okay. I'll take the passenger columns here. Now, because in the same data set, if you see, I have introduced another column also, right? So it's showing error. I want this for this given data of a time series. Okay, if I just pass here, this thing, fine. Let's see. And here we can see we are getting this kind of ACF. This is the ACF, okay, for the given logarithmic data. And also, let's go with the PACF. Okay, so I want to do, let's say, plot PACF. Okay, so what we have here, guys, can you see here? Now, how to read this Wix basically? Okay, now what I've told you, will we have a different method, guys, to read this? Okay, maybe we can take the reference of, see, basically, okay, in this graph, can you see these bars here, guys? Long bars basically. Usually we call it as lollipops, guys, in this graph. So we can see that multiple lollipops over here, right? So there is also a shaded region behind this, correct? Can we see, guys? There is a shaded blue shaded region in this autocorrelation graph. Okay, so basically in this graph, what we have, these are the lags basically. So okay, each line here, sorry, each level here is called as lags here. So what does this autocorrelation tells? It see that what is the correlation of first lag with the previous lag basically. So it's showing the correlation value between each of the lags. Okay, now that's different thing, but how to read this? Okay, so what we can do in the ACF, we can see that how many lollipops are there that are outside beyond this shaded region, guys. Can you tell me how many lollipops are there? One. No, how it can be one, guys? I'm saying this shaded region, this blue shaded region. More than one inside. Correct. Correct. So that's also one of the way to handle it. Okay, but other way is something like this. In this PCF, if you see, okay, can you see that? Okay, here some of the lollipops are beyond it. Okay, some are outside it over here, right? So you can see here, uh, sorry, some are going to negative. You can see in this PSAF plot, if you see, this is above, below 0, you can see it's getting negative. Okay, so now before getting negative, how many lollipops we can see before getting negative, guys? Yes, guys, in the PSAF, can you tell me before getting negative, how many lollipops we can see that which are positive? Can we say 2? Correct. So yes, so here 2 can be the good answer here for p value. This is for the p value. So p value could be 2 as a good. Okay, now the q value. Okay, so the thing is, usually we have to take a common logic. Okay, usually what we do, two things are there. Yeah, we sometimes we do this thing, that how many lollipops are there which are outside this shaded region, blue shaded region, that. Okay, or maybe we can do before going to the negative. Before going to the negative, how many are there till positive? So that's, as I told you, we have different way of rating it. Okay, but can you see what are the loopholes and discrepancies over here in ACF PCF? If I apply this logic, okay, if I apply this logic, that how many values are there, okay, here, which are before getting negative, how many lollipops are there? So here we have 2, correct? If I want to apply the same logic here in this ACF, we can't apply that because all are positive, correct? Which means then we have to go with this logic, that how many lollipops are there which are beyond this shaded region. That is something what we get here, almost, I guess 13 or 14, I guess. Yeah, okay, almost 30. Fine. So 13 here we get if we're using the shaded region logic. Okay, but if we use the same shaded region logic here, can I tell you how many positive correlations we have and that are beyond shaded regions, guys? Yes, guys, can you tell me here, beyond shaded region, the positive lollipops? We have 3, 1, 2, 3. Correct. So one combination, proper combination could be this one, where if I'm using this logic. So in the previous case, q was 13 and p is here as a 3. Correct. That could be also one combination. Another combination, if we see the another way of noting down this plots, is something that before getting negative, how many are the positives? So you can see that before getting negatives, 2 are the positives, but here we can't apply that logic. So let's say I'll try with two different logic. I'll try with 3 and 13. Okay, that is the how many lollipops are there beyond shaded region. And other one I'll try with 2 and this 13. Okay, let's try. Fine. So remember, guys, which logic I'm saying? I'm saying either the 2 or 3. Okay, or I'll do one thing. I'll repeat the same code here. Okay, instead of changing here, I want to copy this. I'll copy this. Okay, let me do one thing. I'll copy the cells itself. Okay, so instead of changing the original code itself, I'll do the phasing again. Yeah. Okay. I want to copy these cells. Okay. Cells are copied. Now here I'll paste it. Okay. Now what I'll do, I'll run with, let's say, the first combination. D will be eventually 1, correct? Very firstly, I'll take that combination where I'm taking 3 as this P, okay, and 13 as a Q. Let's say, run this, see the output, and here you can see. Okay. Can you see little bit improvement? Yes, guys, little bit improvement rather than the previous one, a straight line. Yes, guys, can you see here? Yes, Imran, I'll come to that point, Imran, again, ACF and PCF. Tell me one thing first, if can we see little bit improvement, right? Okay, let's see the same with the 2 and 13. Okay, so let's see the 2 and 13. Let's see whether we are getting any changes or not. Not that much, still almost same. Fine. So basically, that's what I was explaining you guys, that ACF PCF always doesn't give you the optimal. This is how we'll read. Okay, I'll repeat here again as Imran said. So Imran, basically there are 2-3 ways to read these ACF and PCF plots, guys. Okay, first way is we have to look at how many values are there that are beyond this shaded region. Okay, Imran, listen carefully. So we have to count these lollipops, how many are beyond the shaded region. If you see here you can see. So we have total 1, 2, 3, 4, 5. So we have to count this. Okay, 13 or 14, I guess. I'm not exactly sure. If we see till this point, it could be 14, I guess, maybe. Okay, fine. So we can try with 14 also, no issues. Let's fine. Okay, but I'm telling you, Imran, that we have to count that how many values are there beyond short region. Okay, other method is there. We have to look that, just assume that there are some lollipops which are going to negatives also, like this. Okay, so we have to see that before going to negative, how many continuously positive lollipops we have. So we have to count that also. But that logic we can't apply here in Irfan, right? Because Imran, because this is your here I'm not having any negative value, right? So I have to apply this logic that how many values are beyond the shaded region. Okay, where in the partial autocorrelation we can apply that logic that before getting negative, how many are the positive? So we can say 2 are the positive. Okay, so like that. So this is how you read. Basically we have multiple methods to read this PCF and ACF. Okay, but the ultimate thing what I was saying here, guys, that ACF PCF usually doesn't give a much optimal value. It's just an idea, guys. It just give what it gives. It just gives us idea basically what can be the optimal, but it always can't be assured that it will be the best or not. Okay, that's the reason I was saying here, I was mentioned here, ACF PCF getting the p values is not always optimal, as it gives rough idea about it. Okay, but if you want to get actually a good value, guys, okay, either you can go with IT tool or you can go with auto arima. So I'll just go with the IT tool once too. Okay, IT tool is nothing just like a hyperparameter tuning of supervised models we have, guys, correct, with the different n estimators we take. Just like that, we'll try to run the model with the different combinations of this, that is your PD value. Okay, now let's do one thing. Let's try to, I'll put a comment here. Okay, here. Okay, let's try to optimize the model by finding the best PDQ value, well, by best P and Q value. Okay, because D is already fixed now. Okay, Q value using ITER tool. Okay, let's find it. So what I'll do, very firstly I'll import ITER tools. So let's say import ITER tools. Okay, so ITER tool is basically, what exactly ITER tool is, I'll tell you that also, guys. Okay, basically the role of ITER tool is get the various combination, get the various range and create the combination. Okay, let's say, okay, what is the role of ITER tool, guys? I'll tell you first thing, guys. Let's say I'm saying you to any one of you, let's say I'm saying you to Imran, that Imran, I'm giving you the range, let's say 1, 2, 3, 4. Okay, and then I'm saying, let's say 1 and 2, and let's say 1, 2 and 3. Okay, let's say I have given you these 3 lists. Okay, this is for P, this is for D, this is for Q. Let's say if I'm saying, right? Now what I'm saying you, Imran, and to all, anyone, okay, I'm saying that give me the various combination that can possible for PDQ among the given ranges. Okay, so what Imran will do, maybe he can give 1, 2, 3, correct? It can be also combination, other combination 2, 1, 2, right? Other combination 1, 1, 1, right? So whatever the various combinations will be there within these ranges, that is what my Imran will do. Okay, that's basically your ITER tool will do. What I'm explaining the working of ITER tool, guys. So what ITER tool do, it form the various combination for the given ranges basically. Okay, so what I'll do here, let's say P will be equals to, okay, the range of, let's say randomly I'm giving, okay, it's always suggested to give the minimum values, okay, to PDQ values, not to take much lags. Okay, so I'm randomly taking the range, let's say 1 to 8 randomly. Okay, like just like, you know, we know that in random forest also, when we're taking number of trees, there also we take, I guess, still 500 trees will be maximum, will be fine, 600 trees will be fine, or 1000 trees will be fine, right? So here also randomly I'm saying max to max 7 lakhs. Why I'm saying 7, guys? Everyone, I think everyone know that the upper range of upper value of range function is always exclusive. Yes, guys, I think everyone is aware of it. Whenever we use a range function 1 to 8, which means it will be giving the numbers between 1 to 7, right? Same thing we'll do here the D. Okay, now tell me one thing, guys. For the D, what range we have to give? Yes, what range we have to give? I only want that it should take only 1. Okay, 1 to 1. Okay, 0 to 1, but it will take 0 also, but we don't want to make it change itself, right? Okay, let's say someone is saying 0 to 1. Okay, so which means it will include 0, but it will not include 1. Okay, someone is saying 0 to 2, which means it will include 0, it will include 1 also, but I don't want 0 also to be included, isn't it? Because D is always a fixed, correct? Very good, guys, correct. Because since my D is fixed that it should be 1 only, so from 1 to 2, which means it will include only 1. It will not include 2 because 2 is the upper limit that will be always exclusive. Start from 1 and until 2, so 2 will not be included, which means it will take only 1 that over there. Okay, let's do for the Q now. Same thing I'll do for the Q, that is your range of 1 to 8. Yes, we can do like that also. Correct. If D equals to 1 also we can keep Chandra, but that will create issue with this ITER tool. That's the thing. So because ITER tool need a ranges basically. Okay, that's the thing. So if you directly write D equals to 1, that will not work. But if you write the range of 1, then it should work. So if you specifically want to do ITER tool, in that case D1 can't work basically. Okay, because it need a range. Now, so let's say what I'll do here now, I'll just do here my ITER tool dot product like this. Okay, and you know what I'll do, I'll write here create a list. Okay, let's say PDQ combinations equals to list. So whatever the result it will be giving me, right, I want to put it inside the list so that I can iterate a loop for that list. Okay, so what I'm doing, iter tool dot product PDQ to get the combination, and that combinations I'm converting into the list and I'm saving in the this PDQ list combination. Okay, once I run this and if I print this, here we can see, guys, just a second, let me see this list that we created, and here you can see, guys, can you see this, guys? What is the role of now iter tool now? What I was saying, everyone, various combination 111, 112, 113, 114, 115, 116, and so on till your 717, right? Yes, guys, got it. Okay, can someone tell me, just a mathematic question, okay, can someone tell me how many combinations it will return if we have 7 possibilities here, 7 possibilities here, and only 1 here? So yes, how many combinations we can get, guys? Any idea? Let's see. So length of PDQ combinations would be almost 49. Correct. Those who are saying 49, correct answer. So there are total 49 combinations that it has returned. Okay, 1 to 7 for the P, 1 to 7 for the Q, and for the D, can you see this, guys? Since we gave here D as 1 to 2, so D is remaining same, 1, 1, 1, 1, 1, and so on. Okay, Kanta, as I told you, no issues, Kanta, don't be sorry for that. So basically, as I told you, we can take more also, less also, but I have told you that I want a minimum number. See, it's basically just an idea. Okay, it's like don't want that much P and Q values also. Okay, it should be less. Okay, but it shouldn't be that much less that it's not showing much result, much better results or something. Okay, so just an average 7 to 8 range is more than enough, I can say. That's what I'm assuming, and I'm writing over here. Okay, in case if I did not find Kanta, if I did not find any better combination into this combination, okay, like 1 to 8, then I can increase it also. I can go to 9, 10 also. Okay, but what I'm assuming, I think from 1 to 8 between any of these combination, I might can get a better result. If I did not get, I can increase the range here and I can try with the various more combinations now. Okay, that's just an assumption that we will be getting an optimal value into this. Okay, fine. Now, if you want to take till 5 also, that's also work, that will also work. Okay, now here you can see, okay, let's say PDQ combination I'm taking. Okay, let's do one thing. Let's try with little smaller first. Shall we try with with 5 or 6, or shall we try with 8 only? Well, it's totally up to you. There is nothing like that. Okay, let's try with 8 only. As of now, let's continue. Okay, it's up to you, like what you want to take randomly. If it's not showing better results in that range, then you can increase the range. But anyways, let's start with 8 only. Okay, fine. So here I'm running with the various combination. Okay, now you know what I'll do. I will be implementing the ARIMA model, okay, with these various combinations, whatever the various combinations we have. Okay, so what I'll do here, I have one code here. Okay, let me just copy that reference code here a little bit. Okay, okay, here we have. See guys, so this is a code. Let me explain you guys what is this code will do. Okay, right now, also since I'm saying the best, I want the best model. Okay guys, I'm saying that I want the best model with the best PDQ combination, right? How would I get to know that? How would my machine know that it's the best combination? We can see that if it's overlapping, that's fine. Okay, but if I'm saying my machine to automate this thing and find out the best combination, what we can do? Yes guys, can we say RMSE? Can we calculate RMSE? Well, it's not only mandatory RMSE, MSE, MAE, whatever the error or I can say accuracy measures we have guys for regression model, right? So basically how machine will check that guys, okay, whether the actual value and predicted value are same or not, right? So yes, you can go with the best R2 score, best MSE or best RMSE, whichever you want to choose. Okay, so as of now in the given code, what I have choose RMSE, root mean square error. So wherever we have RMSE less, that will be best model. Yes everyone, indeed. Yes guys, tell me, wherever we have the least RMSE, what is RMSE? That is root mean square error. So the model with the least error would be the best error, correct? What is error here? The difference between actual and the predicted value. So the model with least RMSE would be the best one. So what I'm doing here, RMSE is a list that will be holding the RMSE of each implementation model. Okay, order will be something which order I'm taking. Okay, now see here what I'm doing. See, I'm creating a variable or iterator that will iterate the PDQ combinations. What is a PDQ combination, guys? Just now we calculated these basic combination. Okay, so I am running a model with 111 first, then 1112, 1113, 1114, and so on. So this PDQ will refer each combination over here in the loop. So this is the iterator. Can you see, guys? This PDQ is an iterator that will iterate through various combination. Now running the model, training data, in the order I'm passing that PDQ combination. Fine, this much is clear, I guess everyone. Yes guys, this much is clear, right? This is the previous code only what we did, but just we are doing with the loop, manually putting the combinations. We are iterating the combination, putting here PDQ. Again the same thing, fitting up the model.fit. Okay, predicting. How will predict that? Again that general code, guys. Can you see this, that general code again? Model.predict, and here you can see starting value. Okay, let's say length, ending value, length of 10 plus length of test, correct? So that I'm saving in some variable called as prediction. Okay, I'm saving it as a prediction. Okay, now here you can see, now error equals to, I'm calculating the error of that model, np dot square root of mean squared error. Okay, but one thing we have to do here, we need to import this error, right? So I'll do one thing from sklearn, I guess from we imported from sklearn, correct everyone? From sklearn dot metrics, I want to import the mean square error, right? So mean square error, if I perform sqrt square root of that, that will be root mean square error, that will be error. Okay, so what I'm doing, whatever order I'm choosing for the current model, that order I'm appending in the order list, and whatever error we came by that order, that I'm appending in the RMSE list. Yes guys, understanding my point? This much code? Yes guys, this much code is clear. What I did, since this PDQ is an iterator which will refer to the various combination of PDQs, now this code will run the model with various combination. Whatever order I was using, it will be appended in this order list. Whatever error I have in using that order, that will be appended in this RMSA list, right? So by the end of the code, we'll get two lists. First list will be the errors list, which will be holding errors, and other will be the combinations. With that combination, what error we got, like that. Okay, now what I'm doing is, whatever the list and this orders are there, I want it in the data frame format so that I can see it properly. Okay, so what I'm doing, results equals to pd.data frame, index will be order 1 and data will be RMSC, column name I want to give RMSC. That's it, nothing else, just a pandas data frame thing. Okay, small thing I need to change here, that spelling mistake it's PDQ combinations, right? Let me fix here, it's PDQ combinations, and rest is fine, I guess. Yeah, let's see. Okay, now you can see, now this model can take a little bit time because it's running the model 49 times, guys, right? It's running the model with 49 combinations 49 times and finding out the best one, right? In the meanwhile, I'll write the code here. Okay, let's see. You can see it's taking too much time here because there are 49 models are being running in the backend right now. Okay, little more time. Okay, okay, meanwhile, can you please help me understanding how it works in production? What should be the input from user to get response from trained model? Okay, yes, see, yeah, basically if you want to do the prediction, right? So yeah, basically, okay, start and end is nothing. Basically, it based on what data it have trained, okay, based on what data it has trained, accordingly it will predict the value. Basically, start and end are nothing, is the upcoming steps basically. Okay, if you see, that's basically what we are doing for the prediction, Saurabh. Okay, but I'll tell you that after this also, Saurabh, I'll tell you how we can forecast for future, since you are asking for. Okay, I'll tell you one thing, what these models take when I'm talking about the prediction, it does not take the data. Okay, it takes how many future forecastings you need. Okay, so since in the given code, okay, let's do one thing. Let me make understand everyone this thing, because it's not only Saurabh's doubt, I guess. Everyone might be having the same doubt. In the meanwhile, the code is running. Okay, now Saurabh is having very interesting question, guys. Listen everyone very carefully. So Saurabh said here, since we are predicting here the model, okay, we are giving here starting and ending value, correct? So in general, if we have to give inputs to the machine, how we can give it without do we have to every time mention this thing, or if we have to mention any new data for the prediction, how we'll pass that, right? Is that your question, Saurabh? Correct, I guess, if I'm not wrong. Okay, Saurabh. So since basically, guys, whenever I'm saying my model to predict, right, it does not predict for the given data. It predicts for the future points, basically, how many future points I have to predict. Okay. Now here, if I'm saying from 120 to 143, so which means how many predictions are there? 1224, right? So I'm just saying my machine to do the 24 predictions. That's it. Okay, so you will be able to understand this more properly, Saurabh, because right now here it's training. Okay, so that's why we are getting confused. I'll show you when we are doing the forecasting. Okay, this is just a prediction of whatever already happened. If I'm doing with the future, that is something what user will be inputting always, correct? If I'm having a machine, I will be always asking for future, right? So in that case, what I have to do, Saurabh, I have to just give that count basically. Let's say this is monthly data, right? So there is something called as steps parameter. Okay, we have to tell that how many steps. So let's say I'm saying for the next 10 months. So I'll say step 10. So I only have to give this much. That's it. Not a separate training testing data. Just for the input, user will be giving step 10. That's it. So my machine will be creating the further 10 steps for the prediction basically. Okay, Saurabh, is that clear? So basically, it's not passing the data or something. It's basically the points, that how many points I need the predictions basically. Here also, since I'm passing starting and ending, I guess we can pass the steps also here. Let me just check whether the predict parameter can pass the steps or not. In forecasting, the we can pass, but let me see. Do we have steps or not here? Okay, no, sure. I guess it does not have that steps one. Here we have to tell in the starting and ending only, like how many points you want, start here and end here. But when I'll show you the forecasting function, there I just need to tell that how many upcoming steps I need to forecast. That's it. Okay, they should not be passed the data. Okay. Okay, I'll show you in the forecasting, Saurabh. Okay, just wait for that thing. Well, we'll finish this Sarima model also. I'll choose the best model, and there I'll show the forecasting also, how it can be done for the future. Okay, so pickle the trained model, create API, expose it to user while hitting the endpoints. Exactly. So user will be only hitting the endpoints where, if you see, if you want to do, either you can do it like this way, starting and end, or you directly give that steps. There will be steps parameter to forecast, where user will be only giving that steps, how many steps he want to predict for future. That's it. Okay, I'll show you that here. Yeah. Okay, so let's see here. So we saw that the best combination came out to be, okay, this process is done. Let's see the result. So result I've stored in the data frame format, guys. Okay, let's see the result here. Okay, so can we see here for the various combination, guys, can you see this everyone? For the various combination, I'm having the respective RMSE. If 111 is there, this is RMSE. If 112 is there, this is RMSE, right? So shall we do one thing, guys? How can I get the best one out of it? Yes, guys, you will be testing me. This is a data frame having each combination respective RMSE. Shall we do correct? Shall we do sorting and find out the minimum? Correct. So let's do one thing, results dot sort values. Okay, or find the minimum, it's up to you. Okay, whichever function you want to use. I'm sorting the values, sort values, and ascending should be eventually true by RMSE. Okay, and ascending by default is true only, so it's in ascending order. Okay, because I know I need the minimum one. Okay, I need the minimum one. Let's run it here. Okay, after running this scenario, okay, what we'll get to know that, okay, after running this scenario, we'll get to know that the best combination came out to be 514, guys, here. That is having the minimum RMSE, that is 0.14. Okay, which one is the best combination, guys? Can we see? 514. Okay, second highest is 717. So 514 is the best combination came out to till now. Okay, so let's do one thing. Let's run this model. Okay, now again with this parameter. Okay, so what I'll do, guys, whatever combination I did, this thing I did earlier. Okay, this one. I'll copy the cells again. Okay, just a second. Let me cut this one part. Okay, because here though we are not taking randomly. Here we just see from Arima Sarima. Sorry, from ACF PCF. Okay, so I'll copy this data where I'm fitting the model again, and I will be choosing the best parameter out of it. Okay, I'll copy the cells, and here you can see. I think now I can expect much better results. Okay, but if not, maybe we have to go for other alternatives. See, if I'm running this, okay, fine. Again, my mistake. I need to make it to best parameter. What was the best parameter, guys? Yes, what was the best combination we found from the above data? Correct, 514. Correct. So let's fill up here the 514. 4. Since 5, 1, 4 give the best RMSE, go with the that. Okay, so 514, running up the model with these RMSEs, running it and running it again and running it again. Okay, now tell me one thing, guys, isn't the result is more better than the previous case now? It's not exactly perfect till now, but can we say it's much better than the previous one? Let's say if I open the previous graph also with you guys. Okay, I'll open the previous graph here. This is the previous graph. Okay. See.
Just a quick info, guys. Intellipaat offers data analytics course training. Through this course, you will master Power BI, data wrangling, data mining, and much more from the IIT Roorkee faculty and industry experts. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take the first step towards career growth in the field of data analytics.
Previous graph we have, okay, and this is the new graph. Little bit improvement I can see. Yes, everyone? Correct? Little bit improvement is there. Correct? Now, definitely here, now being an analyst or being a data scientist, now what will be my observation here? Two observations I can do here, guys. One is I can see that even after choosing the best combination, okay, still there are chances of improvement. Okay, now the two reasons I can say, maybe I need to improve the ranges, right? Maybe I can take more than 8 range. I think then it can give the better results, right? So I can try that option first. Okay, but what if I'm saying, okay, Can you see, guys? Actually, the problem, what problem was happening over here? It is showing the ups and down, okay, but the proper seasonal pattern is not gonna be proper copied. Can you see this, guys? Everyone? What I mean to say here is, in the graph, it is showing the up, down, right? But this seasonal patterns, okay, these patterns, can you see this? That it is not able to recognize. Yeah, everyone? It's showing that, okay, here it's going up. See, here it's going up, but it's not showing like it's going up like this. Correct? So what does it mean? Can we say, guys, don't you think so? Okay, now the twisting point over here, that since we are working on ARIMA model, guys, which is not that much good with the seasonality, and our data is actually having seasonality, isn't it? Yes, guys, tell me one thing. Our data is having a seasonality, correct? The repetitive patterns, right? But my ARIMA model is not that much good with the seasonal patterns, isn't it? While handling seasonal patterns, ARIMA models lag somewhere. Correct? So shall we do one thing? Shall we try the same parameter, whatever parameter we have chosen, okay, 514, with the same parameter, shall we try with the Sarima model? That what Sarima model can do with this, with the same number of lags what we have given here, PDQ values, correct? Because I can feel that PDQ, there is no issue with the PDQ value now, right now, because it's not able to copy and read the seasonal patterns properly, right? So let's do one thing, okay, to make it more interesting, let's run the Sarima model now. Okay, we'll work on the Sarima model. Okay, so what I'm doing, guys, so yeah, what I'm saying, let's say, since Arima model is not able to capture the seasonal patterns, let's try the Sarima model. Okay, I want to try the Sarima model. So how would I import it? So let's say from stats.tsa state space dot serimax, I want to import the serimax. Okay, one thing I've told you, if you remember, guys, serima model and serimax model, okay, two different approach, no, not a different approach. Basically, usually it's a serima model only. If we give the x variable, exogenous variable, that's serimax. Okay, but importing will be same. While we are using serima or serimax, it will be same only. Okay, so if we give exogenous variable, it's up to, or I can say indirectly, if I can say directly, that the implementation of x is optional, whether we want to use it or not. If we are not using it, it's Sarima model. If we are using it, it's Sarimax model, like that. Okay, so running the Sarimax model. Okay, now here you can see, I'll create an object for that. Let's say Sarimax model. Okay, this is my Sarimax model. So here I'll run it. Okay, now here again, I need to pass the train data, and or have to give the order. What was the order, guys? I'll pass the same order. But you know what, guys? One thing, you can still find the best model for the Serimax also. But I'm just giving that Arima's best model. Okay, let's try with that. So 5,4. Okay, sorry, 514, I guess, right, everyone? 514. Yeah. Okay. Now, one more thing we need to pass here, guys, in this Sarima model. What is that? Seasonal order. Remember, I've told you, Serimax is able to handle the seasonality, which means it can handle the seasonality, right? But we have to tell the seasonal pattern also. Get my point? We have to tell the seasonal pattern to my machine also that this is a seasonal pattern. Okay, what seasonal pattern would be? Let's say I'll write here seasonal order. Null order. So seasonal order will be, let's say, okay. So what I'll give in the seasonal order, guys? In this seasonal order, first value, what does we give this seasonal order, guys? Here, I'll just comment here. Seasonal order. Okay, so seasonal order would be something P, D, Q, S, where P, D, Q, so we already know that S is a seasonal component. So P is, what was a P? P was a 5, D was 1, Q was 4, and what is the S now? So S is basically seasonality. So what is the seasonality, guys, in the data? Everyone? After how many lags or after how many units my data is changing, repeating the same pattern? No, not one, guys. Okay, I'll tell you, I'll come with the seasonality again, guys. See here. Let's go to the top part again. Okay, here you can see where I'm visualizing the data. Yeah, can you see this now, everyone? So since here, if you see, So here you can see this is the 1951. Okay, 1950, sorry, 1949, 50, 51, 52, 53, 54, 55, 56 every year, right? Now, can you see there is a same pattern that is repeating next year also? Every year you can see from just like this, you can see from 1956 to 1957, what pattern we have? This pattern, like this, right? Can you see that same pattern is repeating from 1957 to 58 also? That is this, right? And same pattern is repeating in the next year also. So basically every year basically, Neelam, not next 2 year, every year can you see that the pattern is changing, right? So which means every year you can say this is 1 year. Each this cones, or I can say curves, are years, correct? So in every year it's changing now. But since we have a monthly data, isn't it? Since we have a monthly data, so that is representing each month, correct? So which means, can I say the patterns are repeating like this from 1 2 3 4 5 6 7 8 9 10 11 12. Okay, so till 12 it is showing one pattern, and then again till next 12 month again it will show next pattern. Next 12 months, so basically 1 2 3 4 January, February, March, April, May, June, July, August, September, December, again the January, February, March, April, May, June, July. Okay, so which means within the 12 steps, after every 12 steps the pattern is repeating again and again, right? So that is what the seasonal pattern, guys. Okay, so here we have to give the seasonal order. What will be seasonal order, guys? Since in every year the data is changing and we have 12 months in a year, right? So with respect to 12 units, 12 steps, the data is changing, which means seasonality is 12 here, guys. What is seasonality, everyone? Seasonality is 12. Got it? Understood, everyone? Okay. Now let's do one thing. Okay, let's put the value here 12, that the seasonal order is 12. That's it. Run this model, fit this model. Again, I'm gonna make dot fit. Okay, and let's say doing like this. Okay, I'll do the same thing. Okay, I'll do the prediction. So let's say my log df, I'll make here the prediction name is, let's say, Serimax prediction. Okay, new column I'm creating in the actual data frame, log df itself, Serimax prediction. That should be equals to Serimax model dot predict. Okay, the same thing. What I want to do, start, end, length, and that's it. Okay, if I do this, we have passed order 514. Why we are passing again in the seasonal order? Yes, that's eventually syntax Shampa. We have to pass it. Like when we are passing the normal order, that's a order, and this while passing seasonal order, we have to give PDQ plus the seasonality. That's a syntax. Okay. Okay, so here you can see I'm okay. Still the model is getting fitted. Okay, so it's taking a little time. Okay, let's wait because it is now reading the proper seasonal patterns properly, as well as to make prediction. It will take some time. Okay, now let's see. Let's see this log df. Okay, yeah. Can you see here now, guys? So here Arima predictions were 6 1 point something. Okay, now see, guys, can you see the difference here itself? Okay, Arima prediction is 6109, whereas Sarima prediction is 6.3, and actual value is 6.4. Which one is more closer to original value? This is original, this is Arima, this is Sarima. So can I say that Sarima is more closer, right? Let's go with the last value, 6.096, right? Here we have 5.8, here we have 5.9. So Sarimax values are more closer to the this original value. Okay, so I'll do one thing. I'll create a plot for that. So let's say this data dot plot. If I do, now see, guys, see, so if I create a plot here, these orange ones are the prediction of Serimax, whereas sorry, orange one is a prediction of Arima, the green one is a prediction of Serimax. Okay, well, let's do one thing. It seems little clumsy. Okay, so I'll just do one thing. I'll not take Arima prediction, I'll only take Serimax prediction. Okay, so let's say I'll do one thing. I'll predict it only for Serimax prediction and the actual data, that is your passengers. Okay, Okay, fine. Yes, tell me guys. Isn't this now much better prediction? No, Suman, that will not affect. That's actually the column name itself. Yeah. Isn't this a much better forecasting, guys? Prediction? Isn't it? Let me copy and open it in a new image. Yeah. Here you can see. So this was a prediction of okay. Just a second. Let me go with Arima's prediction. Yes. See, this was a prediction of Arima with the best parameter, and this is a prediction of Sarimax with the best parameter. So can you see this, guys? Whatever the shortcoming we were having in the Arima, that it could not get that proper seasonal pattern. Exactly that seasonal pattern is gonna be read by properly with your Sarimax. Can you see this, guys? Sarima is also copying that seasonal pattern also. Yes, isn't it? Yes, Chandra, I'll come to that. Chandra, we have already evaluated this, right? Isn't it? Remember, I've told you to for the evaluation, we'll choose RMSC. Yes, correct. So we found out that here we have the minimum RMSC. Yes, guys. Can we see this, guys? Don't you think so? Now the forecasting prediction is much better as compared to Arima. Arima was having this prediction. Sarima is having this prediction. Correct? Definitely a good prediction, right? Now just think little bit. It can be further more improved. How, guys? How it can be improved? Remember, I have chosen the best optimal value of PDQ for Arima. What if I choose that for Sarimax? Right? That will be more interesting. So that I want you guys to do that. Okay, so basically see that when I'm choosing the optimal value of PDQ, can you see this is the various combinations we have, right? So here, can you see, guys, we have checked this PDQ best PDQ value for the Arima models. These are better, but for the Arima. And you can see even it's for Sarima, it's showing very good result. What if here we try with the Sarimax? Correct? What if we try this with the Sarimax? Which see, let's say, I'll just show you here. If I do this, okay, you just need to do the Sarimax here. That's it. Instead of Arima, just Sarimax like this. That's it. And you'll get the best parameter for Sarimax, which one is better. And you can get even more better forecasting for this. Okay, so it will take time, so I'm not doing it right now. Okay, because you guys can try it. Okay, getting my point, everyone? Clear this much? Okay, here we took the optimal values for initial range 1 to 8 PD. How do we judge the range what it doesn't get optimal over? See, that's what I'm saying, Neelam. If I'm getting a proper overlapping, better overlapping, I can say that that's optimal. We don't need to increase it. Okay, but if we are not getting a better, just like this, correct? Eventually we need to exceed the range also, like that. Okay, so we have to get an idea out of it. If the overlapping is better or RMS is less, which means yes, that's a good optimal value. If it is not, we try to exceed the range, then we have to try to exceed the range and try with those combination also. So I want you guys to do this. Okay, I'll put a comment here. That's your homework basically. Okay, so homework is find the best parameter for Serimax. Okay, best combination I can say of PDQ okay for Serimax for better results. That's it. Okay, so this is something what your homework would be. Using this code you can do it. Okay, now let's do one thing. As of now, let's say if I'm assuming okay that this is the best model that I have, because this is till now whatever we have performed, this is the best, having the best accuracy. Now what I want, let's say this is the best model and here we have the model. Now someone who was asking me like how user will be giving the inputs, so inputs will be for the future forecasting. So here I can do now. Okay, so let's say this is the forecasting part now. So I'm gonna do the forecasting for future. How can I forecast it for the future, guys? Now okay, now how does the forecasting for future will work? This is my model, right? This is the best model. I'll put a comment, best model, just suppose. Okay, now I'll do one thing. This model dot forecast, we have a function called as dot forecast. Now here I was saying, guys, I think someone was asking me here, I would be saying here the forecast value we have to give steps. Okay, what do you have to give? Steps. So forecast steps equals to, let's say, how many values you want. Okay, so tell me one thing, for how many months you want me to forecast? It's up to you. Okay, now it shouldn't be 24, it's up to you. Well, okay, let's say I have the yearly data. I'm not saying we have to forecast from for this actual value only. I'm saying about the future now. We have data till 1960, I guess, right? We have data till 1960. I want to forecast beyond 1960. Okay, so shall we forecast it for upcoming 3 years? Yes, everyone. 61, 62, 63. Yes, guys. Shall we forecast for next 3 years? Right? Let's say randomly. 5 years also we can take, 10 years also. Okay, for 3 years, how many months? Everyone, how many months will be there in the 3 years? Correct, 36 months. So which means if I'm having data in months, so I'm saying how many further steps I need, which means how many next 36 steps I need, 36 months I need to get the forecasting for 3 years. So I'll pass here steps equals to 36. That's it. So if I do this, okay, and I'll do one thing. That's basically your future. Okay, it will take a little bit time. Let's see. Okay, so execution completed. Okay, so now you can see this is what my execution is. Let me save it somewhere. Okay. Just a second. Yeah. Okay, fine. So can you see this is the future is being saved here? Okay, so this is a future prediction now. So for future prediction, you can see starting where it's starting from 1959 only. Okay, from 59 and so on. Next future. Okay, now I'll tell you that reason also why actually it started from 1959 also. See, now this is a future. Now what I'll do here, let's say, okay, plt dot plot. What I want to plot, let's say my this df of passengers, right? I think I was having passengers as a column name. The passengers, and I want plt dot plot the future. I want to plot the future. Plt dot show. See now, this is the future forecasting now, guys. Just a second. Sorry, not df, log df, because it's a logarithmic value, right? Log df. Yeah, can we see this, guys, now? So this is the future also. Beyond this blue line also it's showing. Okay, now I'll tell you something. Okay, now you might be getting confused here now. I was expecting for the upcoming future, while still I have some values overlapped and some predicted, right? Isn't it, guys? Yes, isn't it? Correct, Shampa. Why? Because I have told my model to make next next 36 steps. Okay. Now, but model have learned only till 120th rows, right? The model have learned only till 120th rows, right? So basically, it's saying that okay, I'm forecasting for the next test step also, basically. Okay, getting my point, guys? Basically, what it is happening. So it's basically like this. Let me take with the pen. Yes. So this is the data I have. In this data, let's say I have value till 1, 2, 3, 4, 5, 6. Let's say model have learned till 6, 7, 8, 9, 10. Till 10 were the actual data. Okay. Till 10, I was having the actual data. I was training my machine. I have trained my machine till 6 only. Okay. Till 6 units I have trained my machine. Now I am saying predict for the next 10 predictions, which means including previous 4, that is training, testing, as well as the future also, like that. Okay, if you want for the more predictions, okay, like that you can do. Let's say I want 60 means next 5 years. Okay, let's see. And yeah, can you see this, guys? So this is the forecasting for the next 5 years. All right, yes, guys, is that clear now to all, everyone, the concept of this Arima Serimax model? Arima and Sarima? Yes, guys. How do we do the inputs also? Like whatever you have learned, accordingly, how many further future steps I want to know. The user will only enter that further future steps for the prediction. Okay, clear, guys? Okay, how frequently we need to retrain model? I guess faster we retrain the model, it's in time series, we get more accurate next steps forecasting. Faster is not, it's not like our faster, it's like about how better results. If we want a better accuracies, there should be a data where we have a better relation between the previous, because it's all predicting based on the previous results itself, right? The previous historical data. So if that is much better correlation is having, yes, further will be also accurate, like that. Okay, but actually, yeah, one thing, if you're going with very much far forecasting, maybe that much forecasting is not that much accurate, guys. Okay, one thing, because eventually, let's say if I'm saying, guys, tell me the weather of next 10 days, right? So you might have seen that the I can say the forecasting of tomorrow is somehow very much closer, right? The weather. But the forecasting of 10th day is not that much closer, isn't it, everyone? I think everyone know that. When we are looking for weather forecasting report, if we are having the report of 10 days, next 10 days, the tomorrow's and day after tomorrow's report is going to be very much close and accurate, but the 10 days later report is not that much accurate. Okay, so it's like how far you are moving in future, that much accuracy will be not there in the future, guys. Okay, understood? So you should always go with the not that much far, it's like this much forecasting only. Okay, it's not like what model have learned for from five years data and you are making the forecasting of next 15 years, right? So it shouldn't be like that. That's the thing.
Just a quick info, guys. Intellipaat offers data analytics course training. Through this course, you will master Power BI, data wrangling, data mining, and much more from the IIT Roorkee faculty and industry experts. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take the first step towards career growth in the field of data analytics.
Great! Now that you have completed these hands-on projects, you've applied key data analytics concepts to real-world scenarios. But knowing the skills is just one part. Acing the interview is the next big step. So let's get you prepared for some important interview questions to help you land your dream role. The next section is designed for just that. So let's get started.
Coming to the first question on these top data analysis interview questions, it is what are the key differences between data analysis and data mining? Well, data analysis involves the procedure of actually cleaning the data, organizing the data, first procuring it before doing all of these, and of course at the end of it driving meaningful insights out of it. But data mining is a very different concept, because in data mining we are very much concerned about finding patterns in the data, finding hidden patterns, and to see how better we can use these hidden patterns to drive insights. Well, data analysis can also be compared to data mining up to one certain extent, but then the procedures that goes into working of data mining is pretty different. Now, data analysis is actually used to produce results which will have a larger impact on the audience, let's say in general, when you directly compare it to data mining. So these two, form to be very vital differences that lie in between data analysis and data mining. Coming to question number 2, it says, what is data validation? Well, data validation is the actual process where we try to see if the data is valid or not, as simple as that. It's not just that, when we're thinking about data and its accuracy, we want to find out if the data is actually accurate and if the data is actually of a high quality as well. First, see if it's coming from a valid source. Second, see how accurate it is. Third, see what the quality of the data is. So to go on to do these, there are multiple processes where, we use to actually go on to perform data validation. Two of the very important processes are data screening and data verification. Data screening involves making use of a lot of models to make sure that our data can be verified in a way that it is accurate, and to make sure that there are no redundancies, no repeatances, or nothing in the data that will harm the models, let's say. And then we have data verification. What happens in data verification is that, if let's say there is a scenario of redundancy, now if there is a redundancy, what we try to do is we try to see if we can evaluate using multiple steps and to see if the presence or the absence of that particular item in the entire data set is required or not. If it's required, we keep it. If it's not required, it gets removed, as simple as that. So first, screening the data and then, performing data validations are a couple of processes that have a huge impact in data validation. Coming to question number 3, it states, what is data analysis in brief? Well, it says in brief, so make sure you do not get carried away with your answer. Data analysis is actually a very structured process where we work with data continuously to perform activities such as data ingestion, data pre-processing, data cleaning, data transformation, data visualization, and eventually we drive insights out of these analytics result or the visualizations themselves. So why is this done? We do it to make sure we can drive revenue or analyze any of the key performance indications of a business. So to begin with, data is collected from multiple sources, right? It can be an on-site server, it can be an off-premise server, a cloud storage network, or wherever it is. Once the data source is grabbed, we have to make sure that we bring in the data into the company architecture. And once this is done, we'll understand that the data is a raw entity, so it needs to be cleaned, it needs to be processed. If there's any missing values, it has to be filled. If there's any entities that's repeating, or if it is out of scope, we need to remove it. So after pre-processing, what we'll do is we'll use a couple of models to drive analytics out of it, to see that we can create very good reports, and to make sure that the data output is converted to a format which is understandable by a technical audience and an equivalent non-technical audience as well. Because at the end of the day, a data analysis result can be viewed mostly by board members, stakeholders, and you will basically be explaining this to a non-technical audience. So in that particular case, all of these steps are paramount. Coming to question number 4, it states, how do you know if a data model is performing well or not? Well, this question is very subjective, as you can already tell, because there are many things that involves to check if a data model is performing very well or not. So to find out and assess the accuracy of a data model, we can use a couple of steps. The thing we can do is, a very good design model, as you might already know, will give you very good predictability, right? So you can understand if this is the input, that can be the output, and it will keep doing that on a basis where it will offer you good predictability. That is one. Second thing is that a good model will make sure that no matter what changes you make to the data or what changes you make to the pipeline, the results can be obtained without having to make major changes in the model itself. That is what defines a good model. And then of course, your model needs to have the ability to scale against data in a way where, with one requirement, you might be working with a small amount of data. You might have another requirement where you're working with a huge amount of data as well. So your model needs to cope up. That's point number 3. Point number 4, when you're talking about this, is to make sure that your model's working itself should be easy, right? If it's complicated for you as a data analyst to use, it literally wouldn't make sense to spend a lot of time and effort into it. So having it easily understood among clients and in fact, data analysts equally will make sure that both the requirement specification from the client and the performance of the data analyst working with the model will be as high as possible to get the results. So these are some of the points that you have to keep in mind to check if a data model is performing well or not. Coming to question number 5, it says, explain data cleaning in brief. One thing you have to know about this question is that it can also be stated as explain data wrangling in brief. So because data cleaning is also called as data wrangling, and as the name suggests, whenever we talk about data cleaning, we try to find ways where we can clean the data, take it from its raw entity into usable information, right? Our end goal is to basically have data with the utmost quality possible. So how do we do it? First, we'll try to see if we can clean the data by removing all the stuff we do not require, right? We call it outliers, but then to remove it, we need to understand what do we need to remove. Do we need to remove one particular row, one column? Do you need to remove the entire data block, or what? The second thing is, it's not just about removal, it's about adding certain stuff back in as well. So we can fill certain data in without having to cause any other redundancies or to obstruct anything else in model performance as well. So we remove the data, we can add the data, and in fact we replace the data with mean or median values as well. Again, this is a very important statistical concept that we'll be discussing in the next couple of questions. But then yes, you can replace existing data with the mean or median values of the data itself, and that in fact makes models very much accurate in a couple of cases. And the last thing is that we'll make use of concepts called as placeholders, which are used for all the empty spaces in the data too. So these are some of the 4 very important steps or procedure that's involved in data cleaning. So after understanding data cleaning, here's question number 6. What are some of the problems that a working data analyst might encounter? Well, there are many issues that a data analyst might face when you're working with data, right? Because data itself is an ocean. So working with the ocean is not easy. So the one very important thing we talk about this is the accuracy of the model, right? If there are any issues that causes the biggest problem is going to be the accuracy in model development, and if it is low, it will cause a lot of errors, a lot of mistakes, where at the end of the day performance will fall. The second thing is that the source of the data, if it is not a verified source, it means that your data will be very raw and very shabby. This means that it will require a lot of cleaning, a lot of pre-processing even before the analysis has begun. This will take a lot of time and effort as well. And the third thing is, whenever you're extracting data from multiple sources, or let's say, you are merging data from multiple sources, right? So this will cause again a lot of redundancies with respect to data, and it is very, very vital that these redundancies are taken care of. So when you're thinking about all these steps, right, it is very vital they go hand in hand, because if you miss one of these steps with data ingestion or data cleaning, the rest of your model will come tumbling down. So these are some of the major problems that the data analysts face in a production environment. Moving on to question number 7, it states, what is data profiling? Well, data profiling, as the name suggests, is a methodology that we make use of to make sure that we have the right steps in place to analyze all of the entries that are present in our data. So it's not just taking a quick overview of what data is present, but rather taking an in-depth look. So what we're trying to do with data profiling is to make sure that we have the ability to see the data in a very high accuracy way, and to make sure that we understand the data better, right? So what are the data types of the data that is present? What's the frequency of occurrence? And a lot of other things as well. So when you're thinking about all of this, it's very, very important that we profile the data. So with this, we can check out question number 8. Question number 8 asks, what are the scenarios that could cause a model to be retrained? One very important thing about data that you have to know is that data is never a stagnant entity, right? Data keeps changing as business changes. So whenever there's an expansion in the business, it means that, there's a day and night difference in the data that the company starts seeing. So what this does is a huge challenge to data analysts, because here we have to analyze if the model itself needs to be retrained or not to work with the new data. If yes, then yes, the model will be retrained, the new data will be shown, the model will be trained, business protocols will be changing, whatever the model sees will change, and of course the output can change drastically as well. So considering all of this, we have one general rule of thumb that we make sure is that whenever we have the models that are retrained, right, we try to align it as much as possible to the new business protocols and whatever is being offered as well. So this, and it is very vital to understand the scenarios that happen to cause a model to be retrained as well. Coming to question number 9, it states, what are the prerequisites to become a data analyst? Well, there are many skills that's actually required to be a data analyst, and I'm sure you guys will know most of these skills if you're here at this video, right? So you'll require programming skills such as JavaScript, ETL, and XML. You need high proficiency with working with databases, especially like MySQL, MongoDB, Oracle SQL, and more. And you need to have the ability, the passion, and the interest to collect and eventually analyze data. You will need to figure out how to design databases on your own and how to perform data wrangling and data mining as well. And once you know how you can go about working with data, what comes next is you having the ability or the experience itself to work with a large amount of data sets in a production environment. This is very, very, very important, and all of these skills are the major prerequisites, let's say, for you guys to become budding data analysts. Well, coming to question number 10, it states, what are the top tools used to perform data analysis? Well, as you might already know, there is multiple tools that can be used in the field of data analysis, right? But then there are really popular ones that get a lot of attention. And these are, Google search operators, also called as GSO. We have RapidMiner, we have Tableau, we have Kineem, we have OpenRefine. We have a lot of these other tools which take the center stage as in when we talk about data analysis. So it's very important that you know these tools. Question number 11. It says, what is an outlier? Well, an outlier is basically a value in a data set that we consider to be very much away from the mean of the data, because in two ways it will hurt the data, because an outlier can cause model accuracy to fall a lot, and of course at the end of the day, if it's outside whatever we call the normal zone or the useful zone in the data or the inliers, right, what it does is it is redundant, right? So when you're thinking about small amounts of data, it's probably okay, but then when you have large data sets, if it can swing the model accuracy around, big no. The second thing is storage as well. Storage is not really cheap, and when you're thinking about all of these, it's very vital to know what outlier is and how to remove them as well. But then there are two types of outliers you have to know about. One is univariate outliers and then multivariate outliers, and they speak, the names speak for themselves as well, right? Well, so moving on to question number 12, it states, how can we deal with problems that arise when the data flows in from a variety of sources? Well, when your data is coming from a variety of sources, it will come with a variety of problems because data is really shabby, as we've been discussing, and it is very important to handle these as well. So to go on to solve these problems, what we try to do is we try to see if the data is same or if the data is similar. which might cause redundancy. And if it is similar, of course, we can merge it into a single record and reduce the redundancy. We can restructure the entire schema where we are trying to make sure there's good schema integration with the data. And at the end of it, no matter how much cleaning you do, no matter how much pre-processing you do, and how much time you take to do all of these, there will be an entry in a large data set, or there'll be a couple of entries, in fact, that will be hurting model accuracy if you're not careful. So these are some of the problems that arise and how we can deal with them as well. Coming to question number 13, it says, what are some of the popular tools that are used in big data? There's many tools in big data, and again there are some of these tools which come to the back of the head as soon as we think about big data. So a couple of these tools are Hadoop, we have Spark, we have Scala, we have Hive, we have Flume, Mahout, and as you can see, there's a pattern that exists, right? All of these tools are by Apache. Apache is an open source foundation, and they've been contributing a lot to the world of big data. And it is very important that either you have the experience using these tools or you know what each of these tools do as well. That brings us to the 14th question that states, what is the use of a pivot table? Pivot table, as you might know, as you might have heard it or used it, is one of the most important concepts that exists, in fact, in Microsoft Excel, in my opinion. Because they will give you a very easy to use way where you can view and summarize large data sets without having to put much effort into them. So, most of the operations that we do with pivot tables actually are drag and drop operations, and it really does not require any sort of coding or any sort of programming, or really any sort of, let's say a hard amount of effort is not required to create reports and to make them look beautiful itself as well. So in all of these usages, pivot tables are very important, and I'm sure if you're at this video, you guys might have used pivot tables yourselves as well. So coming to question number 15, it states, explain the KNN imputation method in brief. KNN is K nearest neighbors, and it's one of the most important methods that we use to see how we can pick up the nearest neighbors in a nodal arrangement and to see how we can measure the distance metric between each as well. So what we're trying to do here with a KNN imputation is that we try to predict both discrete and continuous attributes that happen to be present in a data set. With this, how can we do it? Well, a distance function is exactly what we use here to find if two data, two nodes or two neighbors are similar or not. If there are similars in more than one attribute, then we're going to use that to perform analysis as well. So to go on to do this in a very structured way, we use a method, and that method itself is called as the KNN imputation method. Moving on to question number 16, it says, what are the top Apache frameworks used in a distributed computing environment, right? So we're living in a world of distributed computing where we can make use of the computing power offered by thousands, if not millions of computers across the globe at a time, right? So when you're sitting with that kind of a power, there are two tools which always come to center stage. This is MapReduce and Hadoop, because these are the top Apache frameworks which are in the limelight, which can handle large amounts of data set very easily. And if it's in a distributed working environment, there are a very less number of tools that get to outshine what MapReduce and Hadoop does. So these are the top Apache frameworks. Coming to question number 17, it states, what is hierarchical clustering? Hierarchical clustering can be, this question can be asked to you in another way. What is HCA? HCA is basically hierarchical cluster analysis, or it can be called as hierarchical clustering as well. So it's basically an algorithm that we use to make sure we can find the easiest ways where we can group similar objects. So once we group this similar object, each group itself will be called as the cluster, and hence the name. So why do we require hierarchical clustering? Well, we require hierarchical clustering because we need to create a set of clusters to show that this data differs from another cluster itself, be it individually, be it cluster wise, or even if they consist of similar entities as well. So to show the difference that exists in between data, we make use of hierarchical clustering. Moving to question number 18, it says, what are the steps that are involved when working with a data analysis project? Well, again, this question can be answered in multiple ways, but then the foundational concept is the same. So, there are many steps that are involved when you're working on an end-to-end project, especially in the world of data analysis. You'll begin by finding out there is a problem existing, or you'll have a client bring you a problem statement. Once you understand the problem, you'll source the data. Once you get the data, you'll clean it, you'll pre-process it, and you'll explore it to see what the data actually is. Once you understand the data, you'll start creating data models, and you'll create situations where you'll use the data on a smaller scale to see if you can solve a problem in a simple way. Once you do that, you'll validate it across a bigger data set to see if it works. on the complete data set. If it does, you implement it. But then it's not just done with the implementation aspect of it. Once you implement it, you need to verify if you have solved the problem or not. And that is the last important step. So based on how much the interviewer is asking you to stress on the answer, make sure to expand on it. Keep it concise. Don't get lost in each of these steps, because I can talk about each of these steps for 20 minutes right now, but then it really wouldn't add a lot of value in an interview scenario, right? So read the room, read the interviewer, understand what he or she is expecting, and deliver the answer in that way. So with this, we come to the 19th question that states, can you name some of the statistical methodologies used by data analysts? Well, again, you can name a lot of methodologies used by data analysts, but try to keep your answer concise, right? So name 4 or maximum 5, in my opinion. That should be very useful. See, we have Markov process, we have cluster analysis, we have imputation method, we have imputation technologies, we have the Bayesian methodologies, we have rank statistics, and we have a lot of other statistical techniques that are very, very useful. In fact, I can say they are foundational in many cases when you're working in the case of data analysis as well. So for all of these techniques that exist, each of these have their own niche purposes, and they're very effective at doing what they state. So when you ask this question, make sure to mention this. Coming to the next question, which is the 20th question, it states, what is time series analysis, or also called as TSA for short? Well, time series analysis is used to perform, trend analytics. We try to see how the data changes with respect to time. And it's not just how the data changes with time. Here, what we're trying to analyze is for a fact that the presence of data at particular intervals of time, and seeing the presence of data and its response and its behavior of how actually it drives the data set. So if you have a data that does this at this point of time, and you want to understand why it does that, or you want to understand what it does because of it changing its state or changing its data at that particular point in time, then TSA is very, very effective to use. So moving on to the 21st question, it's actually a follow-up to the 20th question. It states, where is TSA used, right? So TSA has a lot of usage when you think about it in a lot of different domains. So make sure to at least mention 3 or 4, but then I have given you more out here so that it'll help you remember, right? So TSA is used in statistics, in the field of signal processing, econometrics, weather forecasting, earthquake prediction, astronomy, and even applied sciences as well. There's a very good chance the interviewer will not ask you how it is used, but probably give you a situation and ask you to think about it and tell if you can provide a solution there as well. But then these are some of the most important places where time series analysis adds a lot of value. So when you ask this question, make sure to mention this. Moving to question number 22, it states, what are some of the properties of clustering algorithms, right? Well, clustering algorithm, whenever you have it implemented, will have a lot of properties, but then these are the main ones. So you have the flat or the hierarchical property. It can be iterative, it's going to be disjunctive, and a lot more. So when you're thinking about clustering algorithms, do talk about how these foundational concepts of it being flat or hierarchical, it being iterative to make sure that you arrive at a solution, or it being disjunctive, which definitely defines how clustering algorithms work effectively to split out data into clusters and make use of it as well. Coming on to question number 23, it states, what is collaborative filtering? Well, collaborative filtering is a very important concept. It's an algorithm which is widely used in the field of data analytics to create recommendation systems. So recommendation systems is used to understand the behavioral data of a customer, or in fact to understand what the data is doing and why it is doing something the way it is doing as well. So when you can think about it, when you're shopping on an e-commerce site, maybe like Amazon or Flipkart or something, you will be shown recommendations, right? So users who bought this also bought this. So when you think about that, that's a recommendation given to you. And in fact, collaborative filtering is used just for this purpose as well. So it'll be using a lot of data. It'll be using cookies data, browser history, and there are very complex methodologies, there are very complex models and algorithms put into place to recommend the best products out to you. And the working of that is achieved through collaborative filtering. Coming to question number 24, it says, what are the types of hypothesis testing used today? There's 3 main types of hypothesis testing which gets the center stage again, right? So in fact, there's many types of hypothesis testing, but these are the important ones. The first will always be ANOVA, or what we call as analysis of variance, because here we try to perform analysis in between the mean values of multiple groups to see how data is changing. The second thing we call as the t-test. The t-test is actually used wherever standard deviation is unknown to us, and let's say the sample size is pretty less as well. Again, we'll have another question discussing about t-test. And the next thing is the chi-square test, or also called as the chi-square test. You can pronounce it both ways. So what we do with the chi-square test is that we try to use hypothesis testing here to find if there is a requirement, find what's the association of the categorical variables in a sample, and to see how best we can arrive at the goal of our model as well. So when you're thinking about hypothesis testing, make sure to talk about 3 or let's say even 4 types of testing, and quickly briefly talk about what they do as well. Coming to question number 25, it says, what are some of the data validation methodologies used in data analysis? Well, there's many data validation techniques as we've been discussing for a while now, and these 4 are very important. The first thing is field level validation. Field level validation is we try to validate every single field where data is present to make sure that there is no errors, let's say because a user might have entered it wrong, and any other redundancy which would have caused the wrong data to be in the wrong place as well. So form level validation is done when the user works with the form, but then before saving the information, if there's any changes that's been made, we need to keep a track of that as well. And then we have data saving validation. Data saving validation will take place when the file, let's say, or even the database record is being saved as well. So whenever it's being saved, there's a change of state. To analyze that, we perform this validation. And then we have the search criteria validation. Here we're trying to see if the valid results can be returned or not whenever the user asks for it, or whenever the user is going through the data set, summarizing it, or even driving results out of it as well. So these are some of the very important data validation methodologies that are widely used by data analysts across the globe. Coming to question number 26, it states, what is k-means algorithm? K-means algorithm is a very popular algorithm that we use to cluster data into multiple data sets, or in fact cluster data into multiple clusters as well. So each of these clusters will consist of similar data, and the name k-means comes from k actually being the number of clusters that we required. If k is equal to 5, it means that our k-means algorithm is going to divide the data set into 5 different clusters. So to use this, you will require a good amount of experience. It's very simple to use though, but then to achieve really effective results, it requires experience to work with k-means, and of course to know how many clusters you want. And since you'll be working with the data which is unsupervised in nature, you will not have any sort of labels that guide and show what the data is as well. So working with k-means can get finicky at times, but then it's really fun and it's really effective too. Coming to question number 27, it states, what is the difference between the concepts of recall and true positive rate? Well, this is a very tricky question. I'll tell you why. Because recall and true positive rates are literally the same thing. So recall and true positive rates are exactly the same. And whenever we try to think about the formula of either recall or true positive rate, right, it's basically true positive divided by the true positive value and the probability of the false negative value too. So it's TP divided by TP plus FN. It's the actual formula for recall, and it's a very simple question with a very straightforward answer. Coming to question number 28, it says, what are the ideal situations in which a t-test or a z-test can be used? We have one very simple practice that we follow that's become standardized in fact right now. A t-test will be used if your sample size is less than 30, and a z-test will be used if your sample size exceeds 30 in many cases. So a pretty neat trick to remember this is that t is less than z, so t can be used whenever you use a sample size less than 30. Z is at the end of the alphabet spectrum, and it means that your data is exceeding certain cases, right? So that's a pretty simple way in case if you have not had any experiences working with z-test and the t-test as well. Coming to the 29th question, it states, why is naive bias called as naive? Well, whenever we think about naive bias, right, we don't know why it might be called naive, because this is a very tricky question. It gets asked a lot just to see if you actually know the answer or not. Well, it's called naive because it actually makes the general assumptions that everything present in your data is important and it is independent of each other. Thinking this always as a human being, it can be naive because your data is different. It is sometimes dependent on each other. It will not always be independent. Not all the data is important as well, right? So to know all of this, your model will not understand that. It will just say everything is important and everything is independent. So this is not true. It will not hold in a real world scenario, and that is the reason we call naive bias as naive bias. Coming to the 30th question, it states, what is the simple difference between standardized and unstandardized coefficients? As the name suggests, whenever we talk about standardized coefficients, we're trying to interpret all the results based on the standard deviation values. When it's unstandardized, it means that we're trying to use the actual value of the data rather than the standard deviation results. So if you're considering the standard deviation values, it's the standardized coefficients. If you're considering the actual data that is present and not the standard deviation value, then it's unstandardized. Pretty simple question, pretty straightforward answer. Coming to the 31st question, it says, how are outliers detected, right? There are many methodologies that we make use of whenever we are detecting outliers. It is very important to remove them in most of the cases. But then, out of all of these methods that exist, we have two very important methods. One's the standard deviation method, the other one is the box plot method. In the standard deviation method, what we try to do is the value itself will actually be considered as an outlier if the value is either lower or higher than 3 standard deviations from the mean value. So we'll find the mean value, you'll get to know the standard deviation. If the value is 3 times higher or lower than the standard deviation value, it means that it deviates too much from the data and that it is an outlier. And then we have the box plot model. Box plot model is the most popular way of how you can find out outliers, because here we try to find the interquartile range, or what we call as the IQR. And if your data is to be considered as an outlier, it means it has to be either 1.5 times more or 1.5 times less than the mean in the interquartile range. If that's the case, then of course your data is considered as an outlier. Coming to question number 32, which states, why is KNN preferred when determining missing numbers in data? KNN, as we've already discussed, it's called K nearest neighbors algorithm. It's a very famous one that's used a lot, and we now know why it's called that. But why is it used when you're determining missing numbers? It's because it has the capability to approximate a value based on other values that are present very close to it as well. It can easily approximate these values, and hence it finds a very important place in the world of determining missing numbers present in our data as well. So coming to question number 33, it states, how can one handle suspicious or missing data in a dataset while performing analysis? You can think about this in a lot of ways, because when you're thinking about any sort of data, there will be discrepancies in it. So to handle all of these, what we try to do is we create validation reports where we discuss the data in detail to make sure that most of it is right at least. And then we escalate the data or this is suspicion to our superiors or experienced data analysts to have a look at it and then take a call about it. So we try to replace the data which might be old and invalid as well. We try to make it valid. We try to put in the latest up-to-date data to see if it fixes it, and we can go on to use the many strategies that we have in the world of data analysis to find the missing values, use approximation to put in the values to see what fits best to perform analysis, trial and error, and whatever is required to handle either missing data or suspicious data as well. Coming to the 34th question, it states, what is the simple difference between PCA and FA? PCA stands for principal component analysis and FA stands for factor analysis. Among all the many differences that lie in between them, one major difference between principal component analysis and the factor analysis is the fact that factor analysis is actually used to specify and work with variance that exists in between the variables, right? So whenever we're working with the major difference, what we're trying to do with PCA is we're trying to use the variance that exists in between variables, but then with PCA, it's a little different. With PCA, what we try to do is we try to explain the covariance that exists between the components. So factor analysis deals with variance, principal component analysis deals with covariance. This is probably the biggest difference that lies in between principal component analysis and factor analysis. Now moving on to the 35th question, it says, how is it beneficial to make use of version controlling? Version controlling is very important, and it provides you a lot of advantages, right? One thing is that it will give you a structured pipeline where you can compare all the files, identify a lot of differences, merge if any changes are done in a very structured and a convenient way where you can track it as well. Because here you can track the life cycle of any sort of application building with every stage of its build, be it development, be it production, be it testing, be it verification. You can actually track all of these too. And then when you're thinking about how it will bring together a good way to establish, let's say a collaborative work culture in the company, then yes, a version controlling system will do just that. And then when you're thinking about making sure that with every release of your version, the security of your code, the safety of it, the variety of it, and the veracity of it as well, right? So to keep it secure, keep it safe, a version controlling system will definitely help. Coming to the 36th question, it states, what are the future trends in data analysis? Well, if you ask this question, what the interviewer here is trying to do is he or she is trying to assess your grip on the subject and how much research have you actually done into the future of data analysis, right? So to answer this, make sure you can state good number of facts and respective validation for those facts, of course, for all the sources that you have used. To add a lot of positivity to your candidature, because at the end of the day, they're trying to understand how in depth experience you might have in data analysis, or how in depth of a passion do you have for data analysis as well. Try to explain how data analysis will have a huge impact on businesses today. In fact, talk about how it is already revolutionizing the world around us, how it will revolutionize the future trends as well, and how it is showing nothing but immense potential too. If you have facts, if you have statistics, if you have experience, if you have to talk about new tools, new techniques, new ways that data analysis will help, please do talk about all of these. Coming to question number 37, it states, why are you applying for the data analyst role in our company? Well, with this question, the interviewer wants you to convince them basically regarding why you think you are proficient in the subject, how well can you handle data analysis, how well can you work in a production environment, how best can you be fit as a team player, all of these things as well. So to answer this in a very, very, nice way, first thing you have to do is you need to know the job description in detail. You need to know what they're expecting of you to see if you can deliver that or not. Because once you understand the details of what the company does, what the job description is, what your team does, where you will be fit into the organization, you will of course find the best way to understand why you need to do it. You might have a passion for data analyst, you might have a genuine interest to build your career there. Let's say you have a very keen interest on working with data and to solve problems using that too. Well then, you can have multiple reasons, and there is no one answer for all the questions here. So this question completely depends on you, but then you can use this as a guide to go on to answer it. Coming to the 38th question, it states, can you rate yourself on a scale of 1 to 10 depending on your proficiency in data analysis? This is another question the interviewer will usually ask to see how confident you are when you're sitting at the interview, how much you know about the subject, and how spontaneous can you be whenever you ask questions, right? So one very important thing that you need to understand here is that answer it honestly. Do not be over optimistic, right? So if you think you on a scale of 1 to 10 you are at a 7, please make sure not to say 9, 9.5 or 10, because if you're answering it that way, then you might be asked very, very difficult questions or advanced questions which might be over the scope of your expertise, which might put the wrong image into the interviewer's head, and you might lose out on the candidature as well. So to be as honest as possible, talk about what you've done and talk about why you rate yourself at that particular scale as well. Coming to question number 39, it states, has your college degree helped you with data analysis anyway? Well, talk about the latest program that you completed in college, right? So you firstly start your answer with this. Talk about if your college actually helped you with data analysis anyway. Don't say no if you haven't had any experiences there, because see, if you are in fact enrolled in a college degree, you will have access to a lot of data that in fact you could have used to perform data analysis as well. So talk about if you've been keen to do it, if you have done anything to the data, anything with respect to data analysis in the past, or let's say if you have not done any of these, right? Talk about the experience that the entire college degree program gave you and how you think it built you in a way where you can be a good fit into data analysis, into the entire field and the organization that you're applying as for as well. So talk about how it molded you into being the data analyst enthusiast that you are today. Coming to the 40th question, it states, what is your plan after joining for this data analyst role? So again, do not be carried away by this question. It is very, very easy to get carried away here, and you can talk about it for a lot of minutes. But then keep it as concise as possible. This is my advice to you, because you can talk about a lot of things here, but start out with talking about a plan on how you can begin understanding the data analysis structure set that is already set up in the company, how you think you will be a good fit there, how you plan on either seeing if the actual existing model might need some betterment or not. But at the end of the day, don't just say that you're gonna barge in and do a lot of changes in a short amount of time. Keep your answer structured. Keep your answer taking in consideration that you'll be going into a production environment, and it's always vital if you can highlight how better you can make the product, the company, the brand, or whatever it is, with you being there as well. So talk about the expertise that you bring to the table and how you think that might help the organization too. Coming to the 41st question, it states, what are the disadvantages of data analytics? So even though the advantages are huge, right, there are one or two disadvantages that you will have to talk about. And if you do not know this, and it is very important that you know this as well, right? See, data analytics can actually cause a breach into the customer privacy and all of their information as well, right? So it's very vital to know where you're getting the data from. You might be thinking about customer transactions, purchases, subscriptions, and you will have a lot of access into what this customer is doing as well. In that particular case, make sure that you do not cause any sort of breaches in customer privacy. And then when you're thinking about another very important disadvantage as a learner, is that some of these tools are really complex to use and you will require training to go on to use it as well. So it's not as easy as you download the tool, install it, and begin working with it. You will require a good amount of structured training and to work with it efficiently as well. And one of the other things is that it'll take a lot of skill, it'll take a lot of expertise, it'll take a lot of hands-on experience to go on to select the right tool itself. First of all, to find the right tool to use it and to use it effectively, it's going to take a lot of time, it's going to take some money, and of course it's going to take the biggest asset of the company is the client's time too. So in that particular case, even though these are not huge disadvantages, the privacy thing is definitely one disadvantage to consider. Complexity of the tools are important, and of course the requirement for a lot of skills can get overwhelming for beginners as well. So as an add up question to that, you might be asked, what skills should a successful data analyst possess? Well, this is basically a descriptive question because here the interviewer wants to understand how your analytical skills are and how your thinking skills are, right? See, there are many tools and skills that a data analyst must have. Think about programming languages, right? You'll require expertise in Python, you'll require expertise in R, SAS, concepts of probability, details of statistics, regression, correlation, and many other skills that a good data analyst should possess. How much of experience should he or she possess? Well, that depends on how long this person has been into data analysis, right? But then it is vital that you know what skills are required. What skills are used by professional data analysts. You might have some experts or let's say famous data analysts out there that you might be looking up to. So it's very vital you to understand all of that and answer this question in an effective way as well. Coming to the 43rd question, it states, why do you think that you are the right fit for this data analyst role? Again, if you're being asked this question, it means that the interviewer wants to understand if you are the right fit for the job description, number one. Number two, why do you think data analysis is for you? And number three, what knowledge do you have in data analysis to actually fit into their organization well? So one thing again, a very important note is that do not get carried away because you can answer this for 20-25 minutes straight, but keep it very small, keep it concise, keep it detailed, and just talk about your passion, talk about your interest, talk about your goals and how much these goals and passions will match the company's substructure and their goals as well. See, every company will have a vision and a mission, and if you can commit to the vision and the mission of that company and better either the better the product that they deliver or better the brand itself, then of course you will be the right fit for the table, right? So taking a product from one place into another place, which is definitely better, and you can prove it with numbers. In the case of data analysis, it is very important you know how you are the right fit for the role as well. Question number 44. It says, can you please talk about your past data analysis work? Well, you might be asked this even though you're a fresher. You might be asked this even if you're an experienced candidate as well. If you're a fresher, then do talk about how you've either figured out there are problems that exist in the world of data analytics. So if you're a fresher, do talk about how you might have performed very simple analytics as well, right? So think about how many people could have how many guests that come into your place. Find a structured way on calculating that and why you think that's the case. Talk about how many people buy a certain product in your supermarket. There can be many things that you might not have officially done on paper, but your brain would have analyzed it, right? Talk about that. But then if you actually have a certification program, you would have worked on, in fact, a good certification program, you would have worked on a lot of industry level projects as well, use cases too. Talk about that. And of course, if you're an experienced person attending a data analysis interview, talk about your previous company, talk about what you did to the company, what value you added, what problems you solved, and how better was the team when you left, compared to when you were joining as well, right? So talk about a lot of these insights, talk about your debating skills, talk about how you can think out of the box, how good you are with your statistical skills, and of course how much of a team player you were in the past, and how that has continued as well. So let's talk about a behavioral question now. Question number 45 states, can you please explain how would you estimate the number of visitors to the Taj Mahal in November of 2019? Well, this question does not expect you to say the exact number of number of visitors Taj Mahal got in November 2019, but then here people are trying to see your thought process without you making use of a data set, without you making use of a computer, to see how you would approach the problem, right? So here's a very good template that you can use. First, you would begin by gathering some data, right? So to do that, you will have to understand a lot of things. You will need to know the population of Agra, where the Taj Mahal is located, how people can move in and out of Agra, how convenient is it, and a lot more. The next thing you'll be looking at is the number of tourists that come to Agra, right? And how popular is Taj Mahal itself in Agra. So with all of these, you will find the average stay of these tourists that come. You can analyze it in detail. For example, the age of the people who come, the gender, the annual income that they have, the number of vacation days that they take, the number of bank holidays that exist in India, and all of that. The number of days Taj Mahal is closed, the number of days it's open, the number of days it records the highest number of visits, and all of these. Once you have gathered all of these data, you will go on to perform statistical analysis on it to understand how many visitors it has got as well. And if you want to perform even advanced analysis, you can go to the local tourist offices to gather all sorts of data, process it on your own, and eventually use it to verify if your model is right or not as well. So this is a classic behavioral question, and it's not just the Taj Mahal, it's not just the date. This question can be asked in many different ways. For example, how many cars were sold in India in, let's say, the last month or the last year as well. So that's another very common question that's asked. And whenever you ask this, make sure to take this kind of an approach, use the template, and think about it for a second. Take 1 or 2 minutes to think about it. There is no hurry when you're answering this question. Coming to question number 46, it says, do you have any experience working in the same industry as ours before? Well, as you might already know it, a data analyst will fit into a lot of domains, right? Even in the field of medicine, even in the field of social media, be it whatever it is. A data analyst is required if there's a business, as simple as that. So if you've worked in the same industry as the company that you're applying for now, do talk about how you've used your skills to polish yourself into that industry and how best you brought yourself out of it. If you do not have worked in the same experiences, don't just say no. Talk about what you think are the skills that are needed for this industry and how you're working on yourself to come to that particular spot as well, right? So it's very important that you talk about how you're building yourself towards working in this industry, your interests, your passions, and if you've had experience, of course, do talk about that and thoroughly explain it. Thoroughly explain all of the skills that you might have used, techniques, tools, and how you've benefited the past company that exists in the same industry as well. Coming to question number 47, it says, how good are you in explaining technical content to a non-technical audience with respect to data analysis? See, your ability to explain a technical content to a non-technical audience has to be one of the most important things that you'll do as a data analyst, because your communication skills are very vital. It's not just delivering technical content, it's your ability to have patience, it's your ability to break complex things into simpler, it is your ability to break up complex things into simpler things where you can explain it to an audience who might be your board members, stakeholders, or some other non-technical audience as well. So if you've had any experiences of situations where you had to explain technical concepts and break it down to a non-technical audience, make sure to talk about that. Talk about how well versed you are, how effective that you have been in delivering content before as well. So this question again is a question where I cannot give you one answer for each and every one of you, but then you yourself give it a thought for 15-20 minutes and you will get the best way on how you can answer it. Coming to question number 48, it says, what tools do you prefer to use in various phases of development? Again, this is a question that's asked to check what all the tools that you have used, how you have used it, and how best do you think a tool will fit into that particular task as well. So if you have used any or all of the tools that's involved in data analysis, talk about it. Talk about how comfortable you were in using these tools and talk about how they're popular as well. See, some of the tools that we discussed in the questions are very popular, right? Talk about how they are popular and why they are popular too. So this will add a lot of value to your candidature. And coming to the 49th question, it states, which step of a data analysis project do you like the most? Well, it's very, very common to have a liking towards one or two tools in the entire process of data analysis, right? See, a data analysis is a vast field. You just cannot have one particular tool where you will do everything with that tool. So you will have multiple tools to do it, and you will have a liking to one particular tool. You might not like the other tools as well, right? So when you're thinking of the entire analytics cycle, it is always vital that you do not talk negatively about any of these tools, because those tools are put into place to do their tasks and they have been doing it well. If you do not like it, well, okay, you do not like it, we understand that, but do talk about what best the tool can do, how it can improve itself to probably making yourself be inclined towards that, or what are the steps that you think can help make the tools better in fact as well. But understand this, when you're answering this question, know that it is okay to have a favorite tool. Know that it is okay to put in more time into one particular tool, because it's your career, it's your interest, it's your liking, and if you think you can be very efficient at using that tool effectively, then be it is okay. And then coming to the last question on these top data analyst interview questions and answers set, it states, have you earned any sort of certification to improve your learning and implementation process, right? See, a good certification program, what it does for you, it's going to give you thorough knowledge, in-depth expertise from top trainers across the globe. It's going to give you a certificate. It's going to give you exposure to potential hirers. It's going to do a lot for you. So if you are involved in a very complex program that has the capability to take you from a beginner all the way to an advanced data analyst, it means it's adding a lot of value to your life. But how should you answer this when you ask this in an interview? See, one thing is that if you have a certification, right, it shows the interviewer that you have interest in advancing your career in this particular field. It shows that it shows that you have strong aspiration to learn, because you've put in your time, you've put in efforts, you've put in money, and all of these, and dedicated it to the world of data analysis, right? So if you're doing all of this, it always adds value to the interviewer as well. And then when you're thinking about how effective learning that you've put into place, see, many certification programs will give you all the theoretical knowledge that exists, but only the good ones will give you really good industry level projects and case studies to work with. So if you have had the experience to actually crack these industry level problems, it means that you have the capability to learn things on your own and be a player in a productive environment as well. So that itself is going to portray a lot of value of you being certified in that domain. And now if you have more than one certification, just go on to list the certifications of what you have done as well. But instead of stating a lot about what you have done, the most value that can be added to your application is to state how you have used this certification, right? So you could have learned a lot of things, but if you have not used that, it will not add any value, right? So what problems have you solved? The entire world of IT came into place because we have problems and we realized we can use computers to solve them. So to how best of your capability and potential have you made use of these certification programs to solve problems that are there, or how do you plan to solve them if you haven't done any as well? Talk about how helpful it's been to you, your career, and how much value it added to your life experiences, to your learning and interests towards data analysis as well.
Just a quick info, guys. Intellipaat offers data analytics course training. Through this course, you will master Power BI, data wrangling, data mining, and much more from the IIT Roorkee faculty and industry experts. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take the first step towards career growth in the field of data analytics.